Oh, hello everyone. Thank you everyone. Uh, how do I get it up? Cool. Hi everyone, good morning. It's great to see everyone here. Thank you all so much for coming. It's 10 a.m. in the morning, second day. I don't expect a crowd, but there's a crowd. It's great. My name is Chi Chuan, or however you pronounce it is fine, but Chi if you can't do it. Today I represent the Starknet Foundation as an ambassador. I work as a developer at Nethermind, but let's not talk about myself, let's talk about the presentation. But the title is Starkpilled with Starknet. Starkpilled basically means that I'm trying to get you to get involved in the ecosystem. So hopefully after this presentation, you get to know a bit more about Starknet and to hopefully build something on Starknet. Okay, let's see, how do I click next? So before I officially begin, I would like to explain about the current status quo of Ethereum. How is Ethereum right nowadays? So I quickly took a screenshot a couple days ago before I was told to submit my slides, and this is how it looked like. As you can see, the blocks in Ethereum comes in every 12 seconds, especially after the merge. And for each block, we have around 140-ish transactions in 12 seconds. And I did a rough calculation that turns out to be around 11 to 12 TPS, and the average gas price is 70 Gwei. And that means that, okay, if you can see Etherscan, it is a gas report page. For a Uniswap swap, if you want to swap tokens, the average price will be around $23 to $25. Okay, if you're trying to transfer coffee money via USDT on the mainnet, it's $7, which is more expensive than a cup of coffee that you are probably buying. You can probably buy 2 or 3 coffees with that fee. And 73 Gwei, to be honest, is not that high as compared to when it goes up in a DeFi summer. It can go up to 100, 1,000, 10x, 20x. So imagine that you're paying $70 to repay your friend for a cup of coffee. That's something that you will not do. So what I'm trying to stress here is that Ethereum suffers from this thing called a scalability issue. That means that the more people using it, the more demand it has, the more expensive it is for you to move things around in Ethereum mainnet. So this begs the question. Ethereum is designed to be a world computer. It's designed to be open. It's designed to be for everyone to use, inclusive. But it's because things get so expensive because of the supply and demand of the gas and block space of Ethereum. It becomes very inaccessible for people to transact or to even perform a simple action on Ethereum. And that beats the purpose. It prices out people like me who do not have enough gas, enough money to pay for the gas price, which is not nice, which is something that Ethereum was created not for this. Ethereum is created for everyone. So well, how do we solve that? So before I move on to that, let's talk about the problem. The problem is that in Ethereum, we have nodes, because blockchain is a decentralized system, and Ethereum is one of the most decentralized blockchain currently we have in the space. So each node is constantly re-executing all the transactions. So that means that if I were to perform a swap, every of the single validators over there are like re-executing my swap. So if we have like 1,000 validators out there, we have 1,000 similar operations, and that is very, very wasteful. So the more transactions in the block, the more wasteful it is, because all 1,000 validators will need to perform that computation over and over again for 1,000 times. Why do we need to do that? Because we do ensure that the state changes, the actions are all accurate. So just in case, if I were to perform a malicious transaction, my transaction will get rejected by everyone, because the only way to do that is that they have to re-execute it to make sure that everything's safe. So that's a problem. So how do we solve that? I have a typo there, by the way. How do we solve that? The first solution that people come up with is that, oh, I will just create another version of Ethereum that is faster. So we have alternate L1 chains. So to do that, what they do is that they increase the block space, reduce the block size, and therefore allows you to accommodate more transactions in a single block in a shorter time. So that leads to an increase of TPS. But the problem that I mentioned before is that everyone, all the validators still will need to execute a transaction. So if I have more transactions to execute in a smaller in a smaller time frame, what is actually happen is that I will need a more expensive machine, right? I can no longer run like 1,000 TPS blocks in a MacBook Pro, for example. My MacBook Pro will crash and would not be happy at me. I will require a server that's hosted on AWS, probably 1 TB RAM or something like that. And that is okay, but if you think about it, it prices out someone else. You price out the validators. You price out the decentralization factor of the participants. So that means that leads to less and less people being able to validate your transaction. And if you were to extrapolate, that means more centralization. So how is that different from our Web2 solutions, such as our banking system, where only the bank is executing all the transactions and we trust that the bank is doing the right job? So again, I personally feel that L1 chain is not the way to do it because it sacrifices one very important factor about blockchain, which is decentralization. So yeah, it's all gimmick. Oh, we have faster TPS now, but at what cost, right? At decentralization. So in my point of view, I'll be very careful here. In my point of view, this is a no-go. So let's look at another solution. The solution number 2, the optimistic approach. So essentially what's going to happen over here on my right, which is further that way, we can see that there is a huge beefy machine what's called a sequencer that's re-executing everything. So we have one sequencer, super strong sequencer, that is re-executing everything. Now the difference of that is that the sequencer will then dump or publish the data to a L1 chain layer, like for example Ethereum, for data availability purposes. And in the optimistic approach, we have people running the fraud prover and always try to contest and to verify if the state changes from the sequencer is done correctly. So if only one party is performing that honestly, you can safely assume that the entire thing is safe. So that's a much better approach because anyone can spin out. Okay, you need a pretty strong machine to spin out a fraud prover, but as long as one party is honest, the entire thing is honest because then the DLA is secured by the Ethereum chain, Ethereum decentralized, and we can rely on that. But the problem is, what happened if no one is running the fraud prover, right? Because it's optimistic. So we always assume that someone will have the incentive to run the fraud prover. So it's secured mostly on economics and game theory. People who run the fraud prover basically have incentive to protect the optimistic chain. For example, if I were to have a protocol on this optimistic chain, it will be of my best interest to run the fraud prover and to secure the chain. So the users basically trust that there are people performing that fraud-proving action. So that's the optimistic approach. The third approach it's called the validity rollup approach. It used to be called ZK rollup approach, but validity is something more accurate because the ZK element is not there. It's very similar to how the optimistic optimistic approach works. Is that there's one huge sequencer that will execute a transaction for everyone. And the difference between that and the optimistic approach is that instead of only the data that's being dumped on layer 1, you have an additional Stark proof. So basically what the layer 1 is doing is that on a smart contract is checking if the proof is correct. So every time you dump the data to the layer 1, a proof is accompanying the data, and if the proof checks out to be correct, the data is then correct, even instantly. So basically, you do not need to rely on economic incentive. You trust on the math and cryptography that the proof is safe, is correct, and with very, very, very high probability, the stage is also correct. So, and this is the approach that Starknet is using, the validity approach. And as a result, what happens? So this happened around 1 or 2 weeks ago. We have seen after the quantum leap. The quantum leap is a term that the Starknet people like to use. After that, Voyager, the Explorer, has recorded 1 to 126 max transits per second. And we can see that the third approach clearly works. This is a living proof that the validative rollup approach is working. So there you go. And this number can only go higher. This number is limited by the amount of users. So if you have more users, this number can get even higher. So there you go. Scalability is coming on Starknet as a result. And it's shown by this diagram as proof. So you may be asking me, like with the different types of validity rollups out there, how is Starknet different from the other ZK validity rollups alternatives? So one thing that I'm very proud to tell you guys is that Starknet has native account traction. I believe that one of the first L2s to have that native account traction. So for those who were in Vitalik's talk yesterday, he was talking about account traction, about the wonderfulness of account traction. For those who are not, I'm just going to walk you through again how it roughly looks like. So you have a signer that owns like a key, like a private key. It can be any kind of private key because again, the verification logic is done on smart contract, and all accounts are smart contracts. So what basically do is that you sign your operation. We don't call it transaction yet. You sign operation, and then you publish it to the sequencer. The sequencer will then call the entry point contract, and the entry point contract will then call the account that is on chain. That account is owned by you. And 2 steps over here. First, it verifies the signature. It verifies that the operation is correctly signed by you, and then it executes a transaction. Now, let me talk about a bit more. So because all smart contracts are programmable, basically the verification stage is something that you can change, right? For example, if you do not like the ECDSA signature scheme, you can change it to something a bit more quantum computing proof. If you can write that in code, you can change that. You can make it to support things like multisig by default. You can change it for account recovery. You can change the key on chain. For example, if you want to change your password, for example, in the current Web 2 world, you send an email, you confirm it, verify it. You can also do the same in an account instruction. You can change your so-called verification key, and after that, you just have to use a new key to sign the transaction. 2FA, social recovery, and all sorts of functionality. Simply because you're able to then program your verification stage to suit any logic that you want. And the execution stage is something that I cannot stress enough. Right now, okay, not right now. One thing that I find super useful is that the ability to perform native multi-calls. Right now in Ethereum or in a lot of these EVM chains, to perform multi-calls are basically to perform many account calls with one transaction. You have to go through like a workaround. The workaround is to use a standard multi-call 3 contract that is being deployed universally on many chains, and there's an effort to kind of like make sure that all the addresses are the same. So you call that contract, and the contract will then have a while loop in there with the call data to make sure that they call the corresponding contract that you want to call. But that is a very hacky way. It basically doesn't work for ERC20 approvals. So it kind of works, but not work entirely. So with native account correction, it works entirely. It works out of box. It works perfect. You don't have to like worry about ERC20 and stuff like that. So this is a simple result of multi-calls. So imagine right now if you were to perform a swap on Uniswap on Ethereum, what will happen if you have not approved the contract before is that first you need to approve it, and the MetaMask will pop out, and then you need to sign it, you need to send transaction to it, and you need to wait for like a couple of minutes, depending on how much gas you pay, depending on the activity of the network. And after you wait for like 2 minutes, and then you can perform the swap. But if you are someone who is like very price sensitive, like that 2 minutes will actually changes like the price, and you may not get the price you had before. So that's poor experience. You need to sign twice, and you need to wait for like a while. But with multi-call, you're able to perform that you perform the approve action and also the swap action all in one transaction. And I would stress that it even improves security as well, because you only approve the amount that you want. Because right now, if in Uniswap you approve maximum, I know that everyone approves maximum, and then you do a swap, but you forgot to unapprove because the approve stage is not in the UI. But with multi-call, what protocol normally does in Starknet is that they approve the amount that they need, they perform the swap, and then they unapprove right after they perform the swap. So basically, you're able to ensure that you're not giving access to anyone, including the contract, to perform swaps on your behalf after the swap. So all 3 of that in one click. How cool is that? And another thing I want to stress about Starknet is something that we are really proud of. We have this Cairo programming language. It's a smart contract language on Starknet. And I know that people have been walking to me like, oh, gee, like, why do I have to learn another new language? Like, and it's very hard to learn, and the syntax changes all the time and stuff like that. But I promise you, it's only getting better from here onwards. So, quick introduction as to what Cairo is. Cairo is a general programming language that allows you to create proof for execution, and the proof is generated very efficiently because Cairo is written with the idea of creating proof efficiently. So unlike languages like Circom, where you have to like write circuits, like Hello 2, which is you need to like change the mental model. You need to change the way you describe a program to like circuits and math. Cairo allows you to write your language as you would normally would in Rust, because the new Rust Cairo syntax is very Rust-like. So you have your reference, you have your ownership and stuff like that, right? So that's something that the Rust world likes, and Cairo also is adopting that in the new Cairo version. And you can use that to write your everyday program. So one example that I would like to point out is the Kakarot ZK EVM. It's written in a short time of like 3 to 4 months, and 3 to 4 months, and it able to cover all opcodes in 3 to 4 months. And that shows how easy it is to write your program in Cairo, because you don't have to change the mental model. You have to like, oh, how do I express this thing in circuits? You know, that part is something that programmers are not used to. So in Cairo, you don't have to do that, and proof is being generated very efficiently. And it's about to get better from here. So if you are a smart contract developer, at least I was, like how do you learn Solidity like back in the days? Remix is a tool that I love, and they're giving talk later. And I'm pretty sure that you use Remix a lot to do simple testing, simple deployment, simple checking, simple compiling, syntax check, and stuff like that. And so the Nethermind team, I was told like 2 days or 3 days ago, they have finished developing the StarkNet Remix. Okay, not finished, but they have announced the StarkNet Remix plugin. And that allows you to use all the Remix functionality that you know and love of to perform all the actions like debugging, testing, learning, and stuff like that. So over here, a simple example of me compiling a very simple contract. And after that, you get to deploy on DevNet or on even Goerli, StarkNet Goerli, mainnet, and you get to interact with that. So with this, I really hope that it will help in onboarding of new devs. And yeah. And Foundry is also something that the Solidity world like a lot. And they have also StarkNet Foundry, by the same team, by the Paradigm team, by Georges and people like that. So if you like Foundry, StarkNet has Foundry too. So no excuse again over there. Yeah. And what's next? Oh, and Open Zeppelin. I know, like, if you want to spin out your like your ERC20, your ERC721, or even like security contract, we rely on Open Zeppelin a lot because we can. Oh, you know, they are like good. They are like templates, some of that. And Open Zeppelin is also building something similar on Cairo. So basically, whatever you know and love of in the Solidity world is coming to StarkNet. So basically, dev tooling is getting much better. And finally, I would stress that the most important tool of all to make a good L2 chain or a chain is Explorers. So we know Etherscan is big in the EVM world. Like everyone in EVM wants to use Etherscan. Like, oh, okay. But StarkNet is not EVM compatible, so we can't use Etherscan. But there are Explorers like this one I'm showing, and there are more than one Explorers, and this is one of the ones I'm showing. So basically, exploring StarkNet, it's going to be like exploring Ethereum. You have your Remix, you have your Foundry, you have your Open Zeppelin, and you have Explorers. Basically, what more can you ask? Of course, you can ask for more, but these are the 4 basic tooling that I would like to introduce, and hopefully they will get excited and get you not afraid to jump onto the space. And there are so many exciting things that's going to come up, right? Like Volition is one of that. So Volition is basically selecting your DA layer. So right now, everything is on mainnet, on the Ethereum layer as for DA. But coming soon right now in the roadmap is that DA allows you to select your DA layer. So some part of the data is being stored in a separate layer, depending, right now it's not being decided yet. So for even greater gas savings. Our fee marketplace coming soon, and this thing called the Layer 3 is a hype that people are building. So basically, you can deploy your instance on StarkNet. So you can rely on StarkNet as your Layer 2, and then you build like your customized Layer 3, depending on your app on StarkNet. So there's an effort to build an open source sequencer called Madara. I encourage you to check it out. That allows you to spin out your own StarkNet instance. And gas abstraction, when I introduced native construction, I did not introduce gas abstraction because it's coming soon. So that allows you to pay for your gas in native tokens. That allows you to not need tokens to pay for transactions and all those good UX stuff. And finally, the big elephant in the room, sequences are centralized, and that gives us censorship problems, that gives us like MEV problems. And StarkNet is big on in the research of decentralizing of sequences. So there's a blog post on the StarkNet community page about decentralizing it. So if you're interested to learn more about it, I encourage you to go there. So get Starkpool now. So for those who really want to get on board onto StarkNet really quickly, you have Solidity by example. So similarly, you have StarkNet by example. It's signed by example.voyager online, and I quickly include a QR code just in case you want to scan it. This is a good place for you to learn about syntax. You can copy and paste the code using a remix, deploy a remix, play around with it, and get familiar with the syntax. It's not that hard, trust me. So I will leave it out there because there are people who want to scan. Real quick. Cool, I believe everyone scanned. And finally, that's the end. There are a couple of links that I really want to introduce, but I will not confuse anyone. I will just leave the Twitter link, and from there you can join the Telegram group, you can join the Discord group, and that's all. That's all for me. Thank you. Oh, okay. How much time do I have left? 10 minutes. Okay. Oh, that took too fast. Any questions? Because we have 10 minutes. Cool. If there are no questions, I'm up there hacking. So with this, my Starknet T-shirt. So very happy for you to come talk to me and to know more about Starknet. Thank you so much.
All right. Thank you, Chief, for a detailed intro to Starknet and what's to come for the future. Yeah, I can just leave that.
Oh, okay, cool.
Next, can I invite Jared Watts from Polygon Labs to talk about building full-stack apps on the Polygon ZK EVM? Thank you. You have your mic and the pointer there.
Just wait for Aaron. Is it all good? All good? Okay, sweet. Yeah. Hey, everyone. I'm Jared. I'm going to be talking about building full-stack applications on the Polygon ZK EVM. And obviously, I'll be representing the Polygon Labs team today. So if you don't know me, I am Jared. Currently a developer relations engineer at Polygon. You can find me on Twitter, Lens, LinkedIn, YouTube, wherever you want, really. I'll also be here with my colleague Kevin over the next couple of days. So before I continue, I should shout out our bounties for this hackathon. So some of the topics I'm going to be talking about, specifically the ZK EVM today, we have some bounties available for you builders to actually earn some rewards for using some of the tech that I'm going to be talking about today. So we have 3 bounties total. We have one for Polygon ID, one for the ZK EVM, which I'm going to be talking about today, and then we also have one for public goods. So you could kind of tick off, based on this information, you can kind of tick off 2 boxes for the Polygon ZK EVM and the public good bounties if you want. So if you're interested, talk to Kevin and myself afterwards as well. Awesome. So what we're really going to be talking about today is how Polygon ZK EVM is addressing the main issue of Ethereum today, which is scalability. So in the blockchain world, there's this kind of trilemma that all blockchains face, which is security, decentralization, and scalability. And Ethereum, when we talk about Ethereum, has a strong sense of decentralization and a strong sense of security, but is really lacking in that third prong of that triangle, which is the scalability. And that's kind of what all of Polygon's products are built to address, is really ramping up that scalability aspect of kind of the blockchain trilemma, including what we're talking about today, which is the Polygon ZK EVM. So really what I'm going to structure this talk is we're going to quickly review how the ZK EVM works at a high level. We'll follow a transaction through its full life cycle from being submitted on the Polygon ZK EVM layer 2, how it gets executed in that environment, how state gets sent back to you as a user or a developer, and then kind of in the background, how those transactions are being batched up, sent to Ethereum layer 1, and then how zero-knowledge proofs come into the picture to actually post validity proofs that verify the computational integrity of those batches of transactions on Ethereum. Awesome, yeah. So this is kind of a duplicate of what I just said, but really Polygon ZK EVM, the whole objective is to scale the demands of Ethereum. So developers and users alike have this demand for the unique capabilities that Ethereum offers, like the demand for decentralized storage on the Ethereum network, which is a unique offering of these kind of new blockchain paradigms and innovations that are coming out. So developers want to use the decentralized storage, decentralized compute, and users want to use the decentralized storage and compute for their own kind of unique use cases. But Ethereum today isn't really scalable enough to actually address even what's happening today, let alone what we want to see in the future, which is kind of this mass adoption. And today, this leads to a world where only people who can really afford the super expensive gas fees can even use the Ethereum chain. Okay, so what I'm going to be talking about is the ZK EVM, but how does it even do that, right? How does it scale Ethereum effectively, and why doesn't Ethereum just do that in the first place themselves? So if you've ever seen a ZK EVM diagram before, you've probably seen something like this, and it's probably a little hard to see on this screen in the sun, but essentially what's happening is in this top layer, there's a pool of transactions that come in from users, and it enters into what we call the layer 2. So layer 2 is kind of interchangeable with the Polygon ZK EVM in this case. So users submit their transactions into the transaction pool on the ZK EVM. Those transactions get executed, and they get batched up together into one single transaction, which is a transaction containing a proof that verifies that the batches of transactions that are being submitted are actually correct. So essentially, the scalability comes from being able to execute tens or hundreds or thousands or however many transactions occur on layer 2, batch them all together, submit one single transaction containing all of those transactions, as well as the proof that those transactions are correct, back to Ethereum. So this whole process that we just saw in the previous slide occurs really in 5 kind of different steps. So first one is users actually submitting those transactions. The second one is the layer 2, or the ZK EVM, actually executing those transactions. And after that is kind of the background process where the security of Ethereum is kind of coming into play to say, hey, if you don't trust us at Polygon, here's all of the stuff that we're doing in the background to say, hey, we're able to inherit the security properties to kind of address that blockchain trilemma again, where we inherit the decentralization, inherit the security of Ethereum, but up that scalability aspect. So those 3 steps are the batching of transactions together, sequencing of those batches, and then aggregating those batches. And we'll talk about what all of these words mean. Awesome. So from a user's perspective, really, all you really need to care about is everything looks and feels the same as Ethereum or any of the 900 other EVM compatible chains there are out there. So if you're a user, this looks like submitting or signing transactions that goes through what we call JSON RPC, and this goes into the layer 2. For users, this all looks and feels the exact same, and the awesome part is it all looks and feels the exact same for developers as well. So if you've ever built a smart contract on Ethereum before, you know how to build on Polygon ZK EVM. Everything is going to be the exact same, and there's just some kind of internal differences that some sort of edge cases if you're building some advanced use cases that you need to be concerned about, or not concerned about, but aware of. So for users and developers, everything looks and feels the same. The benefit is that you get much faster speeds and much smaller fees, an order of magnitude smaller. So you can see in this example transaction I have here, I'm just sending ETH to one of my friends. It doesn't look like I'm being very generous. I only sent him 0.0001. But you can see the gas fee is around 0 cents in this case. So very small gas fees compared to what you would see on Ethereum layer 1, which would be around $20 or anywhere in the peak times of like a couple of $100 to actually perform this transaction. So for users and developers, the fees are going to be much smaller, and the speeds to actually achieve that finality from the user's perspective is going to be in a matter of seconds. So much, much faster than Ethereum, which would probably take around a few minutes for the same transaction. Cool, so under the hood, how is this actually happening? So as the user, you kind of see this whole cycle happen in a matter of seconds. But under the hood, we can actually see and break this down into a couple of steps. So the first step here is the transactions go into this pending transactions pool. So you can see in this little box, there's multiple different users have submitted transactions into the same transaction pool. And the sequencer, which is a party that is currently being run by Polygon and is going to be, as we said in the previous talk as well, is working on being decentralized as well. But the sequencer is going to pick up all of these transactions and run a few checks on them. So the checks it might run are, does this user have enough funds to actually execute the transaction? Is this a duplicate transaction? Does this conflict with another transaction you submitted? All these kind of checks to make sure that the transaction will actually go through and doesn't violate any of the rules of kind of the Ethereum ecosystem. So based on those checks, it either executes them or discards them. So just says, hey, this, this is good or this is bad, executes or discards. So once it's done that process, it then does what's called broadcasting. So it broadcasts or sends out the information of what happened to all of the nodes running on the ZK EVM. So it sends out, hey, here's what happened, here's the new information you need to know across the network. And all of this is happening in around a matter of seconds. So from the user's perspective, I just click confirm. All of this happens under the hood in around 3 to 5 seconds, and then the state comes back to me nearly instantly. So from the user's perspective again, this would look like transaction approved and confirmed, or transaction rejected. Great, so actually before I continue, what I wanted to say was this is kind of the end of the line for users that you don't really need to care about what's actually happening under the hood, except for one use case. So once you've made the jump to Ethereum layer 2, you actually don't need to care about any of the stuff that I'm going to talk about next, unless you want to withdraw your funds back to Ethereum. So as a user, you can actually just live in the layer 2, right? You can use and interact with applications that are built using the ZK EVM. And once you've made that jump to once you've made the jump to the Polygon ZK EVM, the only time you need to care about the next 3 steps that are happening under the hood is if you want to withdraw your funds or pull them out back from the layer 2 to Ethereum layer 1. And that's what's happening in the background. One other note is the next 3 steps that we're going to talk about is important if you don't trust Polygon. So if you don't trust me or you don't trust Kevin, we're going to post all of the information back to Ethereum to say, hey, if you don't trust us, we're going to send everything over to Ethereum. So if you trust Ethereum, then you should be able to trust what we're doing in the background. And in around an hour, you'll have a validity proof posted that proves that what we performed on the layer 2 is accurate. Awesome. So once the sequencer has done that full process of executing and broadcasting the transactions, the sequencer is going to batch them up and send them to layer 1. Now, if layer 1 is this kind of mystery word in your mind, what I'm talking about in this case is part of the Polygon ZK EVM that is deployed to layer 1, which is literally just a smart contract called Polygon ZK EVM deployed to Ethereum. So it's basically calling a function on a smart contract on Ethereum. Now, how does it actually do this? How does it take all of those transactions and format them in a way so that it can actually transmit them to Ethereum? So what it does is, if you've ever seen a transaction before, I'm assuming most of you have, it contains things like who the transaction came from, who the transaction's going to, what data is in that transaction, what functions it's calling, all of this information. And we need to somehow get it in a format that the layer 1 or the smart contract deployed to Ethereum can actually understand. So highlighted in this little purple circle here is the transactions field of this struct called batch data. Now, if you don't know what a struct is, it's essentially a way of structuring data on a smart contract written in Solidity. So in this particular field, there's a transactions field that is of type bytes. So essentially what we need to do is take all of that transaction data, like who it came from, who it's going to, what functions it's calling, format it into bytes. And the way that we do that is a kind of 2-step process. So the first step is called serialization. And in the brackets here, I just have RLP, which is a particular kind of serialization process that we use called recursive length prefix serialization. And then the second step is to concatenate them, which is just a fancy word for stick them all together. So essentially, we take the transactions, convert them into bytes, and then just stick them all together. That's essentially the 2-step process. So here's a little bit more detail of that same slide. So the sequencer, it's executed all these transactions. So if you remember, the sequencer took them from the transactions pool, said, hey, is this valid or not? Either executed or discarded them. So at this point, we have a bunch of executed transactions that we need to batch in the background and send to Ethereum layer 1 in this particular struct format on the right-hand side here. So the way that we do that is we take the transactions, run them through that serialization process. So each transaction is going to get converted into bytes here. And once we have all of those different bytes, all we do is we just stick them all together. So we just have bytes 1, bytes 2, bytes 3, bytes 4, representing all of the serialized transactions. Now we just have one big long byte that contains many transactions. And this happens many times. So this slide kind of represents that full process that we just saw on the previous slide, happening many times, many times, many times. And we want to jam as many batches as we can into a single transaction. And I believe in the current state of Polygon ZK EVM, you can have around 1,000 batches sent in one transaction. So that's not 1,000 transactions, that's 1,000 batches of transactions. And it's probably pretty small to see, but this slide represents the thousands of batches, or 1,000 batches, or however many batches we cram together into what actually happens with those batches. So now we have all of these batches. We need to send them to a function on Ethereum Layer 1 smart contract. So it's kind of hard to see, but on the right-hand side here, what's happening is the sequencer is calling a function on the Ethereum Layer 1 smart contract, the Polygon ZK EVM smart contract. What it's calling is a function called sequence batches. And in the very right bottom corner here, you can actually see, we'll zoom in a second as well, so you'll be able to see it. But what it's calling that function with is all of those transactions, or the batches that we just created. So we'll zoom in here. So here you can see, in this particular case, there was 52 batches that got called in this particular example of the sequence batches function. So we created that full process 52 times. And then you can actually see all of the transactions that got crammed into each batch. So this picture shows, here's one example batch of this one particular sequence batches call containing all of the concatenated serialized transactions. Okay, so now we're gonna kind of take a step back and see kind of what we were talking about when I was saying, hey, if you don't trust Polygon, here's where we actually verify what's happening on the Ethereum Layer 1. So we're gonna talk about the 3 different types of finality in a Polygon ZK EVM. So if you recall one of our earlier slides, we said everything looks and feels the same as Ethereum, except there's instant speeds and very cheap fees. So in that first phase, as soon as you got that back in a matter of seconds, we were in what's called a trusted state. So it's called a kind of trusted state because if you trust Polygon, then you can trust the state of the Polygon ZK EVM chain and continue living in that layer 2 world. So once we were in a trusted state, we then in the background said, hey, some people are not going to trust Polygon to give you this data availability. So if you want to, we're going to perform these new 2 steps of finality to say, we're going to send all of the batches over, which is what we just saw. So we batched all of the transactions together, shipped them off to Ethereum. So now we're in what's called a virtual state. Virtual means we have all of the transactions batched up and available on Ethereum. However, those transactions are not necessarily correct, right? They're not necessarily valid. So this is where zero-knowledge proofs come into play, where we're going to actually reach a consolidated state where we've proven that the batches of transactions that got sent are actually correct and valid. Awesome, so this slide is kind of introducing a new player into the mix, which is called the aggregator. The aggregator is going to take the batches that we just sent over to Ethereum, and it's going to send them to what's called a ZK prover. And the ZK prover, as the name suggests, is going to generate ZK proofs, or zero-knowledge proofs, in the form of multiple ZK stocks, which are kind of, if you're not familiar with ZK stocks, they are a bigger and more secure way of zero-knowledge proving something. And those get transformed into a single snark, which is a much smaller version of the zero-knowledge proof than the ZK stock. So it creates multiple ZK proofs in a kind of large and secure manner, and it creates one single smaller proof that gets sent back to the aggregator. So essentially what this slide says is, hey, I'm the aggregator, I'm gonna take the batches, ship them off to the ZK prover, and in return, I'm going to get a ZK proof that I can send to prove those batches that we saw on Ethereum. Yeah, so this is essentially the role of the aggregator, is it takes the batches, generates the validity proof, or the zero-knowledge proof, sends them to Polygon ZK EVM smart contract on layer 1. Cool, so the way that it does this, again, we're kind of zooming into a function on the Polygon ZK EVM smart contract. This function is called verify batches. In this case, it's called verify batches from the trusted aggregator, which is the party that is calling this function. So highlighted in this purple circle here, you can actually literally just see there's a field called proof, where we're going to post that zero knowledge proof to prove the validity of the batches. So in this slide, we can see an example function call from the trusted aggregator to the Polygon ZK AVM smart contract. And the function it's calling again is verify batches. So what it does is it calls this function, provides the zero knowledge proof that it received from the ZK prover. And then once it runs this function, within that verify batches function is this block of code where we actually just say, hey, roll up verify a smart contract, run this verify proof function, and give it the proof that we just sent. So essentially what this does is it takes the proof that the aggregator submitted, says, hey, is this actually correct on Ethereum layer 1? So we're using the Ethereum execution environment to say, hey, let's actually verify using Ethereum, using all of the decentralization and security of Ethereum to run this verify proof function to say, is the proof that got submitted that proves the computational integrity of the batches actually valid? And if it's not, we're going to revert and say that is an invalid proof, and the batch, or the proof, sorry, will not be accepted. And here is, I've just kind of highlighted the gas used by this whole function call. So the function to actually verify the batches that got submitted took around 350,000 gas. And this is thanks to the ZK snark, which one of those letters in that acronym means succinct. So it's a very small zero knowledge proof. And in comparison, if we were using ZK snarks, it would be around 5 million gas. So that's the reason we're using a ZK snark called Flonk. Okay, so now for all of the hackathon builders, I wanted to show you some of the ways you can actually use the Polygon ZK EVM. And it's very brief here. It's going to be 1 or 2 slides because everything is kind of looks and feels the same as Ethereum. So if you've ever used Solidity, if you've ever used Ethereum, if you use MetaMask, all of the developer tools that you're familiar with, you're literally just going to use the same tools but point to a new blockchain. So if you want to build on the Polygon ZK EVM mainnet, the first step you need to do is just bridge funds across from Ethereum to Polygon. However, most of you, I assume, are first going to use the testnet, hopefully, to use some dummy funds. So the way that you do that is you head to our faucet, faucet.polygon.technology, and we'll actually just send you some ETH on the Polygon ZK EVM for free that you can deploy some smart contracts with, run some functions, and test your projects with. So essentially all you need to do is change one line of code in your project. So if you're building smart contracts, instead of deploying to Ethereum URL, you just deploy to the Polygon ZK EVM URL instead. Everything will look and feel and behave the same way as you expect with your Ethereum development environment. So you can use tools like Remix, you can use tools like Hardhat. All of the tools that you know and love in the Solidity and the EVM world will work with the Polygon ZK EVM. One final thing I wanted to show you is a project that I've been kind of creating over the past couple of months, which is a full stack development framework called EVM Kit. And EVM Kit will allow you to spin up a full stack project with a smart contract environment in Hardhat and a front-end application using Next.js and TypeScript, all of the kind of modern tools that you know and love in the full stack development space. So that is just evmkit.com, and you can easily change 1 or 2 lines of code, again, as we saw in the previous slide, to configure your full stack application on the Polygon ZK EVM, or any EVM chain, such as Polygon POS as well, and all of the amazing other EVM chains that we have represented here today. Cool, so that is it for the presentation. I think we have a little bit of time for some questions if we want to, but yeah, I'll shout out the bounties once more. So we have a 1 ETH bounty for the most innovative project built on the Polygon ZK EVM, and hopefully you just saw how easy it is to actually go ahead and deploy your project to that environment as well. So yeah, thank you for listening, and Kevin and I will be available to chat about it as well.
No questions?
Easy.
All right. Thank you.
Thank you.
Thanks. I'll just leave it there. Thank you, Jared, once more for explaining about the Polygon ZK EVM. Before we move on to the next session, just a brief reminder that at 2 p.m. today we'll have a yoga session. So I'll further notify about the details and the venue for the yoga session later on. Sorry? Yes, a yoga session later at 2 p.m. Yep. So please look forward to that as well. And next, I'd like to invite Rob Stupe and Do-Hyung Lim to introduce the Remix project.
네, 안녕하세요. 저는 DSRV 웰던 스튜디오의 리드 엔지니어 현수영입니다. 오늘 그 이더리움 재단 리믹스 팀의 요청으로 저희 웰던 스튜디오 팀이 리믹스 팀과 함께 리믹스 아이디와 멀티체인의 미래에 대해서 발표를 하게 되었는데요. 리믹스 팀의 발표에 앞서서 저희가 어떤 식으로 협업을 하고 있는지 그 맥락을 잠시 말씀드리도록 하겠습니다. 저희 DSRV는 다양한 프로토콜들을 다루고 있는데요. 저희 웰던 스튜디오도 마찬가지로 다양한 멀티체인 생태계에서 필요한 서비스나 도구들을 개발해서 제공을 하고 있습니다. 네, 그중 하나가 웰던 월렛인데요. 네, 보시는 것처럼 다양한 하나의 니모닉으로 다양한 멀티체인의 계정을 관리할 수 있는 브라우저 익스텐션 월렛입니다. 저희는 이 지갑을 개발하는 과정에서 각기 다른 체인 생태계에서 하나의 목소리를 들을 수 있었는데요. 그건 바로 왜 우리는 리믹스 같은 툴이 없냐라는 것이었습니다. 러스트를 위한, 무브를 위한 리믹스는 왜 없냐라는 것이었는데요. 개발 환경 설정이 필요 없이 웹 환경에서 스마트 컨트랙트를 개발하고 컴파일하고 배포하고 인터랙션 할 수 있는 이런 툴은 특히 초기 개발자 온보딩에 굉장히 중요한 요소이기 때문입니다. 그래서 저희는 멀티체인을 위한 리믹스, 웰던 코드를 개발하였습니다. EVM을 위한 웹 아이디인 리믹스에서 다양한 체인들의 컨트랙트를 개발할 수 있도록 플러그인 형태로 개발을 하였고요. 현재 7개의 체인을 지원 중이며 리믹스 공식 플러그인으로 이제 등록이 되어 있습니다. 네, 이 과정에서 저희는 리믹스 아이디에서 러스트나 무브 랭귀지를 지원할 수 있도록 기여를 하였고요. 그리고 리믹스의 베타 테스트나 GKP 챌린지 등에 지속적으로 참여를 하면서 리믹스 자체 기능 개선에도 함께 노력을 하고 있습니다. 그리고 웰던 코드와 리믹스에 대한 교육 컨텐츠들도 지속적으로 생산을 하고 있고요. 특히 올해 상반기 기준으로 수이 블록체인에 배포된 컨트랙트 중 10%가 이 리믹스 웰던 코드를 통해 배포가 되었습니다. 네, 이런 협업의 핵심 가치는 이더리움 개발자들에게는 멀티체인에 대한 접근성을 높여주고 이제 다른 체인 개발자들에게는 이더리움에 쉽게 진입을 할 수 있게 도움으로써 블록체인 생태계를 확장하고 강화하는 것입니다. 그리고 오늘 이드콘 코리아를 시작으로 내일부터 시작되는 DSR 빌더스 하우스 그리고 11월에 열릴 예정인 데브 커넥트 등의 이벤트에서 저희 웰던 스튜디오와 리믹스 팀이 함께 참여함으로써 저희의 비전에 대해서 계속 함께 알려갈 예정입니다. 네, 이런 협업 속에서 저희 웰던 스튜디오는 리믹스의 기여자에게 수여하는 리믹서라는 지위를 얻게 되었고요. 보시면 여러분들도 리믹스에 참여와 기여를 하시면 이런 NFT를 이제 민팅을 하실 수 있고요. 리믹스는 이더리움 생태계에서 굉장히 중요한 툴입니다. 이더리움은 탄탄한 커뮤니티와 굉장히 성숙한 문화를 바탕으로 중요한 공공재에 대해서 보급과 지원이 굉장히 잘 되어 있는데요. 여러분들은 아실지 모르겠지만 다른 체인들은 이더리움에 비하면 상당히 열악합니다. 그래서 저희 웰던 스튜디오와 리믹스 팀은 리믹스 아이디를 이더리움뿐만 아니라 멀티체인에서 쓸 수 있는 중요한 공공재로서 자리매김할 수 있도록 뜻을 함께 하기로 하였고요. 리믹스를 이더리움과 멀티체인 개발자들을 위한 교류의 장으로 만들어 보기로 하였습니다. 지금까지 짧게 맥락을 말씀드렸고요. 계속해서 리믹스 팀과 웰던 스튜디오 팀의 메인 발표를 이어가도록 하겠습니다. Higher up. Yeah, you can start now.
Oh, okay. Hello, Seoul. In fact, I'm greeting you from yesterday because I'm 12 hours or 13 hours behind you right now. So you're well in advance of me. I'll start my presentation. Just a minute. You go we're gonna go like this. And so as I've been talking to our Remix users, I've realized that there are a lot of remix features that a lot of people don't know about that we have been developing and people aren't using. And so I'd like to give a presentation about a lot of features that are in Remix that you really ought to know about. There are Remix features for every users, for some intermediate devs, and for some advanced devs and project leaders. I assume everything's going right. Because I can't see you guys, so just signal to somebody and they'll let me know if something's not working. So let's go on with the show. Remix features everyone should know about is, well, why don't I just start in? But it's mostly about some basic stuff. Here we go. But first you have to know the layout so you know what I'm talking about. There's the side panel, which is over here, and the main panel, the editor, but it could be other things that go on in here. Here's the console and the terminal and the plugin manager and settings. So know about the settings. And then you got to know how to find plugins documentation. So every side panel plugin has this little caret over here, and if you click it, it opens up, and if you click this book, it'll get you to the documentation of that plugin. And Remix comes with lots of templates, and to get to the templates, you make a new workspace. So here's the hamburger menu next to workspaces. These are the file management tools for that specific workspace. And when you click on the hamburger menu, you get a whole bunch of stuff, but one of them is to create a new workspace. Another one is to clone a repo, which we'll get into shortly. So to choose a template, you can choose default template, or you can choose any of these ERC templates. And then you can also, when you choose opens up an ERC coin template, you get this options for these extra options: burnable, mintable, pausable, and also upgradability. And if you use the UUPS pattern for upgradability, they'll show you more options later. And also you can initialize your workspace as a Git repo and then push to GitHub and share with your people you're working with. So, which brings me to saving files in Remix. Sometimes people have lost their work when the browser crashes really hard. And that's because browser storage, IndexedDB, it's easy and it's pretty good, but if your browser crashes, you can lose everything. So you can push everything to Git or to Git repo and IPFS, or you can use RemixD, which I don't know if everyone knows about, but it's a script that you run on your computer that will share a specific folder on your computer with Remix. Look, this is a workspace that has a Git icon, so you know that this has been Git initialized, this repo. So let's go to RemixD. Hold on, RemixD. So when you go to the workspace, you choose the workspace, you connect to localhost. And then you get this modal, and then you can go through that. It'll tell you how to install remixd. And then, but the command to run remixd is from a terminal, and you go to the directory you want to share, and then you type remixd. And remixd also installs Slither, and we can go into that in the static analysis section a little bit later. So when you go into, when you have a Git initialized repo, workspace, if you click on the bottom down here, you can see all the branches from that repo. And then you can also manage things with this Git operations with dgit, which is another plugin, and you gotta load that in the plugin manager, and then you get dgit, and you can do most of the basic Git operations here. Okay, sorry about the little delay there. You often have to put in your GitHub access token, and you do that in the settings panel of Remix. And so these are the changes that are done in this repo, and if you click one of these files here that has changes in it, then you can get a diff. And if you're just using remixd, then just manage Git on your hard drive and don't bother with dgit. And did you know there are 4 different ways to compile? And you should try all of them because they're, it's good to have different ways to compile. I'm not sure what you like better. I just keep going between all of them. But also there's this arrow in the top of the editor, and that's for it's for compiling, and it will also, if a TypeScript or JavaScript file is the active file in the editor, it's gonna run that file. And did you know there's a large list in the right-click menu of the File Explorer? You can compile here as one of the choices, but there's all this other stuff you can do. So it's good to know what's there. And this menu seems to be expanding as we get more functionality. And in deploy and run, you can fork mainnet and a lot of other nets as well. In fact, any other net. You just need to have the URL of the node and block number. This is for a custom fork. So you can just fork anything. And then you just need to say what block number you're going to start with. More features. Well, we should go into verification and tutorials. So yeah, there are 3 basic ways of verifying contracts in Remix. There's Sourceify, there's Etherscan, and then if you publish your source code onto IPFS, then Sourceify will grab it later on, and it's kind of like a lazy verification. But here's the Sourceify plugin, and there's no API like there is in Etherscan. So you just click the verifier, and then you put the contract name and the address, and you can verify it. And in Etherscan, you put in the API, and then you can verify it. You can also verify proxy contracts, but when you do proxy contracts, you gotta first verify the implementation contract. And then you go back and you click it's a proxy contract, and there's a little bit more functionality to fill in there. This is the lazy way. You click published IPFS and deploy and run, and then as long as you need to have a Pura account to use their IPFS node, and then when it's published to their IPFS node, your source code and metadata, then Sourceify will it's just a monitoring service. It's monitoring all the chains, and it will see a new contract, and then it will verify your contract, and it's full verification. Now, I assume everyone knows about interacting with deployed contract, but just in case you don't, it's the add address, and you just need the contract source code or the ABI. And you gotta you'd compile the source code or just use the ABI, and then you need the address, of course, of the contract, and you have to choose the environment that that the deployed contract is at. Tutorials are in Remix are Learnif. So to get to Learneth, you either go to the plugin manager down here, or you go to down this part of the homepage, and like if you click on the Solidity course, well, here's all the courses. And so if you need to bone up on your Solidity, go there. There's some ERC20 and NFT classes, and some more advanced classes as well. And so, you know, their Solidity course is pretty thorough. It's following the lessons in Solidity by example. And so there are links back to Solidity by example. And so you can kind of use the same examples here and in Solidity by example. And then you can check out the code, and there's some challenges, assignments, and you can check the answer and show the answer. And for all you Spanish speakers of Seoul or Chinese speakers, you can see Learneth in Chinese and Spanish when you choose this brand. Remix is now in simplified Chinese, and maybe we should make a remix. It's now internationalized, so we can talk about getting a Korean version of the Remix UI. And I think we probably should. The docs are that way, and we're translating the docs into multiple languages as well. So getting the docs into Korean shouldn't be that difficult. Autocompletes in the editor you can autocomplete the entire OpenZeppelin library and Uniswap library and anything that's local on your machine. And for importing libraries and dependencies, I mean, you can just use the @ symbol or just use the import statement. And if, like in this case, it's an npm package, and Remix will go out to unpackage and grab it and bring it in. Or you can just use the HTTPS, URL. And if it's a local file, then it's a relative path from here. But you can't select a file in another workspace. And there's this cool technique now where you can, if you check out a verified contract in Etherscan, you can just see this, take the base URL and just switch it to, from etherscan.io, you switch it to remix.ethereum.org, and then it will just open up in Remix with a contract in the editor. There's also the hardhat console.log that you can use in Remix. I think that's in some of the default files, so you can check out how that one works. For intermediate devs, here's some interesting features that compile and run, and also gas reports on the line, and scientific notation, and free functions. Let's take a look. So often it's a problem of, you're coding, and then you gotta spend some time to set the state, and then you code some more, and then you set the state. But you can write a script that will set the state for you, and then you just click a button, run the script, and set the state. But now we have this button in the Solidity compiler where you can compile the script, and then it will run a script that will set the state. And then so it'll bring the contract to where you were when you were coding, and you can see if that solved the problem. And if it didn't, you code a little more, and then you hit set run, compile and run, and then it will go through the script and set the state. And then you can update the script and update your code. So it's a kind of good workflow. And just use it whenever you want, compile and run. But you can also just compile. You don't have to hit compile and run. The transaction recorder is a way underused feature. So it's in the middle of deploy and run, and it'll save your transactions. And then it'll save them as a JSON file. So you can replay them, you can give that JSON file to somebody, and then they can replay them. And here's the gas estimate after compilation. It'll show the gas estimate inline. And for function inputs, you can use scientific notation. And you can run free functions. So you just right-click in the file in the editor, and you can get free functions. Also, you can get all these other features too. It's a Monaco editor, so it's the same editor as in VS Code. Deploy and upgrade. So if you're using the UUPS pattern, you can upgrade a proxy. And when you use the UUPS pattern, you get these additional checkboxes. So when you do this, it'll deploy both the implementation and then the ERC, whatever the 1967 contract. So you got to do 2 transactions, and if you're in the Remix VM, it's instantaneous, one right after the other. But on a public network, you got to approve both transactions. So the first one's got to go through, and then the second one will go through. And then when you're going to interact with the proxy, you got to interact with the proxy. I mean, you get to in the deploy and run deployed contract section, you'll see these 2, but don't interact with your implementation. Interact with the proxy contract. And then when you verify a proxy contract, verify the implementation first, and then you can verify the proxy. This is only done in the Etherscan plugin, not in the Sourceify plugin. And if you got teammates using Hardhat, Truffle, or Foundry, you can you can compile for these tools, and you can deploy using their compilation result. So this is especially true. I mean, you need to have remixd attached, so you're sharing a Hardhat folder. Then you can enable a Hardhat compilation, and yeah, there's a compilation, and a remixd has to be running, and then it's going to make this config file, and so that people working, your teammates on Hardhat, can check out your compilation results. And working the other way, they can compile, and you can grab, or you can compile in Hardhat and then grab it in Remix. That also works with Foundry, and you can see the result. And so that you can deploy from Remix, but do your development work in these other tools if you prefer. Linting. We've updated the static analyzers. So there's the Remix analysis library, there's the solhint, linter, and slither. And slither will only work if you have remixd running. And you can use Remix by default comes with Solidity unit test, but you can also run Mocha tests. And so you just have to run the script. And they're in the scripts folder, some example files. And also, there are more scripts being added, and we're going to be increasing the capacity, increasing sample scripts in Remix. There's already GitHub Actions that you can set up, and there's also, I think I'll get to those later probably, but here's some, yeah, these are the GitHub Actions, and so you can run your unit tests on the GitHub side. And then you can add these other Etherscan scripts to bulk compile in Etherscan, or contract deployer is a kind of interesting one because you can deploy to multiple chains with this script, but have the same URL. I mean, sorry, the same contract address. And you can clean up your, this is right-clicking in the editor, you can clean up your code, and then with format code, and then you can set the, you know, how it's going to look with the JSON file. So for advanced devs and project leaders, you should know your liability, and you can find the health of your, well, let's go to liability. I mean, basically, this is just something that came out of the EU MICA regs that are coming through shortly, but programmers are going to start becoming liable. But that's only if they're going to be deploying the contracts. So you could develop your contracts in whatever, you know, framework you want, and then get the contracts onto Remix, and then have your clients deploy the contracts so the liability is on them and not on you. So then deploying from Remix becomes, because it's so easy, your clients can do it, and it makes them responsible for the project. You can get them a gist and load it via a Remix URL, so that's quite simple to do. Here's an example. You just put the Remix URL with a gist and the gist address name. And there's lots of other location docs about Remix URLs. So you can load Remix with specific plugins already activated. You can load Remix with the tutorial already activated into a certain step in the tutorial. And lastly, there's UML in Remix. So that's important. When you right-click, you can generate UML, and you can get your UML diagrams drawn up. For finding the health, I guess there's not a slide about this, but finding the health of the contract, just go to deploy and run and do the add address, and you can access your contract and check through it. And I think it's an important way to know that your contract's working as you expect. And that's it. Thank you.
안녕하세요. 저는 이제 리믹스 랍에 이어서 발표를 하게 될 임도영이라고 합니다. 저는 이번에 이제 세 번째 이드콘 발표인데요. 첫 번째는 저희가 이제 메타 트랜잭션을 발표를 했었고, 두 번째가 이제 셀로 리믹스 플러그인을 발표를 했었고, 이번에는 이제 어떻게 보니까 멀티체인 리믹스 플러그인에 대해서 발표를 하게 되었습니다. 아무래도 이번에는 저희가 뭐 영지식이 좀 더 많은 발표 주제가 되었는데요. 지금은 이제 저희는 이제 개발자 환경에 대해서 좀 설명을 드리고자 합니다. 이제 개발자 환경이라고 이제 에코시스템에 대해서 간단하게 설명을 드리면은, 그러니까 우리가 뭐 흔히들 말하는 생태계란 어떤 것인가 한번 생각을 해보면은요. 그래가지고 보통 이제 제가 원래는 이게 게임 개발자였기 때문에 뭐 게임 개발 생태계를 보면은 뭐 개발자 생태계 말고도 뭐 스팀이라든지 뭐 플랫폼마다 하나씩 생태계가 있어요. 근데 이건 범용적인 생태계가 아니기 때문에 우리가 흔히들이 말하는 뭐 애플의 생태계라든지, 애플은 뭐 이런 뭐 아이패드, 아이폰, 뭐 애플 TV 뭐 등등이 있겠죠. 그리고 뭐 구글의 생태계도 마찬가지로 뭐 안드로이드 기반의 모바일 이런 것도 있을 거고, 뭐 지메일이라든지 방금 이제 랍이 말한 구글 밋 같은 생태계가 있을 겁니다. 그래서 이거를 한번 공통점을 한번 추려봤어요. 그러니까 뭐 보통 이제 어떤 조직에서 만든 애플이나 구글이 되겠죠. 연속성 있는 제품군에서 이 연속성을 좌우할 수 있는 부분은 어떻게 보면 이제 애플은 애플 아이디가 있을 거고, 구글은 구글 아이디, 지메일 같은 것이 있겠죠. 이걸 사용해서 사용자들에게 향상된 경험을 제공해 주는 것입니다. 그래서 생태계를 벗어나면 굉장히 삶이 불편해지죠. 그리고 옮겨가기도 힘들고요. 애플에서 자기가 만들어 놓은 생태계들이 있는데 구글로 옮겨가기도 힘들고, 뭐 구글에서 쌓아둔 생태계가 있는데 애플로 옮겨가기도 힘들고, 역시 뭐 게임에서도 마찬가지죠. 뭐 리니지라든지 이런 현질했던 게임들의 자산이라든지 그런 인맥 같은 걸 버리고 다른 게임을 시작하기 쉽지 않은 것과 동일합니다. 그래서 이제 그러면 이제 이거를 어떻게 보면 이제 억지로라도 대입을 한번 블록체인의 생태계를 한번 대입을 해보면은요. 어떤 조직이 만든, 보통 이제 어떤 조직이라고 하는 거는 뭐 파운데이션 아니면 파운데이션과 같이 개발하는 뭐 개발팀이 되겠죠. 그 연속성 있는 제품군이라고 하는데 애플이라든지 구글에서의 연속성을 뭐 만들어줄 수 있는 거는 애플 아이디라든지 뭐 구글 아이디가 되는데, 블록체인에서는 아무래도 지갑이 되겠죠. 지갑에서 자기 어드레스가 뭐 애플 아이디라든지 구글 아이디가 되는 것이고요. 그리고 사용자들한테 향상된 경험을 제공해 주는 겁니다. 뭐 저희가 뭐 웹2의 세대다, 이제는 이제 웹3의 세대가 올 것이다라고 해주는, 웹3가 아무래도 웹2보다 뭔가 향상된 경험을 제공해 줄 수 있기 때문에 우리가 이 자리에 있는 것이고요. 그런데 말입니다. 지금 현재의 시점에서 블록체인 생태계를 벗어난다고 해가지고 삶에 불편한 것이 있을까요? 예. 아직은 뭐 미래의 가치를 위해서 투자하는 시기고요. 예, 아직은 꿈이 더 큰 곳입니다. 그렇지만 예, 우리들의 삶의 질을 향상시켜줄 제품이 하나 정도는 있지 않을까 생각을 하고요. 그게 바로 예, 리믹스 아이디 플러그인입니다. 우리는 모두 개발자들이니까요, 일단은. 그래서 예, 블록체인 개발자들에게 블록체인 생태계는 이미 우리의 삶의 한 부분이고요. 예, 그리고 예, 게다가 이더리움은 가장 충실한 생태계를 가지고 있는 블록체인입니다. 그래서 이제 개발자 풀과 개발자 환경 등에서 예, 우리는 이더리움 환경은 굉장히 좋은 환경이라고 제가 얘기를 드릴 수가 있어요. 근데 왜 그렇게 말씀을 드리냐면은 저희가 이제 앞서 말씀드렸던 것처럼 리믹스 플러그인을 가지고 이제 멀티체인 다른 개발자들한테 이런 편의성을 제공해 주고자 우리가 이제 이런 플러그인을 만들고 했던 경험이 왜 발생을 했는지 보여드리면은요. 저희가 이제 개발의 시작은 멀티체인 지갑을 만들기 위해서 맨 처음에 사이너를 만들었어요. 멀티체인 사이너를 만들고 그걸 이제 지갑으로 만들고 그러면서 다른 커뮤니티를 많이 돌아다녔는데 가장 많이 보는 질문들이 왜 우리는 리믹스 아이디 같은 제품이 없느냐, 만들어 달라라고 하는데 사실은 리믹스 아이디도 개발 기간이 굉장히 길었고 그런 개발 기간 동안 굉장히 사용자 친화적으로 발전해 왔던 건데 그거를 순간적으로 따라잡을 수는 없겠죠. 그래서 왜 우리는 리믹스가 없느냐, 아우성이 굉장히 대단하더라고요. 그래서 우리가 만들게 되었습니다. 일단 멀티체인 플러그인을 만들어서 다양한 아까 말씀하셨던 7개의 블록체인을 지금 지원하고 있고 그중에 보셨던 것처럼 뭐 뉴트론, 수이, 앱토스, 주노, 니어, 셀로, 클레이튼 뭐 EVM 계열도 있지만 EVM 계열이 아닌 것들이 더 집중을 하고 있습니다. 뭐 EVM이 아닌 거는 뭐 당연히 다른 체인에서도 다른 체인에서 어차피 지원을 하고 있으니까요. 그리고 역시 플레이가 안 되네요. 네. 그래서 이제 저희가 리믹스 아이디를 이용해서 수익 게임 개발 예제도 만들었습니다. 이거는 저희 웰던 독스 그러니까 독스 웰던 스튜디오 .io에 들어가 보시면은 플레이를 해보실 수도 있고 튜토리얼을 경험해 보실 수 있습니다. 그리고 이제 그래서 상도 받았습니다. 이 상이 바로 이제 다른 블록체인들 멀티체인들에서 저희 체인들을 저희 툴이 얼마나 원하고 있었는지 보여주는 약간 어떻게 보면 증명 같은 거겠죠. 그래서 이제 그런데 이제 여기서 끝나면 재미없으니까 제가 이제 또 살짝 앞으로 어떻게 우리가 어떤 식으로 생각을 하고 어떤 식으로 제품을 발전 나가고 싶은지에 대해서 살짝 말씀을 드리도록 하겠습니다. 일단은 이제는 거의 사장된 얘기지만 한때 이더리움 킬러라는 얘기를 많이 들었을 거예요. 항상 뭐 2017년도부터 시작해가지고 매해 새로운 이더리움 킬러라는 블록체인들이 나오고 그 블록체인 킬러들이 지금 남아 있는 것들이 거의 없죠. 그래가지고 보시면은 이제 2017년도에 이더리움 킬러들은 지금 어떻게 됐나 뭐 이런 것들. 그리고 매년 지금은 아마 이더리움 킬러라고 어떻게 언론에 타는 거는 솔라나 정도? 근데 솔라나도 그렇습니다. 그렇게 있고요. 그래서 뭐 이런 밈도 한때 있었죠. 어떤 게 진짜 이더리움 킬러냐. 그래서 결론은 그냥 이더리움 2.0, 더 이상은 이더리움 2.0이라고 말하면 안 된다는 얘기를 들었는데 이더리움 2.0이 이제 진정한 이더리움 킬러다라는 밈이 있었고요. 근데 사실은 돌이켜 생각을 해보면 블록체인들의 관계는 경쟁 관계가 아니고 사실은 가격적인 측면에서 서로 라이벌 구도를 만들었던 것이고요. 이더리움은 사실 그것보다 한참 많이 앞서가 있는 상태였죠. 그래가지고 이번에도 뭐 L2, L1 얘기가 많이 나왔는데 사실은 실제 사용에서는 L2를 통한 상호 보완 관계로 이제 발전하고 있다라고 저희가 생각합니다. 뭐 여러분들 당연히 또 그렇게 생각하고 계시겠지만, 그래서 이제 특히 뭐 트릴레마 문제에서 확장성 부분을 L2로 해결을 하겠다라는 얘기가 나왔고 이거는 이제 이더리움 파운데이션 독서에 이미 들어가 있는 내용입니다. 그래서 저는 살짝 전문성까지가 좀 들어가면 좋지 않을까. 왜냐하면은 체인들마다 뭐 약간은 L2인데 서로 이제 다 범용적인 체인을 노리는 게 아니라 어떤 것들은 뭐 디파이에 중심이 있다던가 아니면 어떤 거는 뭐 게임에 중심이 돼 있다던가 뭐 이런 것들이 있겠죠. 뭐 게임도 뭐 플레이스테이션에서 특화되어 있는 게임이 있을 거고 스팀덱에 특화되어 있는 게임이 있을 거고 뭐 이런 장르의 그런 뭐 디펜던스가 있다고 봅니다. 그래서 이제 이런 추세 속에 저희가 아마 이미 2020년도에 한번 저희도 기여를 했거든요. L1, L2의 트랜잭션, 메타 트랜잭션 내진 체인 아이디를 통해서 다른 체인에 있는 트랜잭션을 뭐 이더리움에서 사용하고 이더리움에 있는 트랜잭션을 뭐 다른 체인에서 사용하고 하는 거를 EIP를 한번 거의 제출한 적이 있습니다. 어제 거기 포퓰러에서 EIP에 대해서 이야기를 했는데 뭐 여러분들도 뭐든지 있으면 일단 올려놓으면 나중에 이렇게 써먹을 때가 있으니까 충분히 좋은 부분이 되고요. 근데 여기서 또 재밌는 부분은 우리가 했던 EIP를 폴리곤 코파운더가 리트윗을 했어요. 이런 게 있다. 굉장히 좋다. 그리고 스테이 튠드 기다려달라라고 이제 저희가 이제 셔라웃 해줬었죠. 그러니까 어떻게 보면 이제 저희는 이제 가문의 영광이죠. 굉장히 기분이 좋습니다. 폴리곤이 지금 만들어지는데 조금이라도 기여를 했다라는 느낌만 갖고 있어요. 그래서 이제 제가 생각했을 땐 이렇게 되면은 이더리움은 뭐 다른 L2 체인들의 루트 오브 트러스트의 위치를 가지게 될 것이고요. 어떻게 보면 저희가 이제 초기에 블록체인을 개발을 할 때 뭐 제가 계속 게임 얘기를 하는데 게임을 개발을 할 때 새로운 게임기가 나왔을 때 게임 개발사 뭐 마소나 소니가 되겠죠. 그 사람들은 킬러 타이틀이라는 걸 굉장히 중요하게 생각하고 라인업을 굉장히 중요하게 생각을 합니다. 우리 게임은 뭐 RPG에 특화되어 있는 게임기고 아니면 우리 게임은 뭐 FPS에 특화되어 있는 게임인 것처럼 마찬가지로 이더리움이라든지 블록체인이 나왔을 때 과연 우리 체인은 어떤 거를 특화를 해서 만들 수 있을 것인가 생각을 했는데 더 이상 이더리움은 뭐 대배 의존하지 않아도 다른 블록체인들이 이더리움의 킬러 타이틀이 아닐까, 킬러 대비 아닐까라고 생각을 들게 될 정도로 앞으로 이제 어떻게 보면 루트 오브 트러스트의 위치를 공고히 하지 않을까. 또 다른 말로는 어떻게 보면 디파이가 굉장히 중심이 되고 있으니까 은행들의 은행으로서 역할을 할 것 같아요. 그래서 근데 이제 이거는 이제 EVM 호환 체인들에 대해서 이더리움에 굉장히 뭐 브릿지를 연결한다라든지 서로 프루브를 해가지고 뭐 앵커를 박는다라든지 이런 거에는 굉장히 유리하겠죠. 그런데 EVM 호환 체인이 아닌 다른 체인들은 좀 난해하긴 하죠. 이런 부분에 대해서. 그렇지만 뭐 용도에 따라서 이미 브릿지를 통해서 자산을 이동을 해가지고 뭐 서비스를 이용을 하고 있어요. 그런데 브릿지로 자산의 이동이 수월해졌다고 해도 해결할 수 없는 문제가 있는데요. 일단은 뭐 전문성이라든지 네이티브 코인 가격, 뭐 사용자 리퀴디티 뭐 이런 게 아니고요. 사실은 이더리움은 지금까지 얘기했던 것처럼 다른 체인에 비해서 압도적으로 높은 퀄리티의 개발자들과 압도적으로 많은 양의 개발자들을 가지고 있어요. 이거는 이제 컨센서스에서 발표한 자료고요. 최소 4배 이상의 개발자들을 갖고 있다. 그리고 그 개발자들 퀄리티조차 압도적으로 다른 체인들보다 훨씬 높다. 이런 얘기를 하고 있고요. 그래서 뭐 약간 추려서 말씀을 드리면은 이더리움은 뭐 가장 강력한 영향력을 가지고 있는 블록체인인 거를 뭐 따로 말씀은 드릴 필요는 없고요. 그리고 그 영향력을 이용하거나 의지하고 싶은 블록체인들이 계속 나올 거예요. 하다못해 그냥 공격의 대상으로 그냥 이더리움을 싸울 생각도 없는데 뭐 킬러라고 스스로 자처한다라든지 얘기하는 것도 있을 수 있고요. 그런데 이제 사용자들은 커뮤니티를 고르듯 자기가 원하는 성격 블록체인을 선택해서 사용할 거예요. 그러니까 또 게임 얘기가 나오는데 난 FPS를 좋아하니까 이 게임에 내가 원하는 타이틀이 많구나 뭐 이런 식으로 선택을 하는 것처럼요. 그런데 그것이 꼭 EVM 호환 체인일 필요는 없어요. 왜냐하면은 이거를 느끼지 못하게 UX는 진화를 할 거기 때문에요. 그리고 이제 미래의 개발자들은 대부분은 스마트 컨트랙트의 개발자들일 것입니다. 그러니까 뭐 또 게임 얘기를 하는데 게임 엔진 개발자들이 많을까요? 게임 개발자들이 많을까요? 그러니까 언리얼이라든지 유니티 개발자들은 합쳐서 몇백 명이 안 되는데 전 세계의 다른 개발자들은 몇만 명이거든요. 그래서 대부분의 개발자들은 스마트 컨트랙트 개발자들일 것이고요. 그래서 EVM 기반의 솔리디티 이후에 스마트 컨트랙트들을 개발하는 경우가 더 많을 거예요. 그런데 이렇게 되면은 멀티체인이라든지 뭐 다른 뭐 솔리디티만 있는 것도 아니고 뭐 이더리움 안에서도 솔리디티만 있는 것도 아니죠. 뭐 바이퍼 같은 것도 있으니까요. 그리고 뭐 니어 같은 경우는 뭐 타입스크립트, 자바스크립트, 러스트 같은 걸 많이 지원을 하고 있고 요즘에 많이 각광을 받고 있는 앱토스 수이 같은 경우는 무브라는 자체 랭귀지를 갖고 있습니다. 그래서 2종류 이상의 블록체인에서 2종류 이상의 스마트 컨트랙트를 동시에 개발할 경우가 미래에는 당연히 발생을 할 거예요. 그래서 뭐 제가 생각했을 때는 그래서 이제 저희가 기여한 리믹스 IDE의 멀티체인 플러그인을 사용해서 아마 개발자들도 자산처럼 다른 체인에 왔다 갔다 하면서 개발을 하는 환경이 만들어지지 않을까 그렇게 생각을 하고 있습니다. 그리고 저희가 이제 또 요즘에 좀 관심을 가지고 있는 것 중에 하나가 저희가 이제 개발을 할 때 아무래도 이더리움이 가장 말씀드렸던 것처럼 가장 발전된 체인이고 그리고 뭐 가장 촘촘하게 박혀 있는 생태계이기 때문에 이더리움 생태계를 분석을 하면은 다른 체인에 비어 있는 부분을 쉽게 볼 수가 있습니다. 그래서 상상도 이더리움 쪽에서 개발을 하다 저희도 이제 저희 개발팀 원래 이더리움을 개발을 했었고요. 그러면서 멀티 체인으로 확장을 했었는데 다른 체인을 먼저 개발했던 사람들은 우리가 이더리움 개발자들이 봤을 때 이건 당연히 있어야 되는데 왜 없지라고 하는 것들이 굉장히 많은데 그 중에 특히 코드 베리피케이션이라는 부분이 많이 간과가 돼 있어요. 그러니까 이더리움 계열 아니면 EVM 계열 외의 다른 체인들은 코드 베리피케이션에 대한 개념이 굉장히 없습니다. 그래서 저희가 이제 리믹스 플러그인의 이제 멀티 체인 컴파일러 이외에도 그래서 다른 뭐 수이라든지 앱토스라든지 코드 베리피케이션 API를 통해서 저희가 뭐 세큐리티라든지 다른 체인의 뭐 트릴레마도 같이 해결해 주려고 노력을 하고 있습니다. 그래서 이상 마치도록 하겠습니다. 감사합니다.
Thank you very much. Well done, team, for a detailed intro to Remix ID. Before we move on to the next session, I just want to tell everyone inside the building that we have a really nice weather out here. The sun's lovely, so please feel free to come outside, sit up front and close to the speeches. Thank you. Next, can I invite Frank? Do we have Frank from Chainlink? Here. Right. While we prepare, please, everyone, feel free to step outside and join us under this sun. It's not too hot. It's not too hot. You're gonna use this one. Okay. 이걸로 연결할게요.
Thank you. Sorry. The display is a little bit different. Can you just come here and I will show you? When I just
코딩은 저거로. 네네. 근데 지금 이게 저기서 잘려서 나와요. 그러니까 지금 코딩한 걸 틀어준 건데 다시 원위치 하세요.
So for the PPT, there's a pointer. So whenever you need to switch slides, just use the pointer, and then you can switch screens back to when you're coding.
okay.
Yeah.
1번하고
Okay. So you want me to use that one for what? For the PPT, for the slides?
So I'll just give you the pointer. So you can just move between slides using this. And then when you're coding, you can just switch to the different screen where you're coding.
Okay, thank you. Hello, everyone. Hi. Yeah, thanks for the opportunity provided by Ethcon that I can stand here and introduce some blockchain and Oracle technology to all of you. And thanks everyone coming to this workshop. My name is Frank, and I am a developer advocate from Chainlink Labs. For those who don't know about the Chainlink, Chainlink is a decentralized Oracle network. And based on that network, we also provide some Web3 services like data feed. You can get some price data of a particular asset like Bitcoin, Ethereum, or you can just outsource some calculation and computing to the Web2 services. And we also have some cross-chain service. And I'm going to cover all of these services in this workshop. And in our workshop, oh, sorry, I need to use this one. In the workshop, there are going to be 3 sessions. In the first one, I will introduce what is an Oracle and what role Chainlink plays in the Web3 field. And in the second session, I'm going to introduce all the Web3 services provided by Chainlink, like a data service, computing service, and more importantly, the CCIP, the cross-chain service we just released in last month. Oops. Sorry. And also, I will give like a 15 minutes demo to build a cross-chain NFT with the help of the CCIP to show how easy you can build a cross-chain dApp with a Chainlink service. And at last, I will spend a little bit of time to share some very useful information about our developer community. If you want to get started, where you can find some material. If you get some technical question, where you can get some help. Okay, so let's start. So first, let's just start from answering the question, what is Oracle and what is the Oracle problem? To simply put, the Oracle is like an infrastructure to help developers to move the data and computing services from Web 2 to Web 3. And your next question may be, why do we need a typical infrastructure to help us to move the data from the Web 2 to the Web 3? That is because with the growth of the Web3 ecosystem, we want to build more complicated logic in our smart contract. So we need some data from the Web2. For example, if you want to build a Web3 version insurance for the flight delay, so you need to know the data of the flight. You need to know the data of the weather, and you save your asset on the blockchain. If the flight is delayed, you can just offer the payout to the clients of your insurance. In this scenario, you definitely need some data from the Web2. But for the blockchain, they just cannot get this data or computing services proactively from the Web2. And why is that? That is because the blockchain is actually a deterministic system. And what is that? The blockchain can only handle the deterministic transaction, and that is because the process called a consensus. You know, the blockchain is a distributed ledger system, and in order to keep every node under this blockchain have the same data, we have the process called consensus. So if there is any data supposed to be updated or added to the blockchain, there are going to be a node under this network to make a proposal to say like, hey everyone, I just executed this transaction and updated my database. And can you guys just check this transaction and to see if you can get the same result? If you can get, just update your database. And if the majority of the nodes under this network agree that we will add this data into our database, then the consensus is reached and the data can be updated, and AKA the block is written into the blockchain. But think about that. If I want to tell everyone, I checked the API of the weather in Seoul. Maybe it's 20 degrees in Celsius today. And can you guys just check this API and just to see if you can get the same temperature? And what do you think will happen? So like before, every different node will see the proposal to see like if they can get the same temperature. But you know, let's first assuming they all have the access to the outside API, but the different people in the different time slot, even they call the same API, they may get the different answer. So if they cannot get exactly the same answer from the API, they just cannot make this data go through the consensus. So the data cannot go through the consensus. The data cannot be written into the block. So that is why the the blockchain can only process the deterministic transaction. So no matter when, no matter who to execute this transaction, like 1 + 1, the result will always be 2. That is called a deterministic transaction. But if you want to get some data from the Web2, from the API, or you want to get some random number, so everyone else will have the different answer. So that data cannot be written into the block. That is the reason why blockchain cannot get the data and the computing service from the Web2, and that is called the Oracle problem. And Oracle, by its name, is help us to solve this problem, to just use a decentralized manner to relay the data and the computing service from the Web2 to the on-chain smart contract. Okay? So from a very early age, from the in the Web3, we have a lot of the Oracle solutions. Well, the one is a central Oracle. The process of this Oracle is pretty straightforward. You just set up a server off-chain and write some script on this server, and then this server will keep monitoring the status of the smart contract. So if the user of this smart contract make a request and write some data usually into the event, and this request will be caught by the off-chain node, off-chain Oracle node. And the off-chain Oracle node will use this, will just execute what is described in this request and get the data from the data resources and then feed this data back to the smart contract. Sounds good, right? But there is a problem called a single point of failure. So think about the reason. The reason we want to build the decentralized application on the blockchain, on this decentralized network, is that we want to rely on the thousands of or hundreds of nodes under this decentralized network to promise our dApp is just secure, just tamper-proof, just transparent. But if we introduce the single point of failure by connectivity to the outside data, we just if this Oracle node is attacked or exploited, we just compromise the security of the whole system. So that is what we're saying, that using the single node Oracle is just creating a single point of failure. So the solution or the answer to this question, to this problem, is that we need to use a decentralized Oracle network. And in the decentralized Oracle network, we will have like a 32 or 64 node under a network. And each node will just go and reach out to get the data from their own data source. And after the data is fetched by each node of this network, the node will talk to each other and aggregate the answers into a final report and then submit this report to the on-chain smart contract. And after the necessary verification is done, the different smart contract on-chain can consume this kind of the data. So by doing this, we kind of mimic the trust minimized service from the blockchain. So we can just make our data delivery layer, or we can call it the Oracle layer, is secure and tamper-proof and transparent as a blockchain. So that is a decentralized Oracle network, or we can call it DON, DON. So the Chainlink is actually a kind of the decentralized Oracle network, and based on that, we also provide some Web3 services. Like I said before, the data feed, the data service, and the computing service. For the data service, we have the data feed. If you build something like DeFi, you will know the price of the asset. People collateralized on your protocol, you need to know the price of assets that people want to trade on your protocol. And in this scenario, you are going to need the data from the data feed. And also, if you want to get some unnormalized data, like the weather data, transportation data, marketing data, advertisement data, any data you can get from the Amazon Data Exchange or any Web2 API, you are going to use the Chainlink functions to get some niche and unnormalized data from that. Yeah. And for the computing service, we can just generate a random number. If you are building some NFT collection, you want people to mint your NFT, and you will give it a random number. So everyone will get an NFT in different reality in a decentralized manner. And also in the automation, if you want to automate your smart contract some functions in your smart contract every 2 days or based on some predefined conditions, you can do it with chain automation in a decentralized manner. So I will just go through the data and computing service for just in less than 5 minutes, and I'm going to jump to the cross-chain service. So the data feed, this is the architecture. You can see that there is a DON, the decentralized Oracle network. There are going to be 32 or 64 nodes under the DON, and each node will just go and reach the data source and get the data from its own data provider. And then they just talk to each other, like I said before, to just finalize, aggregate the answers and submit the aggregate report to the on-chain smart contract that can be consumed by the user smart contract. We can also call that a consumer smart contract. So if you are building DeFi, there is a very, very decent chance that you are going to use data from the Chainlink data feed. And the next one is called Chainlink functions. To support a Chainlink data feed, if you want to get some niche data, you want to, let's say you want to build a Web3 insurance. You need to know the temperature data, you need to know the flight delay data, or you want to know the transportation data, you need to get it from the API. But you cannot rely on a off-chain service in the single node to help you to do this, because that is not secure. You know that? By doing this from the Chainlink functions, we have the DON, the decentralized Oracle network. You just write your request in the JavaScript or any language you like and submit this request through the smart contract. And this request will be picked up by the DON. And in every node under the DON will just execute your request, maybe just fetch data from the API or do some computation. And then the node under the DON will just aggregate these answers and feed this answer back to your smart contract. So for the user side, you just write a request in the JavaScript and send it through the Chainlink functions. And then after several seconds, you will get a result. So this actually gives a flexibility and a connectivity to your Web3 app as any Web2 app has today. So cool. So let's move to the Chainlink automation. Chainlink automation is a tool to help the developers to automate any function in any contract by some predefined condition. For example, if you have a protocol, you want to claim your yield every 2 days and reinvest your yield into the staking, and you can increase your money in a compounding rate. You can use Chainlink automation to do that. Or you just want to build a limit order in the decentralized exchange, because in the decentralized exchange, there is not a central engine to keep watching if your order should be taken or not. So you can use a off-chain service to keep monitoring the status of the smart contract. And when the predefined conditions is met, you can the Chainlink automation will definitely trigger that one. Okay, cool. So next, I'm going to introduce the most important service I want to introduce today, the cross-chain service, the CCIP. The CCIP, the full name of it is Cross-Chain Interoperability Protocol. And by its name, you can know that this is a tool to help the developers to build a cross-chain dApp. Maybe you want to just move the fund from the chain A to chain B and from chain B back to chain A, and you also build your smart contract on the mainnet you like, but you want to reach the users in different blockchain. And you can build some interfaces for your dApp and provide this interface in the different blockchain. So the users in the different chains will just interact with your smart contract without having any fund in that blockchain. Okay, so before we dive into the technology of the CCIP, I just want to ask everyone else with me to think about the future of interoperability. Maybe 3 to 5 years ago, it is very safe for anyone to see like, we only need Ethereum, and we build our dApp on the Ethereum. Everyone will use the Ethereum. That is quite a widespread idea several years ago, and there are going to be a super blockchain to dominate the world of a digital asset. But with dozens of the blockchain in production today, I think this situation, the winner-take-all situation, kind of diminished. So we will have a lot of the blockchain in this world. And if you check this website, it's called the Chain List. That is a website to help the developers to know the RPC and the chain ID information from the different EVM chains. You will know that there are about 500 EVM mainnet in this world for now, and this is only for the EVM. If you include the Move system, if you like a Sui, if you include some Polkadot or Cosmos, there are going to be more blockchains, and no one knows the total number of the blockchains in the world. So the factor number one is that nowadays in the Web3 ecosystem, the number of chains keep increasing, and the factor number two is that the liquidity. The liquidity is more and more decentralized. Liquidity fragmentation. So if you look into these two charts, especially on the right hand, you will see the blue part, which stands for Ethereum. The TVL of the Ethereum keep decreasing in the percentage, and the number of other colors is increasing, and the percentage of the other colors in this in the total TVL is increasing. So there is a lot of the blockchain coming out, and each blockchain will have its own killer apps. Then the user, if the user want to use this app, they will keep the fund on the other blockchain. So the fund and the liquidity fragmentation is more and more decentralized. Okay, so these are two very interesting numbers. The first number is total value breached till now is 168 billion, but the total value breached in last 2 months is about 115 billion. The token value breached in the last 2 months contributes the 68% of the total value we have till now. So if you are a developer in the Web3, if you want to build your decentralized application in these 2 years, you will please be attention for the cross-chain feature because people demand it, reflected from these numbers. Okay, cool. So what is the CCIP? The CCIP is a messenger relay protocol, and in the different channels we will deploy some smart contract called the router. And if you want to send a message from the chain A to chain B, we call it from the source chain to destination chain. You just send this transaction through the on-ramp smart contract, and the CCIP will just pick up this request and write this request back to the destination chain. And there are going to be 3 phases. In the phase number 1, you'll write a request, and the CCIP will pick it up and write into the destination chain. And this phase is called commit. And after the commit, we have another one called risk management network. That is a network to help the developers to keep monitoring if the DON, the executing and the committing DON is exploited or is attacked, to keep the data is a real data the user want to relate from the original chain to the destination chain. And if they can verify the validity of this message, they will blast the commit on the destination chain, and this phase is called blast. And in the phase number 3, we will have another role called executing DON, the executing decentralized Oracle network. This DON will execute this transaction on the destination chain. So by go through these 3 phases, the people can transfer any message or any information they want from the source chain to destination chain. And it includes the token transfer, includes the token minting, or you want to mint an NFT, you want to make a transfer on another chain, you want to interact the smart contract deploy in another chain where you do not have any fund, you can do it from the cross-chain provided by Chainlink. Okay, cool. So for now, I'm going to give a demo. It's going to be a 15 minutes demo to build a cross-chain NFT with the help of the CCIP. So I will introduce what we are going to build. Our target is to provide a handle to the users in the Avalanche Fuji to allow this user to mint an NFT that is deployed on the Ethereum Sepolia. So this user will not have any fund on the Ethereum Sepolia. They just have their Avalanche tokens on the Fuji, and they can just send a transaction from the Fuji, and this transaction will picked up by the CCIP, and the CCIP is gonna execute these transactions on the Sepolia, and then the NFT will minted for this user. And what we are going to build is, first I'm going to build a ERC 721 NFT smart contract, and then we will have a sender smart contract from the Avalanche Fuji, and next we will have the receiver smart contract in the Sepolia. So the sender is used to send the transactions, send the request from the user, and the receiver will be used to receive this request from the CCIP, and this transaction is going to be parsed to mint an NFT in an NFT ERC 721 smart contract. Okay, this is architecture. So on the right hand is the destination chain. We will have our NFT smart contract and the receiver smart contract. And on the left hand, we will have the sender smart contract deployed on the source chain. And we send a request from the source chain. This request will be picked up at the CCIP, and the CCIP will write this transaction into the destination chain. And the destination chain receiver receive this smart contract, receive these transactions and parse it and get the real message that need to be executed and execute it to mint an NFT. Okay. So that is the demo part. I think I need to use my laptop. Can I change it to my screen? Okay, 1 second. Okay. Okay, so in this demo, I'm going to use an online IDE called Remix, just introduced in the last session. And I'm going to use the Open Zeppelin to generate some smart contract. So first one, I'm going to open the Remix. Let me zoom in. Okay. Since we are going to deploy the 3 smart contract, let me show it here. First one is a ERC 721, and I'm going to create a ERC 721 NFT smart contract first. And I'm going to create a new file called my nft.solidity, right? And I'm going to open that openzeppelin.com because it gave me a framework to generate a smart contract in the very fast speed. Go to the docs. And contracts, there is a wizard. I don't know if you are using this one. It's a great to help the developers to just generate a standard smart contract. And click this one, the ERC 721. And I'm going to give it a name called my NFT. And simple is not important. And we will select the features we want to have in our NFT smart contract. I want it to be mintable. And I want it has a URI storage because I need to add some metadata into our smart NFT. So I need this interface. So the development of the NFT smart contract is complete. And copy everything here. Sorry, just select everything. Copy to the clipboard. And switch back to the remix. Oops. Oh, let me open that on the remix. Just rename it to the my NFT. Yes. Oh. Oh, let me do this just to copy everything here and paste in my NFT smart contract. And let me remove that. So Remix does not allow me to remove. Oh, that's fine. Let's see this smart contract of the NFT. See, we have the constructor, give the name of this NFT, and we have a function called SafeMint. If anyone call this function SafeMint, they will get an NFT under his address. And we also have the function burn and a token URI. Actually, we don't need these three. To make this smart contract simple, I will remove all the unnecessary smart functions. Remove that, and Command plus S. Okay. We don't need this either. Just compile that. So if you see a green check mark here, that means the compiler is successful. And our first smart contract is going to is almost complete. But what we want to do is we remove this access controller called only owner, because we want everyone to mint our NFT. And there is a token ID, and I want to create a variable here to just use a token ID. Because everyone who calls this function, they don't want to input a lot of parameters. We want to keep this simple. Remove that one. And after one NFT is minted, we want the token ID incremented. And there is a second parameter called URI. So this URI is a metadata of this NFT. And I have already prepared a metadata, and we will use that as a constant variable. I saved that on the IPFS. So that is just a JSON file. If you want to build an NFT and give it a metadata, you just add this JSON file to your token URI. So everyone opens the OpenSea, and to see the NFT, they will see the image and all the descriptions and the features. So the image is saved on the IPFS here. I will show that to you. It's like this one, right? So our NFT, the image of our NFT will be this handsome gentleman, okay? So I'm going to copy the URI here and paste it here. We will have another variable called a string constant and a token URI equals that JSON file, right? So we have the URI variable, and we don't need that anymore. Remove that. And in this set token URI function, we just use the token URI here and compile. Everything good. So our NFT smart contract is completed. So we have already completed this part. And next, I'm going to create a sender. This sender is used for sending the request from the source chain, which I will going to choose the Avalanche Fuji testnet. And switch back to the remix. We create a new smart contract called the source chain minter. So we want user to mint our NFT from the source chain. So we call it source chain minter.solidity. And definitely we will not going to write this smart contract line by line. So where we can get some sample code, go to the documentation of the chain links, docs.chain.link, and everything, let me change to the English. So everything I talked today, you can find in the Chainlink documentation. You can find everything. See here, you can see that we have the different services listed on the top tab, the VRF automation, CCIP functions, and API and nodes. So for this time, I'm going to go to the CCIP. And on the left hand, there are tab. We're going to the getting started. In the getting started, this page, we provide two sample code. The first one is standard code. And the next one is receiver code. That is our sender and receiver. So let's first focus on the sender. And I copy everything here. Copy that by clicking this. And switch back to the remix and paste the smart contract here. And if you overview this smart contract, you will see that in the sender smart contract, we have a function called send message. So in the send messages functions, we will write our data and wrap this data with other necessary parameters and wrap all of that into a bytes and send these bytes variables through this send message. And if we call this function, there are going to be a message, event emitted, and another function called CCIP send will be called. That is a function under the router. And if this function is called, your request will be written into the event. And the event, the information in the event can be caught and picked up by the CCIP so that the CCIP can relay this messenger from the source chain to the destination chain. So what we are going to call is that a mint function, right? In this one, we want to call this function. So how we transfer this message? First, let me just copy that one and switch to the send message function. And there is a method called abi.encode with signature. And it's gonna receive two parameters. The first one is that the function name, and the function name is a safe mint, right? And we will give the data type of the parameters. And the next one is the value of these parameters. And we want it to be the message.sender. And it's going to be a bytes. Let me give you a name called function call equals to that. And obviously, that is a memory. Encode with signature. Signature. Okay, sorry. Oh. Anyway, for this function call, we are going to use this function call in the data part. You can see here we have the EVM to any messenger. So this messenger is a messenger we want to send from the source chain to the destination chain. What is the problem? Oh, that should be the compiler issue. Change the version of a compiler to this one. Okay, we can see the green check mark here. So the sender smart contract is compiled successfully, and we almost done with that. So we have the function call. In the function call, we add the first parameter as a safe mint, and the second parameter is a value of the parameter in this function we want to call. And then we just transfer it to the bytes variables, and then we write this variable under this message. And this message is wrapped up, and that can be sent from the source chain to the destination chain. Okay, cool. So we don't need this task here. Remove that, and also remove that on the comment. And obviously, in the event, we remove that. And I think this one. Just remove the text because we just send the safe mint function bytes variables from the source chain to the destination chain. And till now, we have already completed our sender smart contract here, this one. We have complete that. And next, the final step is to complete our third smart contract called a receiver. And I'm going to create a smart contract here called, third one called destination chain receiver dot solidity. So for this code, I'm going to go to the same page and find the receiver code, receiver sample code here, the receiver code, and copy that, switch back to the remix, and paste code here. Okay. And for the receiver, what we want to do is to call the safe mint function in the NFT URC 721 smart contract. So I need to handle for this smart contract, for the NFT smart contract. So import that one. dot slash, because these two smart contracts are under the same directory. So my NFT dot solidity, right? And in the constructor, we need to instantiate. So first, let me just initiate this variable NFT, right? Just initiate that. And on the smart contract, on the constructor, we will give the address to it. And NFT equals my NFT, and give it the address, NFT address. Obviously, we need to pass this address on the parameter. Address, NFT address. What is that? Oh, semicolon. So for now, we have already instantiated our NFT handle here in the constructor. And we are going to use another function called CCIP receive. This function is going to be used to receive the messenger relayed by the CCIP. So in the source chain mainter, we just send this function call and wrap that in the message. And this messenger will be picked up by the CCIP. And then this function will be called by the CCIP to send this message we just wrapped in our source chain mainter. And in this CCIP receive, we are going to parse this message and then call the NFT function. So how can I do that? So the address, NFT, we give the address and instantiate this NFT variable in our constructor, right? And the call, how can we get that? Message. Any to EVM message. This message will be input by the CCIP. And let me copy that and paste into the call dot data. And that's it. We just use the messenger related by the CCIP and input into the CCIP receive and call that function in the NFT on the destination chain. And we can give it a flag to see if that is a success, right? And actually, we don't need all of this stuff. We just get the NFT address and call this function, and the function call is from the source chain in the Avalanche Fuji. And then we need to require this success to be true. And by doing this, only the NFT is minted successfully, we can complete this transaction. So cool. I think we have already complete all the smart contracts we need. And let me start deploy them. Open your MetaMask and switch to the destination chain. We are using the Sepolia. And I switch the network on my MetaMask to the Sepolia. And I'm going to deploy the deploy tab and change this to the injected provider MetaMask. So the remix is going to use the network I configured in our MetaMask. And let me go to the NFT and compile that. If you are using a Mac, that Command plus S. If you are using a Windows, that is a Control plus S. And after that is compiled, you can see the my NFT in this blank and deploy that. MetaMask popped up and confirm. And we need to wait, I think, about 3 to 5 seconds, depending on the network. And we will see our smart contract here, the deployed contract. Let me see if that is done. It's still pending. Okay, good. The NFT is deployed successfully, so we can see all the functions here. The safe mint function is going to be called by the receiver smart contract in the CCIP. And this function, this smart contract is deployed successfully. And next, we are going to deploy the receiver on the same blockchain in the Sepolia. So go to the receiver, I think here, receiver, and compile that. You can see, make sure you can see the receiver under the contract and deploy that. But in this deployment, it requires two parameters. The first one is the router, and the second one is an NFT address. The second one is easy. We just copy the address of the NFT smart contract and paste it here. But for the first one, what is a router? The router is here because you need to allow the router to call the receiver smart contract. So you need to add this address of this router into your constructor. Switch back to the remix, and where we can, this remix, sorry, where we can find this one. In the Chainlink documentation, going to the supported network. These are all the network supported by Chainlink function, Chainlink CCIP, and because we are doing that on the Sepolia, so click the Sepolia, you can find here is a router address. Copy this router address and paste it on the second parameter, first parameter here. And we have all the information we need to deploy this receiver smart contract and transact. And the MetaMask popped up. Click confirm. So we are deploying our second smart contract. Okay, cool. These two smart contracts are deployed on the Sepolia, this network, Sepolia. So what I'm going to do is I will deploy the sender smart contract on the source chain, on the Avalanche Fuji. So when the user on the Avalanche Fuji's user want to mint a NFT on the Sepolia, they don't need to move the fund from the Fuji to Sepolia. They just use this interface to send a transaction, and they can just interact with this NFT smart contract, which is deployed on another chain that they do not have any fund. So to employ the third one, I'm going to not this remix. Let me close that. I'm going to use my MetaMask and switch the network to the Avalanche Fuji testnet, to this testnet. And open that source chain sender and compile that. And we can see the sender smart contract here. And to deploy that, we need two parameters, the router and the link address. For the router, you know where to get that from the page of the link documentation and go to the Avalanche Fuji, click that. Here is a router address. And copy that, paste it into the first parameter. And the second one is the link address. In the link address, you can still find this information in the documentation of the Chainlink. Go to the getting started, and in the getting started on the left-hand panel there is resources and the link token contracts. And for here, you can get the address of the link token across the multiple chains. Because we are using the Avalanche Fuji, so go to the Fuji testnet, and here is the address of the link token on this testnet. Copy that, and switch back to the remix, and paste it here. So we have all the parameters we need to deploy our sender to the source chain, and deploy that. MetaMask popped up. And for now, I'm using the Avalanche Fuji testnet and confirm. Wait 3 to 5 seconds. Okay, cool. So we can see all these 3 smart contracts in the deployed smart contract. And what I'm going to do is under the sender smart contract, I'm going to call this send message function to send a mint function call from the Fuji to the Sepolia to just mint an NFT for me. So there are 2 parameters needed. First one is a selector to tell the CCIP which chain the transaction is sent to. And the second one is a receiver. Receiver is the function is a smart contract address we just deployed. Copy that and paste on the receiver. And the selector can be found on the CCIP page. Go to the Sepolia. Except for the router address, there is also a chain selector. So copy that chain selector and paste it here. So, oops. So we are ready to send this transaction. Let's click that. So it gave me an error. That is because we have not transferred the link tokens to these smart contracts. If there is no link token balance under this smart contract, the CCIP cannot charge for this request. So I need to transfer some link tokens to this smart contract. Copy the address here and open my MetaMask and send. Paste the address here and go to the link. Let me just transfer 2 links to the smart contract. Confirm. Okay, cool. So everything is ready. Let me just call this function again. MetaMask popped up, and I click confirm. So we will wait for this transaction is sent. Okay, cool. It is sent, and because we need to wait the transaction, the block where the transaction is finalized in the source chain. So it's going to be 3 to 5 minutes to complete the whole process, and we can just check the status of a transaction on the CCIP Explorer. Go to the ccip.chain.link, and I paste the transaction hash of the transaction in the source chain and search that. And you can see this transaction has already been picked up by the CCIP. This is the source chain hash and the destination hash. Because the messenger has not relayed yet, so the destination hash is empty. And the status of this transaction is the source finalized. That means the source is the block is waiting for finalized in the source chain. And the source chain and the destination chain information are listed here, and you can check the status of the transaction here. So let me just continue and switch this back after I introduce the final part of this workshop. So okay, so in this hackathon, we provided 2 categories of the bonus. So if you integrate the Chainlink CCIP into your project, we will pick the 2 winners and $1,000 for each. And if you want to use other Chainlink services in your project, we will pick 2 winners too, and $500 for each winner. So if you are interacting with Web2, or if you want to cross the messenger from the chain A to chain B, please consider the Chainlink services, and we will review your project and give you the price if that is good enough. So if you have if you want to have some more detailed information about each services, you can go to our documentation at docs.chain.link. And if you want to get started and you have some very specific technical questions, go to the Discord or post your questions on the Stack Overflow. We will review that and answer that. Or just join our Discord, or just add my Telegram if you have more specific questions. Okay, I think that cross-chain transaction should be finalized. Oh, see, the status is committed. Usually it takes 3 to 5 minutes. Okay, maybe 2 minutes. Oh, one thing. So for the CCIP cross-chain, we actually have a lot of the use cases. And I know the creativity is always from the developer community. So for the cross-chain, you can create a collateral staking protocol, which user can collateralize their asset on the chain A and get some liquidity on the chain B. And the synthetics, which is a protocol for the mirror asset, is actually using the CCIP to do this cross-chain collateralization. And for the governance, if you have tokens in multiple blockchains and the token holders have the right to make a proposal and to vote. So you can use the cross-chain dApp to allow multiple governance. Or you can treat the asset from one chain to another chain, or you can just use the CCIP or use your CCIP with your project as a aggregator or a connector to connect the different components of the different defined project together across the multiple chains. Or if your enterprise is building an app chain and set some asset on this app chain, you can use the CCIP to connect the app chain together to just connect the asset from the app chain to the public chain. I'm really excited to see what happens in this hackathon. Oh, see, the status is a success. That means when I send a transaction from the sender in Avalanche Fuji, this message is relayed from the source chain to the destination chain, and a new NFT is minted under my address without having any fund on the destination chain. Okay, let me just check if I can see this NFT on the OpenSea. OpenSea testnet. And go to my profile. Yeah, I have this NFT minted. You can see it is on the chain Sepolia, but actually I sent this message from the Avalanche Fuji. Okay, I think that is pretty much I want to introduce today. And thanks to everyone. Thanks for your time and thanks for your attention. If you have any technical questions, please reach me. Okay, thank you very much.
Thank you very much for such an elaborate session. Very fun. That'll be it for the first half of today. Please enjoy your lunch. The next session begins 1:30 p.m. And just another friendly reminder that we have a yoga session at 2 p.m. So if you're interested, it'll be held downstairs at Hall B. And if you have any questions regarding that, let me know. Enjoy your lunch. Thank you.
the official picture with you? With my laptop. Wow.
Hi everyone. Hope you enjoyed your lunch. We'll be beginning our afternoon session in 5 minutes. Thank you.
I'll be sending my slides to the chat. Because I realized what I wanted to do initially was to go back and forth the slides and the live coding, but I think that wouldn't be that useful. So I'm just going to end this slide, and then I'm going to start live coding.
Okay. Yeah. So when you hit this slide, I'll start the team to live coding. Okay.
Then I'll send the rest of the slides to the participants chat.
Got it. This is the first slide. Okay, everyone, it's 1:30. We'll begin our session. Hope everyone managed to get some to eat. There's still a lot more food upstairs if you're still hungry. I'd like to invite Tycho to the stage. Yeah, thank you.
Hello, test. Is it okay? Okay. Hey, good afternoon, everybody. Yeah. Thank you. Okay, my name is King. I'm a DevRel from Tycho. And today we'll be deploying a decentralized application on Tycho with a subgraph, right? So I guess not many people are here. I wanted to ask what's the skill level of developers here? But just a disclaimer, this workshop is actually for developers who are newer to Web3 development or hasn't really built an application with a subgraph, right? So because a little bit of an introduction of Tycho, because Tycho is a type 1 ZK EVM, we are able to integrate with protocols such as the graph so that we can build like cool decentralized applications with it. Okay, so yeah, we'll be deploying, and for today's example, we'll be building a NFT decentralized application powered by subgraphs. Yeah, so also why should we use the graph is because it's costly to store data on chain, and also by using the graph, you can retrieve your data much faster using the graph technology. Also, a short introduction of the graph. The graph is a decentralized protocol for indexing and querying blockchain data. And yeah, the graph makes it possible to query data that is actually difficult to query if you were to query it directly on chain. So, for example, projects with complex smart contracts like Uniswap or OpenSea, they use some sort of indexing hardware. It might not be the graph, but I'm pretty sure Uniswap uses the graph, and this allows them to, for example, retrieve like their liquidity positions, like on Uniswap v3, by querying the graph instead of querying it on chain. Okay. So how does the graph work? The graph learns what and how to index Ethereum data based on subgraph descriptions, which we will be going through later. And this is all written in what is known as the subgraph manifest. And once you have written the subgraph manifest, you can use the graph CLI to store this definition in IPFS and tell the indexer to index your data based on this subgraph manifest. And yeah, so just taking a look at this diagram over here. First of all, we will start off with your dApp on top, where users will interact with your smart contracts. So for example, when your user writes to your smart contract, let's say mint an NFT, events will be fired by the smart contract and picked up by the graph node. This data is processed by the subgraph that you have written and stored according to how you define, how you wanted the data to be processed. This is all done, stored in PostgreSQL in the graph node itself. And then your dApp can actually access this data through a GraphQL API. Okay, so now I guess we can get into the live coding section of this presentation, right? And I will also be sending the slides to the participants chat so everyone can follow the live coding. Right. Okay. All right. Okay, I guess. So first we will clone the example repository. And then we'll install the necessary packages using this shell script. So this actually sets up a Foundry and also the NPM packages for you. right. So I guess we can fire up our code editor. Okay. So next we will look at the project structure. I'll be highlighting the important files that we will be editing or have to take note of for this demonstration. So first of all, this is actually a mono repository which contains the front end smart contracts and the subgraph manifest. So within the packages folder, you'll see apps, contracts, and subgraph. App will contain your front end. Contracts will contain the NFT smart contracts, which will be deployed later, and the subgraph will contain the subgraph manifest. So if you take a look at in the source folder, we will see this diamonds.s solidity file. This smart contract will be deployed later on. Also, an important file would be the deploy script in Solidity as well, which will help to deploy the Diamonds smart contract. Right. Yeah, and in the subgraph folder, the subgraph manifest is found in this subgraph YAML file here. And yeah, in this tutorial, we probably only need to edit 2 or 3 files. Right. Next. Okay, so next we will set up a new wallet using this script, which will generate a new private key, and this private key will be used to deploy your deploy the Diamond smart contract later on. So now I will fund this address with some Tyco ETH. Let's go to router. Yeah, just give it a little while. And once your wallet has Tyco ETH, we will deploy the smart contracts using another script. Just typing pnpm deploy onto Tyco. And this pnpm script will actually run a Foundry script which will deploy our smart contracts to Tyco. Yeah, specifically the Diamonds NFT smart contract. Okay, so the smart contracts were just deployed to this address over here. So if we take this address and paste it into our block explorer, we should be able to see that the contract is deployed there. Also, this Foundry script will help to verify your smart contracts on Foundry, like all in one, so you don't have to worry about like contract verification. Right. All right. So the next step to this tutorial would be to edit the subgraph manifest. So there are two things we have to do, which is to edit this address and start block based on the outputs from the deployment. So right now I'll be copying the newly deployed contract address here, as well as the block number into the subgraph manifest file. And yeah, that's about it. Okay, so next we will be deploying the subgraph to we'll be deploying the subgraph to Tycho, the graph node that is on Tycho. Right. So the subgraph has been deployed on our graph node. And if we access this URL, we'll be able to go to the GraphQL playground, which will be used to, I guess, query the subgraphs that we deployed. So currently, there will be no tokens that are indexed by this subgraph. But after we mint an NFT, we will be able to see the changes. Right. So let's launch the front-end application using pnpm dev. Right. So this package uses WAGMI CLI, which will actually get your deployments from your Foundry folder and update your front-end application of the latest contract addresses that you have just deployed. So you don't have to worry about copying in the ABI or latest address. So if you access the front end now and mint an NFT, you can see that this button is already automatically connected with the latest deployed smart contract. Okay, it might be a bit difficult to see here, but yeah, it is the latest deployed smart contract. Okay. Yeah, so now the NFT is being minted. It's being processed right now. If we go back to the GraphQL playground, we should be able to see that the token was minted. If we query like other stuff, what can we query? Like the owner or the URI, we can see that we can actually see the owner and also the link to the like an NFT metadata. Yeah. So when we refresh our page here, we can see that the data was retrieved from the graph node. Yep. Subgraph API. All right. Yep, so that's the, we've come to the end of the example. Maybe I think I still have like 15 minutes, so I could talk about the potential applications that you could do with this subgraph. So initially, if you were to query all of this data from the blockchain, you will have to spend like one RPC call to, I don't know, Alchemy or Infura, and that might be costly if you have a lot of users that are using your decentralized application at one time. Also, with this, you can query the data of you can query multiple NFT data in one query instead of calling the blockchain. For example, calling the token URI one at a time, right? So for myself, I've used the graph to build applications such as NFT trade options trading protocol, where I use the graph to index the calls or puts on a DeFi application, or on this NFT options trading protocol. You could also use it for social media. For example, if you were to record every single post or comment, if all of this was on-chain and all of them were firing events, you could index these events and you could display your social media feed from by querying the data from a subgraph. Yeah. So any like questions from the crowd? No? Okay. I guess. Thank you. Yeah, if anyone has any like questions, or needs any ETH to deploy smart contracts, you can ask me for some. I mean, okay. You can buy it from me. Yeah.
So if you want to do this like deployment somewhere else, like a local Anvil or on another network, like another L2 or like mainnet Ethereum, like how could you like do that, I guess?
So if you wanted to deploy the subgraph, for example, on another chain, you will have to edit the subgraph manifest. So, okay, so you either, okay, no, so, sorry. You do not need to edit the subgraph manifest, but you will have to edit the deploy script. Instead of deploying to this node, you will probably have to either get the node that is indexing data from the chain that you want to deploy on, or use the Subgraph Studio. Yeah. So Tycho will be integrating with the Subgraph Studio in the near future, and Subgraph deployments will be much more streamlined from then on.
All right. Do we have any other questions? Also, if you want to ask questions but also need translation, just let me know.
All right.
All right. Good.
All right. Thank you.
Thank you, Kank.
Thank you. Thank you. All right. Thank you.
Next, do we have DJ from Lightscale? 네, 이거 사용하시면 됩니다. 그리고 이걸로 슬라이드 움직이시면 되고요. 여기서 발표하셔도 되고요. 네. 여기 지금 햇빛이 좀 세가지고. All right, everyone. Now we have DJ from Lightscale to give us an introduction to Chroma.
Okay, let me start. Yeah, no one is outside, so but I'm going to start my presentation. I'm DJ. Yeah, I'm not DJing, but yeah, my nickname is DJ. I'm the CTO of the Lightscale. You can see the logo of the left top. And we are building a unique load of Chroma. And we are integrating the GKEVM onto Optimus Loadup. So I'm going to share our considerations and some design choices when we're building our Loadup Chroma. Yeah, let me start with some basic overview of the Loadup. Yeah, layer 2 is the scaling solution for the Ethereum, and it depends on some security on the Ethereum. And so assets can be moved from to the Ethereum, and all the transactions can be executed on the layer 2 chains. So loadup is a specific type of the layer 2. So loadup submits all the transaction batches to the layer 1, and anyone can download transaction batches and reconstruct the layer 2 chains. Usually, these are basic components for realizing the loadup. There are data availability provider, bridge, L2 output oracles, and loadup clients. Loadup clients handle all transaction batch unloading and chain derivations and other stuffs. And block outputs are uploaded to the L2 output oracle, and it should be verified. So according to the type of the validation method, we can categorize into two types, fault proof and validity proof. And also, we can usually call the loadup based on the proof system types, optimistic loadup and GK loadup. Optimistic loadup usually submit the outputs and then wait several days. Then other can check the validity of the outputs. Then if the output has some kind of problems, then we need to submit the dispute challenge, and then we need to resolve that challenge. And GK loadup outputs submitted with a GK proof. So if the proof is verified, then outputs can be finalized instantly. But I think many of you already know that GK proof is very complex, and the proving cost is very high. And even worse, the proving time is very slow. So Optimus loadup currently more widely used now. I saw that the logo of the Optimism. We forked our code from the Optimism, and I think Optimism one of the most best loadup solutions. So Optimism loadup's pros is it's EVM compatible, and its proving cost is comparably low, so the execution fee is lower than other types of loadup. But GK loadup has fast finality, but it's incompatible. For example, Starknet has its own smart contract language like Cairo. So the GK EVM added some EVM compatibility. So, but still implementing the GK EVM is very hard, and writing some circuits for GK EVM is very time consuming. But recently, Polygon GK EVM, GK Syncera, Linear launched their mainnet, and also Scroll and Taiko is about to launch their mainnet soon. But we have some idea. So we implemented a unique load of chroma. We have two phases. At the first phase, we want to maximize the process of the optimus load-up, but still we want to have GK EVM. So we integrated the GK EVM onto the optimus load-up. So we implemented our challenge system using the GK EVM. So we call this fault-proof system GK fault-proof. So we can have some low operating cost and low fee, and we have some decentralized challenge system. And I think we are the only load-up that have permissionless validator systems. And there are some limitations because there may be some bugs, and the current proving system is not complete. So we need to have some security counsel. After maturing all the GK steps, we can move to the GK load-up. So we need to optimize, and we need to have some parallel GK proving pipeline. And we already designed our smooth transition mechanism for the GK rollup. So I'd like to introduce more about these kind of ideas. Yeah, this comes from the OP stacks. So these bottom blocks shows some layer 2 blocks, and layer 2 blocks can be zipped and encoded as a channel. Then channel can be split into channel frames. Then channel frames can be uploaded to the layer 1 as the transaction call data. So the reason why we split into channel frames, channel can be too big, so we need to make it uploadable to the layer 1. And then other nodes can download all the frames and reconstruct the channel. Then from the channel, the node can construct, rebuild the block data. So this kind of process are managed by different components. So mempool and block generation and state transition are done by the execution engine like the gas. And all these block load up and derivation process are coordinated by the load up node. And channel frames are uploaded by the batcher. Yeah. So this shows the basic architecture of the OP stack, and we start from the OP stack. So this color shows some different types of the participants, I mean the node types. So splitting it, then we have sequencer and verifier. In the OP stack, a sequencer upload all the transaction batches, and also it upload the outputs. And then other verifier can download all the transaction batches, and verifier can verify the integrity of the loadup. So there are two types of nodes for now. But there are some problems, like verifier does not have any kind of economic incentives. So there is no reason to learn verifier. So this is so-called the verifier's dilemma. To solve this problem, we changed the architecture of the OP stack like this. So the sequencer does not submit the output. Instead, validator submit the output. And then we can give some levers to the validator up. From this, we can have some chance to solve the verifier's dilemma. So we can divide some decentralization problem into two parts. The first one is decentralizing the proposer. Previously, it's called sequencer, and the reason why we call this proposer is that we want to adopt a proposer filter separation that is already researched widely. So I think this is the good candidation solution for solving some decentralization problem of the proposer. And we are going to focus on validator decentralization. It's related to the challenge system. Yeah, I just changed some colors to distinguish some node. And yeah, now we can think that based on this architecture, we can see some details of the handling, deposit, and L2 transactions. Yeah, and validator or downloads transaction and submit outputs. Then when user want to withdraw their assets from the layer 2, then they can send withdraw initiating transaction to the proposer, and other validators download all the transaction batches and create outputs, then upload to the L2 output oracle. After the challenge period, then the output is finalized. Then user can withdraw their assets from the layer 2. But there is no verification, any other verification. So we need some verifications. So there need some other types of participants. Proposer, validator. Validator just submit the output. So we call these types of validator as asserter. And maybe there is some problems, then the other types of validator can check the validity of that output, then they can submit dispute challenges. So we call it the challenger. So let's see what happens. So there are some blocks, and we only submit outputs in some checkpoints. Usually, we submit outputs every 1,800 blocks. So you can see there are two different outputs. The bottom output is submitted by the asserter previously, and the upper output is not submitted to the layer 1. It's some local output of the challenger. So we can provide some GK proof showing that this stated transition is valid. But actually, it's not practical because the proving cost is very high. It's almost impossible to generate all the proofs within a short time period for all these 1,800 blocks. So we need to identify the first disagreement output by interacting each other. So at first, challenger provided some outputs. So this number shows the index from the previous checkpoint outputs. So the first zero index output should be the same to the asserter's output, but the 1,800 checkpoint output is different from the asserter's output. And then asserter can check whether the difference came from, then provide other checkpoint outputs with six outputs, and then also challenger can check his output to this outputs. And then finally, also can provide this consequence, this sequential outputs. Then challenger can identify where the disagreement came from. So in this example, the 409.3 is the first disagreed checkpoint outputs. This may be invalid, or challenger may make some challenger may have some bugs. So challenger also makes some fault. So we need to prove that who's correct. So in this case, challenger have to prove his checkpoint output, his output is correct. So we use GK proof. So challenger is going to generate proof. Then if the proof is verified in the layer 1 contract, then challenger win. But actually, this is the current output root structure. So there are state root, withdrawal storage root, block hash. But we only can have some agreement on the stage. So we need to check the transactions. But the transactions that from the 493 is not agreed to each other. So we need to add this to the previous output. So in this manner, I'm sorry, yeah, it's not moving. Yeah, so in this manner, we can get some data that we can provide to the verifier. So now we can summarize the overall process. The validator at first submit checkpoint output, and the other validator can check the output, and if there is some problem, then they can create a dispute challenge, and they identify the potentially invalid output by interaction, and then challenger generate GK proof. So GK proof is verified, then the challenger wins, and if it's not verified, then Ulster wins. There are two types of problems in the system while we processing a dispute challenge. Maybe valid outputs may be removed because we sometimes fail to identify a fault output routes. And maybe we have some bugs, so invalid fault proof is verified. And second, invalid outputs may be kept. Sometimes we are unable to generate proof for a block because block is too huge, and maybe our proving code have some bugs. And the valid fault proof is not verified because our proving system may have some problems. So we need to handle this kind of situation. So Security Council checked all these kind of challenging processes, and if there is some problems, then they do some tasks that required. So this shows our overall architecture. Yeah, GK verifier, Colosseum, and GK prover is our unique component that we added all this GK related stuff to the OP stacks. And we also changed a lot in the validator. So we need some validator incentives. Yeah, I described how we handle and how dispute challenges can be resolved. But I didn't explain what's the economic incentives. So I'm going to explain the economic incentives. So this summarizes some network participants. So there are proposal validator and Ulster mode validator, challenger mode validator. To submit the checkpoint output, validator need to stake some ETH, and also challenger need to stake ETH to submit the dispute challenge. And if they succeeded, I mean, if some outputs are finalized, then the submitter, assaulter can get reward. And also challenger, if challenger win the dispute challenge, then they can get some rewards. It's from the user's fee pool. So in the layer 2, users usually pay 3 types of fees: load fee, base fee, priority tip. So base fee and the priority tip is the same to the layer 1, and load fee is used for uploading all the transaction batches. So proposal get all these load fee, and some portion of the layer 2 execution fees can go to the validator reward, and other remaining parts go to the protocol fund. This is our design. So our certain reward can be computed like this. There will be accumulated rewards in the validator reward board, and there will be our challenge period is 7, and checkpoint outputs will be submitted every hour. So there are these 106 8 waiting of submissions. So reward will be like this, and we need to have some proper bond to be a validator. So if bond is too low, then it breaks the challenge system. So the bond should be bigger than the challenger's proving cost, so the challenger can expect to get enough rewards from the successful challenging. So high bond makes some validation less profitable. So I think at least 10% APY is the minimum. So after simulation of from the other layer 2 data, we think that the 1.2 will be enough for our secure layer 2 network. And to escape from a situation where a few validators get the most rewards, we randomly choose one validator and give a priority to submit the checkpoint output. So there are some priority period, and if the priority validator misses the chance, then all other validators can submit checkpoint output. So we have priority and public period for submitting checkpoints. So priority validator randomly chosen without any external verifiable random function. So it's computed like this. Yeah, and challenger bond is the same to the Oster's bond, and some portion will be removed and go to the protocol vault, and the remaining 80% of the Oster's bond will be given to the challenger. In this way, we can escape some collusion between Oster and challenger. Yeah, we made some changes from the Ethereum because we are layer 2. We need some difference from the layer 1. So there is no layer 1. There is no deposit transactions in the layer 1s. So we have some layer 1 to layer 2 deposit transactions, and it's the initial differences. And we have different fee mechanisms because we designed our decentralized challenge system. And also, all data structures have changed for GK friendly and optimizing the GK proof generations. And these deposit transactions came from the OP stack, and the GK related data structure and algorithms came from the scroll, and the other parts came from our original design. So we changed GK EVM from the scroll, so only these two parts need to be applied to the GK EVM. So this is the original GK EVM developed by the Ethereum Foundation's PSA group. And scroll changed these parts, and we changed these two circuits. Yeah. I think I can skip these details because I think this is too complex. Yeah. Yeah. We changed some circuits and implemented it, all circuits. So the reason why we do not start as a GK rollup is that it's all about the cost. Yeah, its cost is too high. I'm not sure how the other GK EVM mainnet can be operated in this kind of high cost. Maybe they have some other secrets. Yeah. So simulating based on this kind of designs and implementations, we tested it, and we found out that the cost will be just 1 mil only for operating our prover if we learn the GK rollup. Recently, I checked the recent profit of the Arbitrum and the Optimism. And Arbitrum is the top one, and Optimism is top two active rollup. So their monthly revenue is Arbitrum 1 million, Optimism just a little less than Arbitrum, and the proving cost is more than their profit. So I thought we cannot start as a GK law. So for now, we are put our much effort to optimizing the GK proving cost and speed. So currently we are implementing the Hackathon. It's our brand new open source project. We did not open all of the sources yet, but we are going to open all these sources. It's optimizing our low-level GK proving operations like multi-scalar multiplication and hash computation, and so on. And also, we are designing and implementing parallel GK proving pipeline. After completing all these proving pipelines, we can move to the GK rollups. So actually, I think it's very simple. If we complete all GK related stuff, we already have some GK friendly data structure and algorithm. And only thing that we need to do for moving to the GK rollup is to put GK proof to the checkpoint output. So we are going to have transition period. And if it's successful, then we can smoothly move to the GK rollup. That's all. Currently, we are just about to launch our mainnet in a few days. So we completed all these stuffs, and we already gathered our Security Council members. So, it's very exciting to have that mainnet soon, very soon. So we are going to expand our ecosystem in the future, and I think the most exciting part is that we are going to have Web3 version of the Nightcrawls. We are backed by the WeMade, and WeMade will be launch the Web3 version of the Nightcrawls, and the Chroma will be the only layer, Ethereum layer 2 that have the Web3 version of the Nightcrawl. So we are currently implementing the prototype sharding, account abstraction, and also we have some unique zero-start tokenomics. We're going to release all about these tokenomics soon. And we are going to have DAO. And end of this year, we are going to have GK rollup testnet, hopefully. And also, I hope we can have GK rollup next year. Yeah. You can check all these resources. You can visit Chroma.network, and you can move to the other resources from our hub. So, yeah, this is my presentation. So, do you have any question? Yeah. I'm sorry. Do you need the mic?
Thanks. You were talking about like profitability of the ZK VMs, how like they're really unprofitable compared to the fraud-proof ones. Which of the ZK VMs that are out there like are profitable right now, or are even close to making money, if any?
Actually, I didn't show our research, but we checked the security cost and the fee cost. Actually, I'm not sure who is makes profit from their mainnet. So actually, I'm not sure.
Oh yeah, no worries. I was just curious. Thank you.
No more questions? All right, give it up once more for. Thank you. Thank you very much, DJ. Looking very forward to the mainnet launch. Next, we have Ben from Axelar. Yeah, Ben. Sorry. You're gonna use your computer. Okay. You can use this table here. We'll connect your computer to the HDMI. Well, you can start whenever you're ready. Yeah. 여기도 코딩도 같이 해야 될 것 같아가지고. So do you want to start with the presentation first and then move on to the?
I have the presentation here as well.
Okay, then we'll just use your computer for everything. 그냥 이 컴퓨터에도 프레젠테이션 다 있다 그래서 이걸로 그냥 쭉 쓸게요. 컴퓨터로. 아 그래요? 그럼 그냥 PT는 Got it. 네. 조금만 있다가 하나씩만 더. Okay, everyone will be starting in 2 minutes.
Don't like. It's not that bad. You don't have to run around like.
Let me go check. Yes.
I can. Yeah, I can go. Okay. Yeah. No worries if you don't have.
No worries.
This thing on? Yeah. Cool. Hey everyone. Thanks for coming. I know it's a hot day here, so I appreciate you sticking it out. rather than being out in the comfort of the AC. So my name is Ben Weinberg. I'm a developer advocate with the Axelar team. And from Toronto. It's my first time ever in Seoul or even in East Asia, so it's really cool to be here. And thanks for coming out. So lots to get through. We're going to start off with the need for interchain, brief history of the space, like how we got here and why we need interoperability between blockchains. We're going to then move on to the problem with pairwise bridges as they've existed over the past few years. Then we're going to give an overview of the Axelar network and some of the advantages which it brings to the table. Then we're going to talk about general message passing, or GMP. This is, I think, the really cool part. For those of you in the hackathon, our bounty is actually on best use case of GMP. So it should be helpful. And then we're going to have an actual code example of GMP in action. And we're going to end off with some cool stats and just look at Axelar in the wild as well, like some actual production apps which are using Axelar. OK, so thanks. So a bit about myself. About me, so I got into the space back in late 2017. And for me, when I was trying to get into blockchain, I spent a lot of time going to meetups and events. And sorry, I cut my finger here. And when you'd go to these events, I'm sure you guys had a similar experience to myself. It was a lot of going to these events, and you'd meet a lot of people, and they all seem to know a lot more than you do as a beginner. And they're all very, very opinionated, promoting different projects which they're either invested or that they believe in. So these are some of the big projects that were around. There was, of course, Ethereum, which is still was the biggest player back then, and still the biggest player today. But there were other projects which some of you may have heard of, like Neo, IOTA, Tron, EOS. Neo was kind of branded as the Chinese version of Ethereum that was backed by the government there, and that was going to be very popular there. EOS was branded as Ethereum on steroids because it was faster and cheaper than interacting on Ethereum. And many of these blockchains took on the term Ethereum killers, meaning that Neo, for example, is going to be the blockchain to slay Ethereum and be the be-all, end-all blockchain. And this mentality, which was around at the time, and even today to some extent, but not as much, is this idea of chain maximalism. In other words, that there will be one blockchain to rule them all, and that's the end of Web3. And I think it's safe to say now, looking back, that what we've learned is that chain maximalism is wrong. We never actually saw one blockchain to rule them all. Yeah, you got it? Sorry, guys, I just cut my hand. I really need a Band-Aid here. Thanks, everyone. Yara, the lifesaver. Sorry, be careful on the door there. You can cut your finger there, too. Yeah, so what I was saying was chain maximalism, this idea of one blockchain to rule them all, never really happened. Instead, what we saw was the rise in the need for interoperability. And why do I say that? Well, if you look at this little screen recording I made here on a website called Chain Analysis, if it would load, can I full screen this? This is simply Chain List, not Chain Analysis. Chain List is a website which shows many of the blockchains that exist today. I say many, not all, because it's impossible to actually know the list of every blockchain that exists. But if you just watch this video for a bit, you can see that there's hundreds, if not thousands, of blockchains that exist. And that number is only continuing to grow. And many of these blockchains are built in different ways. Some of them are optimized toward privacy, some towards decentralization, some towards security, some towards speed. We've even seen the rise of app chains, which are blockchains who have one specific use case. For one app, we have an entire blockchain. And it's really clear to me and to much of the space that with the number of blockchains rising so much, the need to interoperate between the communities on this different blockchain to access the liquidity that exists on these different blockchains is greater than ever. So this became clear, not just now, it became clear a few years ago. Let's see, guys, switch slide. Yeah. And what we saw was the rise of these pairwise bridges. And what these pairwise bridges allowed us to do was to use wrapped assets, such as WETH, which is wrapped Ethereum, or WBTC, which is wrapped Bitcoin. And these are basically tokenized versions of these assets. One WETH was equal to 1 ETH in terms of its dollar value. And it was cool because you could now use these tokens on different blockchains. So it's it gives you this illusion that you can actually use your ETH on different blockchains, but you'd be using the wrapped version. And many of these bridges were using multi-sig contracts to basically secure themselves. So very briefly, for those who are unfamiliar with multi-sig contracts, a multi-sig contract is a design pattern which allows a transaction to be basically guarded in the state where like you need more than one signature to actually sign the transaction. So rather than just signing a MetaMask pop-up, you actually need, like in this case, 3 signers of the 4 eligible parties. So in this case, you can see myself, my younger brother, my parents who didn't want their picture on this slide for whatever reason. And you can see here that like 3 of the 4 people signed it, so the transaction goes through. And these are great, multi-sigs are awesome, but for bridges which are sometimes securing like hundreds of millions of dollars, they're a little insufficient on the security front. And you can see here, I'm not sure if you guys can read the font here, but these are some of the notable bridge hacks that have occurred. The most famous one probably being on the top left corner there, the Ronin network bridge hack, for anyone who's familiar with like Axie Infinity. Was hacked for like $625 million. On the top right, the Poly network bridge that was hacked just earlier this summer was actually a 3 of 4 multi-sig, basically like what I just showed, and they had their keys compromised. And an interesting article by Chain Analysis, not Chainlist, Chain Analysis this time, but came out about a year ago, and they said, I know it's hard to read, but they said that 69% of total funds that were stolen in 2022 in crypto were actually attacks on these bridges. And that's about $2 billion worth. So what do we know? We know that chain maximalism is wrong. We know that there is a rise in blockchains and that interoperability is more important now than ever. But we also know that there's room to improve in the way we conduct interoperability as an ecosystem. And that's where Axelar comes into the picture. So what is Axelar? And the simplest way you can explain it, Axelar is a blockchain that connects blockchains, enabling universal Web3 interoperability. That's a bit of a mouthful. So let's break this down. I'm going to start off with the last 3 words here, universal Web3 interoperability. What does that mean, and why is that so exciting to me? If you look at this diagram here, you can see basically a map of the Axelar ecosystem with some of the blockchains that are connected to Axelar. You can see it's a hub and spoke model. So any blockchain that wants to communicate with each other goes through the Axelar network. And I want to go back to those 3 words I had before of universal Web3 interoperability. Why am I focusing in on that? Because if you look at the name of the blockchains here, I know it's a bit distorted, so hopefully you guys can recognize some of the symbols, but let's go through some of them. You have like Ethereum, Polygon, Avalanche. These are EVM-based blockchains. Underneath Ethereum, you see Osmosis, Juno, the Cosmos Hub. These are Cosmos-based blockchains. You even have Arbitrum here on the bottom right. We have Linea, we have Base, Layer 2 blockchains. So you can see here that there's many different types of ecosystems that are being connected here. It's not one consensus mechanism. It's not one virtual machine that's running. It's true universal Web3 interoperability. The other big, the other thing I was talking about here was that it's a blockchain that connects blockchains. So what do I mean by that? Well, right out of the box, we have 2 major improvements that come with Axelar. And those are in terms of scalability and in terms of security. So let's focus on the scalability improvements first. So let's think of pairwise bridges. Let's say we have 3 blockchains, say Ethereum, BNB, and Polygon. And we want to connect each of those blockchains to each other. So for those 3 blockchains, you can count here the bridges. You see we need 6 bridges to connect each of those blockchains to each other. Let's say we want to throw in some clouds. We want to throw in one more blockchain, say Avalanche. For a 4th blockchain, we now need 9 bridges to connect each of these blockchains. So now imagine, remember that list I showed you with a chain list? Imagine those thousands of blockchains that are on there. If you want to connect each of those blockchains to each other, that's a tremendous number of bridges you're going to need. So we need a more scalable ecosystem. What Axelar offers is, if I go back to the slide here, is a hub and spoke model. So any blockchain that is connected to each other, we don't need a bridge to connect each of these blockchains to each other. All we need is to go through the Axelar network. So you just need one setup, one connection to the Axelar ecosystem, and then right out of the box, you're connected to the 49 different live blockchains that are on Axelar today, rather than needing a ton of bridges to connect to each of these 49 blockchains. The other major improvement that we get right out of the box is, in addition to scalability, we get security improvements. So, and going back to this definition I have here, Axelar is a blockchain that connects blockchains. So for security improvements, like I said, Axelar is a blockchain and runs the proof of stake consensus mechanism. There's currently 75 live validators on maintaining the ecosystem. Anyone in the Cosmos ecosystem here might be familiar with some of these validators. There's like Figment, Informal Systems, Pokachu. These are validators that are very reputable. They're maintaining many of the other blockchains in the Cosmos ecosystem. And having an actual blockchain that is handling interoperability for the space is a tremendous step up from just having like a 3 or 4 multi-sig contract like I was showing before. There's tremendous improvements there in terms of security. And it's really, really cool to think that what is securing the interoperability layer of Web3 is the same security that's the blockchains that we're connecting are actually using themselves. That's, to me, really, really cool. So I just realizing we didn't full screen here, but anyway, going to the next slide, the thing that's really exciting to me and hopefully to you, for those of you doing the hackathon, is general message passing. So on a high level, what is general message passing? Well, let's backtrack a bit. Remember what I was saying before, the early days of interoperability, what could we do? We can use like WETH or WBTC, actually use wrapped assets between different blockchains. What general message passing allows us to do is much more advanced and like more authentic interoperability. So what we're seeing here in this example, we see myself here on the Ethereum blockchain on the left, and myself on the right on the Avalanche blockchain. And I know the font's a bit small, but basically I'm saying like, hey, WAGME, are we going to make it in this crazy, amazing space of ours? And then myself saying back like, hey, SafeMint, like 5 Bored Apes. So what I'm trying to show here is, yeah, we can actually send like little hello world messages like I'm doing in the first line. But what we can also do, which is really, really exciting and cool to me, is actually calling functions that exist on other blockchains. And that, to me, is true interoperability. It's the idea that we can actually interact with contracts and applications on other blockchains as easily as we could as if they were on our own blockchain. Brief overview of how GMP works. This is a simplified diagram. But let's walk through this together. And I'm sorry, I know the font is a little bit small. Let me just go back to, there we go. Hope this is a bit bigger. But let's go through this example. We have 2 applications here. One on the Ethereum blockchain on the left-hand side here. One on the right-hand side here on Polygon. This is the same application. And imagine we want to send an ERC20 token from Ethereum to Polygon. Well, the first thing we want to do is interact with something called a gateway contract. A gateway contract is a contract that Axelar has deployed on every single blockchain that it interoperates between, on the EVM ones. And this gateway contract exposes functions that we can use to basically initiate transactions into the Axelar ecosystem. So one of these functions, for example, is this guy right here, call contract with token. This is a function that exists on the gateway. So I have my dApp. My dApp has whatever logic that's in there, and I call a function, and this function runs a bunch of stuff, and it runs the call contract with token. That then triggers the gateway contract. The gateway contract emits an event, which is then picked up by the Axelar network, who are maintained by the validators. Remember, the Axelar network is a blockchain. These validators basically come to consensus about the message that was sent, and they notify the gateway contract on the destination chain. So everything on the left here is Ethereum land, on the right here is Polygon land. And each of these blockchains have a gateway contract. When the message is picked up by the gateway contract on Polygon, it triggers a function called execute with token, which runs some logic on our dApp. And we're going to see this all in a code example. But one more time on a very high level, dApp on source chain calls a function on gateway. Gateway emits an event to the Axelar network. The network comes to consensus, notifies the gateway on the destination chain, and then the gateway eventually triggers a function via something called a relayer, called execute or execute with token. And then we handle some logic there in our dApp. So let's see this in action. Can you guys see this? I know it's a little small, but can I get a thumbs up if you can sort of read it at the back? Or good? OK. So we have an example here, which we're going to try do something basically like I just explained. We're going to try send an ERC20 token from the Avalanche blockchain to the Polygon blockchain. And for time's sake, I'm going to flip between branches rather than write out the code, but you'll see what I mean. So let's start off here with what we got. First line, we import a standard ERC20 interface from OpenZeppelin. Next, we import our Axelar executable. I will get back to this, but make note of this guy. Then we import our gateway. Does that sound familiar to anyone? The gateway, that is this guy that we had on our previous diagram. So we import the interface for the gateway. And then we import the interface for something called the gas service. So, brief tangent. What is the Axelar gas service? When you're interacting with Axelar, there's two key contracts you need to know about on your blockchain. The first one we talked about was the gateway. The second one is the gas service. And you're going to need to interact with both of these guys to send an interchain transaction. What the gas service does is it abstracts a lot of the difficulty in sending an interchain transaction. Why is that? Well, think about it. If I want to send a transaction from Avalanche to Polygon, I need, if you think about it, 3 tokens. I need AVAX, the token of the Avalanche blockchain. I need Matic, the token of the Polygon blockchain, though I heard they're changing the name of that. And then I need AXL, the token of the Axelar blockchain, to pay the gas on Axelar. And I don't know about you guys, but that is a pain to me. I don't want to need to worry about 3 tokens each time I want to send an interchain transaction. So what the gas service does is it extracts a lot of that difficulty away. It basically handles the gas payment on the Axelar blockchain and the Polygon blockchain so that me, as the sender on the source chain, which in this case is Avalanche, all I need is AVAX, and then I can rest easy knowing that the gas service is handling the payment on the Axelar blockchain and the Polygon blockchain. Now, to be clear, that doesn't mean we don't have to pay that gas cost, like it's eventually coming out of our pocket, but we don't have to worry about actually having all 3 of these tokens to send the transaction. So if we want to go to step 2 here, if I could find it. Step 2 is very straightforward. We define our gas service variable, which will basically serve as the variable we use for the Axelar gas service interface, what we just talked about. And we basically pass in the address of the gateway contract and the gas service contract here in our constructor. So now we have access to these two contracts that we're going to need to interact with to send an interchain transaction. Step 3 is where it starts to get interesting. We define this function called send to many. What send to many function is this is the function that we're going to use to actually trigger our interchain transaction. So we take 5 parameters here. The first is the name of the destination chain. In this case, we're sending a transaction from Avalanche to Polygon. So what do we pass in? We're going to pass in Polygon. That's what we're going to. Next, we're going to take in the destination contract address. What's that? That is this entire contract, which by the time we're done here, will be deployed on Avalanche and on Polygon. If you remember this diagram that we looked at earlier, we're going to need to have both of these contracts deployed on our source chain and our destination chain to be able to actually interact with it or to send an interchain transaction. Third is our destination addresses. I will come back to that again in the future. And our last 2 parameters are our symbol for our ERC20 token that we're sending and the amount. How many of this ERC20 token are we sending? So 5 parameters. Third one, I owe you an explanation for still. We'll get to that. If we go to step 4, we start to write out this, this function. First thing, very standard. Require message being basically saying like, hey, we need some gas. If you don't send any gas, revert immediately, say like, hey, you need to send gas. Next, first interaction with our gateway contract. What do we do here? We pass in the token symbol that we're going to be using. In this case, we're going to be sending something called AUSDC, which is a wrapped version of the USDC token. And we basically say, hey, gateway contract, we're using the AUSDC token. And the gateway contract will spit out the address of the token that we're using. So we just obtain our address here for the token. Next, these 2 lines, some standard ERC20 stuff. We transfer the funds from me, the caller, to this contract. And then we approve the gateway contract to handle these tokens on our behalf. Sorry, hot day, guys. Last thing we want to do here is encode our destination addresses. What is that? That is this 3rd parameter that I promised I'd get back to. So our destination addresses here is what's going to be our actual message that we're passing. If you remember what we're trying to do here, we're sending an ERC20 token from one blockchain to the other. But what I wanted to show you guys was general message passing, GMP. So what is the message that we're going to be passing? Well, we're going to be passing a message which is the list of an X number of addresses. And these X number of addresses that we're passing are going to be the recipients of our ERC20 token on our destination chain. So what we're going to do here very simply is pass the USDC, our token, and then we're going to send that token on our destination chain to these like 3 or 4 addresses that we pass in. So what we're doing here on line 47, for a GMP message, we basically have to encode that message. So that's what we're doing here. We take this array of addresses and encode it into this variable here. Step 5, I promise we're almost done here. We now interact with our gas service and our gateway contract. So we basically tell the gas service, like, hey, I'm going to be paying for this, this execution. We're going to need gas for the Polygon blockchain, which is our destination chain. And we pay the gas that way. And then we have our gateway call, which is call contract with token. And I hope you're not getting dizzy as I flip back between the two slides. But if you recall call contract with token, this green guy right here is what we actually have here in this diagram. So this is what's going to trigger our interchain transaction via the gateway contract. And what do we pass into call contract with token? We pass in the 5 parameters before: the name of the destination chain, Polygon, the destination contract address, this entire contract address, which will be deployed on Polygon, our GMP, so our encoded recipient addresses that we passed, that we defined here, and then our token symbol and our amount of token that we're sending. Next, we get to our final function, which is our execute with token. This function, if we go back again, is our 4th step here. So this function will get executed on the destination chain. Remember, the previous function is what we use to trigger the transaction when we're leaving Avalanche, and this next function here is what we use on Polygon when we're coming back, when we're on our destination chain, we're receiving the transaction. So the only parameter here to make note of is payload. Can anyone guess what the payload is going to be? It's going to be our GMP message, those 3 or 4 addresses that we're passing in right here to our gateway contract. So then our final thing we want to do here on step 7 is we want to write out some very simple logic here on our execute with token function, which is going to be to, hey, like decode that message that we sent in, our addresses, our GMP message. We then, once again, talk to the gateway contract, which now is on the Polygon blockchain. And we pass in the token symbol. We get our address for the token on Polygon blockchain. Then we run some very, very basic logic here, which is basically how many tokens are we going to send to each address. So let's say we send in 3 addresses as our GMP. We send 6 tokens. So we divide the tokens by the addresses, so we get an amount of 2. So we're going to send 2 tokens to each of the 3 addresses that we sent in. And then we loop over the addresses, and we transfer the tokens to each address. So one more time, very high level. We call send to many, which sends USDC tokens. Along with those USDC tokens, we pass in a message. That message is a list of addresses. We pay the gas. We call it here on our gateway. Then on our destination chain, execute with token gets called automatically. We decode the message, so now we have our list of addresses, and then we send those tokens to each of the addresses. So let's fire this up. First thing we want to do is deploy. And we, of course, have an error. We are on the wrong branch. Let me run this guy again. So we give this a minute. We have a deploy script. I'm not going to go into it now. I can show you guys later if you're curious to see it. One-on-one, I'm going to be hanging out here. But basically what this is doing now is it's deploying this contract that we defined, GMP distribution, on each of the 2 blockchains. So it's deploying it on Avalanche and on Polygon. And nice, we got our Polygon deployment is up, and hopefully our Avalanche deployment should follow suit very quickly. Nice, okay. So we have this contract now on 2 blockchains. Let me hold this. I'm going to use the hard hat CLI to interact with this contract now. So we fire it up. We want to deploy, we want to interact on Avalanche. That's going to be our source chain. Let me take it out. We want to interact on Avalanche. So we grab our contract address. So now we have our Ether's contract factory object. Now we need to attach the address to our factory object. So let's pass that in. So we take the address here, which we deployed on Avalanche, and we pass that in right here. Now we have a contract object that lives on the Avalanche blockchain that we can interact with. So if I want to call like the gas service public variable here, I can go wait. And you see here we can interact with the contract. So what do we want to do? We want to call this function that we wrote up, send to many. So we want to pass in our 5 parameters. So the first one is going to be Polygon. That's the name of the destination chain we're going to. Next one is going to be the destination contract address. So remember, we deployed this contract on the Polygon blockchain. So we have our address right here. We pass that in as our second parameter. We then want to pass in our GMP message, which is the list of 3 addresses, or 4 or 5, however many we want, that we're sending this token to. So I have a list here that I'm going to pass in as an array. We then pass in the token symbol that we're sending, which is AUSDC. And then how many tokens do we want to send? Let's send like 6 tokens. 60,000. We sent 6 million just because USDC is 6 decimal points, so 6 million is actually just 6. And then the final thing we want to do is pass in our gas. Otherwise, remember, we'll revert here on line 37 with this message. So we pass in 0.1 AVAX. And now, if all is well, this should work. Sweet. We have a transaction hash. So let's go to a really cool feature which Axelar has for us. This is the Axelar Scan Block Explorer. And you can see some stats on the Axelar network, which we will go to in a bit. But I'm going to pass in our transaction hash here that we just generated. And on Axelar Scan, we can actually see the step-by-step of an interchain transaction. So you can see already the gas has been paid. We're waiting for finality right now on the source chain, which is Avalanche. You can see if I click here, I can actually see this transaction on Snowtrace on the Avalanche Block Explorer. We're currently having the transaction confirmed on Axelar. So going back to here, the first 2 steps, when we send the transaction on Avalanche, we can see are mirrored here. The next step is we're in the Axelar network. So we can see that here. It's getting confirmed. Then it'll mark an approved message to the gateway on Polygon. So the next thing we'll see up here is a transaction on the Polygon destination chain. And then our final step will be to execute the logic. What logic are we executing? It is this function that we wrote up here that is going to be triggered automatically. So that's going to receive our message, take our USDC, and send it to each of our recipients. And it is hopefully going to execute in a second. There we go, executed. So now, should be able to see on Polygon our 2 AUSDC token being sent to each of these recipient addresses. Let me make this bigger so you guys can see. You can see these 3 addresses that I passed in as our GMP are now receiving equal splits of our wrapped USDC token on each blockchain. So it worked, and we can see the kind of guts, the step-by-step of this transaction here on Polygon Scan. So I'm not sure if I have another minute just to talk about some projects that are live today. Am I good for another minute?
5
Okay, perfect.
minutes,
Yeah, won't take that long. So I just wanted to talk on some projects that are live on Axelar today for some inspiration for you guys. So a really, really cool team is the Squid team. And what they have, they're basically leveraging the Axelar technology and they have a very clean UI to basically show off interchain transactions. So you can see here, the Squid team has a sort of swapping tool which people can use. This UX might look very familiar to anyone who's used Uniswap before. You can see on the right-hand side, you can pick the tokens that we want to send. The difference is that with Uniswap, we have to point via MetaMask or something, which blockchain are we on? Are we on Arbitrum? OK, let's swap tokens on Arbitrum. On Squid here, you can actually also select the blockchain which you want to swap between. So you can see here, I'm swapping on Ethereum, GRT, which is like the Graphs token, for USDC on Optimism. I can do this all with 1 click and have a true interchain transaction with Squid. So if anyone wants to check that out, that's app.squidrouter.com. Another one is in the gaming space, Junkyard NFT. Basically, this is a kind of fun little game where for anyone who has purchased NFTs that they regret and you don't like them anymore, you can dump them in what's called the Junkyard, and then you can fish out new, hopefully valuable NFTs. And then the way they're leveraging Axelar here is, rather than just limiting themselves to one ecosystem of NFTs, you can actually deposit NFTs from different blockchains, or many different blockchains, via Axelar. some stats here. The last thing I want to end on the Axelar blockchain, which we saw these stats briefly on Axelar Scan. I'm not sure if you can read them, but some of them are like GMP transactions. So like we've seen over 100,000 GMP transactions. Volume, the amount of dollar value that's gone through the Axelar network, $4.5 billion almost that's gone through. We're currently working with 49 different blockchains. And the really, really exciting thing about some of these numbers is that this is just the last 30 days. This is over almost $4.5 billion of transactions. So it's a really good time to get familiar with the Axelar ecosystem as a developer. And here are some resources for anyone who wants code examples. On the left here, you can scan. This is like a video series which the DevRel team has, like walking through examples. On the right is actual GitHub repository with code examples, which you can see with like end-to-end, front-end, contract examples that you can see. And that is it for me. If you have any feedback, feel free to submit it here with this Google form. My name is Ben Weinberg, and thank you very much. I'm going to stick around, walk around here if anyone has any questions or just wants to talk. Thank you, guys.
Thank you, Ben. Next, we have Sam from Skyrim to Solidity. You'll be connecting your computer here.
Thank you.
Yep.
Yeah. Thank you. All right.
The robot under the sun.
The robot under the sun works very great. Like it's part of our lore, so we need to respect.
Got it. I respect that.
All right. Okay.
여기도 컴퓨터 연결할 거예요.
네, 꽂으시면 돼요. 네.
그럴 것 같아요.
All right, no worries.
15 minutes-ish.
That will do. Then I think 10 minutes should even be.
Okay, that's
sufficient.
perfect.
15 minutes.
10, 15
Max.
minutes, yeah.
Yeah. Great.
Here's your mic.
Does it work? Oh, it does. Wonderful. All right. My name is Sam, and I work at Node Guardians. I'm very humbled by this warm welcome that you guys are giving me. I hope that the pitch that I'm going to give you will be matching your expectations. But yeah, let me introduce you to Node Guardians. First of all, I'd like to know who in this crowd is a developer. Don't be shy, guys. I'm like an NPC asking you a question. You like, all right. Who is into security? Like really takes interest into like the EVM and like shipping safe contracts? Two of you? Okay. Who is more into actually shipping and building stuff as we're in the context of a hackathon? No one. Okay, it's fine. So, Node Guardians is basically a platform for seasoned developers to challenge their skills and build meaningful things on different ecosystems within the space. The way it works is extremely simple. I'll be sharing the screen and demoing the whole flow. All you need is a Web3 wallet or a GitHub account, and you're good to go. No fluff, no bullshit, no ads, no paywall. You come, you hack, and then things happen. I'll be showing these things. So I am on the Node Guardians interface, as you can see. I'm going to log with my GitHub here. And once I'm logged in, a little bit like in a role-playing game or PUBG or Lineage for the boomers, I'll have to solve quests. So quests are lore-rich, story-rich programming challenges in the form of CTFs and more general programming challenges that we call build. I'm going to showcase a few here. So you pick a quest, a little bit like in any game, could be StarCraft, whatsoever. Each quest has its own story that unfolds as you complete it, and you hack through it. So I'm going to take that one, for instance. I pick that challenge. I load it. There's some story that I can skip. And then I have all the inputs that I need to solve the actual problem. A little bit like in a role-playing game, there is a story, and your code, the code that you ship is going to determine what is going to happen, what step of the story you're going to unlock, and a few other things. The flow here is that we do not have an IDE like Remix, an in-browser editor. because we really want the experience to be as close as production level coding. So you set up your environment, whatever you're comfortable with, and you hack your way through. So here I have the contract that I will deploy on Girly, and I am good to go. In that case, I am gonna need to break this contract using reentrancy attack or other attack vectors, take the money away from it, and our contract called the verifier will monitor the state to see if you have altered the contract in a proper way. And now, a little bit like in any competitive game, you would unlock the next step of the story, but also, based on your efficiency and some other parameters, the rewards that you get may vary. And so, let's speak about these rewards. This is not a play to earn or learn to yearn or play to, yeah. It is actually, you get attestations when you complete a challenge in the form of soulbound items, soulbound gold, soulbound crafting materials. I know it's like 2023, and just solving challenges for the sake of improving your skills is probably not enough. A lot of us have ADHD, and probably like a lot of social networks to monitor. I'm in that case too. Ultimately, the outcome that you want from this platform has to be very tangible. So beyond just being a platform to hack, this is actually a trust network. So here, I have EVM Monster, which is our demo character. And as you can see, it's like pretty well stuffed, pretty hot. Each of these items are kind of tied to the completion of these challenges. And these items will be mintable and composable. And that's where it gets interesting for developers and non-developers. Because you can tie the delivery of one of these items or the possibility to craft one of these items with a specific opportunity. Let's say you're Aave or Radius or even Hashed, right? You want to hire a security researcher, a smart contract engineer, a compiler engineer. You can, or we can, if you want, design a spicy programming challenge to gate access to that opportunity. So you can say, hey, the first people to first blood that challenge, they get access to that group if they consent, where they can be match-made with our recruitment specialist. You save time because you don't have to go through 1,000 like curriculums, etc. And you know that the candidates that you're dealing with are likely to be fit with your specifications, your criteria whatsoever. So you can think of all sorts of use cases that leverage that trust and all these items that we distribute. So a little bit like in World of Warcraft and all, let's say, status quo MMORPG. You get to craft things, you have a forge, and there's a vanity element that's very interesting here. We have a leaderboard and an Elo ranking that's in the works, and some kind of Elo ranking that's in the works, not there yet, but based on your completion of the game and some other parameters, you're climbing up the ladder. Some people tend to try hard doing this, and that gives their profile a better aura. I think Subin is a known try-harder. I'll give you a shout-out. Thank you. Thank you very much. The idea is that you're building some kind of Web3 curriculum, and that's where it takes you to meaningful opportunities to some extent. One example that I can give is this one. We designed a quest called self-hosted EVM. So self-hosted EVM is a challenge where you have to implement your EVM on top of the EVM. And if you actually succeed at doing this, that suggests that you might be familiar with the intricacies of the Ethereum virtual machine. And what we decided to do is that the 5 first solver of that challenge get a reward. But we never say what's the reward, because if we start to say that there's money at stake, then that might trigger some malicious behaviors and actually get maybe like not the most suitable people to come on the platform. So we never disclose financial incentives. There's always something at stake. But the thing that mattered here is that most of the people that completed that challenge are now working as open source contributors on Kakarot and making something meaningful in the sense that they're contributing to a production level project and making money on the side. And that's pretty much one avenue to actually build things in that space. Don't be shy. Come, hack, build the best profile, like learn things along the way, and yeah, eventually get involved with an ecosystem that is relevant to you. So I'll add another thing. Beyond just being a platform, it is also a community. And so if you're also more of a beginner and you happen to struggle with some of the challenges, any engineer at Node Guardian is actually a community manager, a customer support specialist, and will be more than happy to help you, give you some hints. And the community, because it's a community, will also be happy to lend you a helping hand. And as you climb the different ladders, you have scholars, mages, high mages, guardians. You also get access to some cool perks. Like for instance, we do some conferences like Starknet CC, etc. If you have a certain status within the Guardians, you can get there without getting a ticket. And there are a few other things that we're preparing that might make it even cooler to be part of that community. But I really insist on the fact that from a developer standpoint, this is a public good, and we're not going to ask you to sign something or retweet something to access chapter 2 or that kind of stuff. No fluff. You just come, you hack, and you take whatever you want, and we want to keep it as pure as possible. And ultimately, we want this product to be better, and in order for it to be better, we need your input. And you can actually contribute, like the amazing Kaylin Young here, who did an elliptic curve cryptography campaign on the platform. We welcome any person that wants to teach a specific design pattern or a specific concept to contribute. And yeah, we'll be more than happy to discuss and collaborate with you. And we're extending that concept to open source. So if you're running a project and you want to, for instance, have a certain component of your stack that is built through the Node Guardian system, we're creating something called relics. Relics are unique items in the game. There's only one copy of it. And it is issued to the person who has solved the open source query that you're basically adding on the platform. Then the person has the choice to either keep the relic for the sake of vanity, because it's a sin we all like, I guess, or they can burn it. And then it might redeem the funds that are tied to the relic. So that's also a component that's coming slightly after our V1 that's coming up next month. And I encourage you to check it out. I have some slides called a copy of presentation of ECC Seoul. That's a terrible name. But yeah, it gives some more like a breakdown of how the platform works. So I'll just complete my presentation by adding a few details, some metrics maybe. And we're out of time?
No, you have time.
All good? Okay.
Like a minute or two.
Yeah. So you have 4 types of challenges: build, CTF, resource management, also known as gas golfing for the OGs, and theory. So there's quite some diversity based on what you want to learn, what you want to do. And the whole process is automated. You install our GitHub application if you want to do a build challenge. Then we write tests in Foundry, and we're able to see if your code satisfies the specific criteria that we have defined. And if it's a CTF, everything happens on chain. So if you do the right thing, we're able to see it, and we're able to issue the Soulbound reward. For the theory, it is just a set of articles on a given topic that you might need before doing a practical challenge. If you want to do something about stealth addresses, it would be nice to have an understanding of how ECC, elliptic curve cryptography, works. So that's something that we're also trying to offer through the platform. Yeah, that's the loot stuff. That's the PvP aspect. Why solving, the whole evolution process within the platform. And yeah, we also have IRL events. You can contribute to OSS through the platform. That's what we said earlier. It's not a pay to win, so skill prevails. And yeah, we have about like 900 active developers. Korea is actually the 2nd country on Node Guardians. Since yesterday, we flipped America. So I would like to extend a huge thank you. I don't know how you guys do it, because that's a lot of users per capita. So I really hope that we can keep on this trend and flip the redacted #1 within the ranking. They're #1 country, so we flipped America. Really moving. I really appreciate that. And yeah, 6,000 challenges have been completed. And again, you're welcome to contribute and become a contributor or Templar within the platform. We've had contributions from researchers at DEF, also security researchers or people working at different protocols. And yeah, it's viable and valid for Solidity, but we're also expanding to other zero-knowledge domain-specific languages. Has anyone heard about Cairo? Oh, not bad. Actually, not bad. That's almost half of the crowd. So we also teach it the same way, and you might see some Noir stuff coming up pretty soon. And yeah, I think that's pretty much it. If there are any questions, I'll be more than happy to answer them. And I thank you for your time, taking the time to listen to this. And yeah, have a wonderful day.
Thank you, Sam. We're going to have a short 15-minute break until 3:30, and then we'll come back, start with a speech from Hash. Yep. 이제 시작할게요. Okay, everyone, please take a seat. We'll be starting now. Okay, please invite Subin from Hashed, from raw data to insights. Thank you. 이걸로 하시면 돼요. 저희가 스크린은 띄워놓을 거거든요. 네.
이렇게 넘겨도 되죠?
근데 이거 지금 연결하신 거예요?
네, 연결했는데.
이번에도 그냥 컴퓨터로 하시겠다고 하시거든요. 네.
Good afternoon. Yes. Sorry for non-Korean native people. I just prepare for the Korean. But I will upload in Korean English article soon. So let's start. 안녕하세요. 해시드의 데이터를 담당하고 있는 안수민이라고 합니다. 반갑습니다. 그래서 오늘의 주제는 로우 데이터에서 어떻게 인사이트를 뽑는가라는 주제인데, 제가 이제 해시드에서 1년 정도 데이터 분석 리드를 담당을 하면서 가장 많이 듣는 질문이 어떻게 하면 온체인 데이터 분석을 할 수 있는가라는 질문을 많이 들었어요. 근데 이제 온체인 데이터 분석 자체가 아직까지는 그렇게 심화되지 않았고 엄청 어려운 난이도가 아니라서 지금 레벨에서는 많은 분들이 할 수 있거든요. 그래서 어떻게 하면 온체인 데이터 분석을 쉽게 접근할 수 있는지에 대해서 한번 준비해봤습니다. 그래서 이제 왜부터 시작할 건데, 혹시 온체인 데이터 분석을 보신 분이 있을까요? 네. 오, great. 그럼 왜 온체인 데이터 분석을 보통 보죠? 그래서 엄청 다양한 이유가 있을 것 같아요. 엄청 다양한 이유가 있을 것 같은데, 온체인 데이터 분석을 보는 가장 큰 이유는 더 좋은 선택을 하기 위해서입니다. 뭐 선택에는 사실 되게 다양한 애스펙트가 있을 것 같아요. 뭔가 프로토콜 기반에서는 프로토콜의 건전성을 확인을 하거나, 아니면 마켓 전략을 수립을 하거나, 또는 퍼블릭 대시보드를 만든 다음에 인게이지먼트를 조금 더 얻을 수 있는 기회가 될 수도 있겠죠. 그리고 약간 유저 사이드에서는 아까 이제 진영님이 말씀한 것처럼 트레이딩, 어떤 이코노믹 디시전이 될 수도 있고, 리스크 매니지먼트나 아니면 투명성이 될 수도 있습니다. 그리고 이제 해시드 같은 VC 입장에서는 여러 가지 측면으로 볼 수가 있는데, 뭔가 이제 새로운 투자건이 발굴됐을 때 테크 디드를 할 수 있는 경우가 있을 수도 있고, 또는 저희의 포트폴리오에 대해서 같이 데이터 분석을 통해서 인게이지먼트를 돕거나 아니면 그들의 KPI 설정에 같이 도움을 줄 수도 있겠죠. 그래서 이제 기존에도 데이터 분석 플랫폼은 상당히 많았습니다. 뭐 지금 보이는 로고들이 거의 다 데이터 분석 플랫폼이고, 사실 이거 말고도 한 10배가 넘는 데이터 분석 플랫폼이 있는데, 그리고 실제로 이제 해시드 같은 곳에서 데이터 분석을 실제로 이렇게 공유를 하기도 하죠. 근데 그럼에도 개인 커스텀한 데이터 분석을 하는 이유가 무엇일까라고 했을 때 정말 많은 이유가 있을 것 같고, 크게 저는 뭐 4가지 정도 뽑아봤어요. 첫 번째 경우에는 새로운 프로토콜을 디플로이했을 때 과연 이 디플로이된 프로토콜의 데이터가 있냐 하면은 대부분의 서비스에서는 이 데이터가 올라오지 않습니다. 단순히 로우 데이터로 트랜잭션 데이터만 있을 뿐 이거에 대해서 정리된 데이터는 없고요. 두 번째로 이제 마케터나 아니면 이제 비즈니스 디벨로퍼를 하시는 분들은 아시겠지만, 본인만의 분명히 가정을 수립할 때가 있어요. 뭔가 데이터를 뭔가 이런 A/B 테스트를 통했을 때 얼마나 인게이지먼트가 늘었나 이런 어썸션을 할 수 있는데, 그런 거에서 데이터를 수집을 하려면 결국에는 좀 플렉시블한 본인만의 데이터가 있어야 되고요. 세 번째로는 이런 데이터 서비스들도 종종 실수를 합니다. 그래서 예를 들면은 석세스한 트랜스퍼에 대해서만 뭐 합을 구하거나 그래야 되는데, 석세스하지 못한 트랜잭션에 대해서도 합을 구하는 등 그런 실수를 할 수 있기 때문에, 본인이 어떤 데이터 주권을 주장을 하기 위해서는 이런 데이터 소유권, 그러니까 본인이 어떤 데이터를 검증할 수 있는 실력이 있어야겠죠. 그래서 이런 것들 때문에 이제 데이터 분석을 진행을 하게 되는 거고, 그럼 이제 어떻게 하느냐가 되게 중요할 것 같아요. 어떻게 하느냐. 사실 이제 온체인 데이터 분석도 데이터 분석이기 때문에 사실 순서 자체는 되게 비슷합니다. 이제 맨 처음에 목표를 정하고, 두 번째는 데이터를 수집을 하고, 세 번째는 이 수집한 데이터를 변환을 하고, 네 번째로 이런 데이터 수집한 거에 대해서 통계 모델이나 AI 모델을 통해서 본인만의 가정에 대해서 검증을 한 다음에 해석을 하고 그 해석 기반으로 시각화를 한 다음에 문서화 작업을 통해서 사람들한테 공유를 해주는 거죠. 그래서 이 사이클을 반복하면서 결국 데이터 분석을 많이 진행을 하게 되는 거고, 온체인 데이터 분석도 마찬가지입니다. 근데 이제 온체인 데이터 분석이 다른 데이터 기존 분석과 다른 게 뭐냐라고 했을 때는 크게 네 가지인 것 같아요. 크게 두 가지인데 네 가지 정도의 어떤 허들이 있는 것 같아요. 일단 첫 번째로는 온체인 데이터를 어떻게 해석해야 되는가에 대해서 많은 사람들이 모르고 있습니다. 이 온체인 데이터라는 게 결국에는 트랜잭션 데이터와 블록 데이터밖에 없기 때문에 어떤 데이터를 합쳐야 되는지 모르거든요. 그래서 첫 번째로 이런 온체인 데이터에 대한 구조에 대한 이해가 필요하고요. 두 번째 같은 경우는 이 온체인 데이터들에서 어떤 매트릭이 있는가를 살짝 모를 수도 있어요. 세 번째로는 이제 이런 온체인 데이터 분석 플랫폼은 일반적으로 SQL을 기반으로 하고 있기 때문에 이제 이런 SQL에 대한 어떤 프로그래밍 스킬이 어려울 수도 있고, 네 번째로는 대부분 데이터 분석 과정에서 얻는 어려움으로 시각화가 어려울 수도 있습니다. 그래서 이제 지금부터 설명드릴 내용은 조금 듀네에 있는 데이터베이스 이름과 매칭을 많이 시켰고, 듀네에서 어떻게 데이터 분석을 할 수 있는가에 맞춰서 발표자를 좀 준비를 해봤어요. 그래서 뭔가 처음에 이제 여러분들이 쿼리를 만들 때 그 당황스러울 수 있어요. 처음에 보는 인터페이스가 이런 거거든요. 그래서 이런 인터페이스를 처음 봤을 때 느끼는 느낌은 나는 데이터 분석을 하고 싶었는데 도대체 데이터는 어디 있는 거지? 그리고 데이터를 찾았는데 여기서 각각의 데이터는 어떤 의미지? 나는 그냥 밈코인 트레이딩에서 알파를 찾고 싶었는데 과연 어떤 데이터를 어떻게 처리해야 되는 거지? 라는 생각이 들 수 있어요. 그래서 이제 보통 데이터 플랫폼에는 크게 네 가지 종류의 데이터가 있습니다. 첫 번째로는 이 블록체인에 실제로 기록되는 로우 데이터가 있고요. 그 다음에는 이제 이치 컨트랙트 기반으로 했을 때 그런 이치 컨트랙트에서 기록되는 이벤트라든지 그런 데이터가 있고, 세 번째로는 이런 이벤트 기반 데이터를 바탕으로 정리된 디코디드된 데이터가 있습니다. 이런 이제 로우 데이터를 이해하는 데는 그냥 기본적으로 이 트랜잭션 데이터의 흐름을 알면은 조금 더 쉬운데요. 기본적으로 그냥 트랜잭션 데이터는 크게 네 가지 과정으로 연결이 됩니다. 첫 번째는 이제 트랜잭션을 만들고 그거를 뭐 트랜잭션 내에 많은 정보를 담게 되겠죠. 누구한테 보낼 건지, 얼마나 많은 양을 보낼 건지, 가스는 어떻게 할 건지 뭐 이런 것들을 적을 수 있고, 두 번째로 이 트랜잭션 데이터를 본인의 프라이빗 키로 설명을 하겠죠. 그리고 네트워크에 보내고 그 네트워크에서 보낸 것들 중에서 검증된 트랜잭션들이 블록에 쌓이게 됩니다. 그리고 이제 블록이 추가가 되겠죠. 그럼 이제 이 프로세스를 기반으로 했을 때 데이터가 어떻게 쌓이냐고 한다면, 이제 월렛에서 보낸 트랜잭션이 뭐 펑션을 부르거나 아니면은 그냥 상대방한테 보내줬을 때 첫 번째로 트랜잭션이 보낸 데이터는 트랜잭션스에 쌓입니다. 그리고 이 트랜잭션들이 모여서 블록이 되겠죠. 근데 이 트랜잭션을 진행을 할 때 EOA와 CA가 상호작용을 하는 경우에, CA에서 CA 상호작용을 하는 경우에는 서브 트랜잭션이 기록에 남아요. 그럼 이제 서브 트랜잭션이 트레이스에 남고, 그리고 이제 컨트랙트와 인터랙션을 했을 때 이벤트가 발생을 하게 되면은 이 이벤트들이 기록돼서 로그에 남습니다. 그래서 로우 데이터는 이렇게 크게 네 가지가 남게 되고, 그 중에서도 이제 펑션 콜을 하거나 이벤트가 저장되는 것들은 각각 컨트랙트에서 트레이스에 남기 때문에 디코디드 데이터에 남게 돼요. 그리고 이제 이렇게 남은 데이터에서 어떤 데이터가 추가되냐고 했을 때, 첫 번째로는 가격 데이터가 오라클을 통해서 받아오게 됩니다. 그래서 가격 데이터가 오라클을 통해서 받아오게 되고, 이 오라클을 통해서 가격 데이터와 결합을 해서 어떤 걸 할 수 있냐면, 덱스에서 거래되는 전체 총량이라든지 NFT 마켓플레이스에서 거래되는 양이라든지 그런 어떻게 보면 정리된 앱스트랙트 테이블을 만들 수 있어요. 그리고 이제 ERC20나 ERC71, ERC1155 같은 경우는 그 템플릿이 정해져 있기 때문에 이벤트가 다 똑같아서 이런 것들도 한 번에 모아서 볼 수가 있습니다. 이따가 코드를 한번 더 살펴보도록 할게요. 그럼 이제 이런 데이터들에서 온체인 데이터는 어떤 데이터들이 남냐라고 했을 때, 사실 온체인 데이터에는 크게 많은 데이터가 포함되진 않습니다. 그래서 첫 번째로 타임스탬프 데이터가 포함이 되고, 그 다음에는 어떤 어카운트가 포함되고, 이제 뭐 내가 송신잔지, 수신잔지에 대한 정보가 남게 되겠죠. 그리고 이게 EOA냐 CA냐로 구분할 수도 있고 블록에 있는 데이터냐 트랜잭션의 데이터냐라는 것도 구분을 할 수 있겠죠. 그 다음에는 이더리움 그리고 이제 펀지블 토큰, non 펀지블 토큰에 대해서 어마운트와 토큰 아이디를 볼 수 있고 외부에서 불러온 프라이스 오라클로 가격을 볼 수 있습니다. 사실 이 온체인 데이터에 있는 내용은 이게 전부예요. 온체인 데이터에서 크게 볼 수 있는 내용들은 이런 거고, 그럼 이제 이 데이터들을 어떤 식으로 조합을 해야지 매트릭을 얻을 수 있냐라고 한다면 이제 이런 식으로 데이터를 구할 수가 있습니다. 사실 그래서 일반적으로 여러분들이 보는 대시보드라든지 기사에서 나오는 데이터는 사실 엄청 복잡한 공식을 통해서 나오진 않아요, 대부분. 그래서 타임스탬프와 블록이 결합했을 때 뭐 블록에는 모두 디피컬티가 저장되기 때문에 이런 디피컬티에 대한 정보를 얻거나 아니면 각각의 블록의 리워드를 포함해서 지금 사람들이 채굴자들이 얼마나 많은 이익을 얻을 수 있는지도 확인할 수 있겠죠. 뭐 트랜잭션과 결합을 한다 했을 때 시계열 데이터로 본다면 지금 전체적인 트랜잭션이 몇 개인가, 아니면 지금 TPS가 얼마인가, 아니면 가스 컨섬션이 얼마인가 볼 수 있겠고요. 만약 시간별로 어카운트를 보게 된다면 진짜 신규 진입자가 얼마인지, DAU, MAU가 얼마인지, 리텐션이 얼마인지 쉽게 구할 수 있습니다. 뭐 펀지블, 논 펀지블 토큰과 프라이스가 있다면 트레이딩 볼륨을 구할 수도 있고, 조금 더 공식을 알게 된다면 TVL이나 fee revenue 이런 것들을 구할 수 있겠죠. 그래서 사실 이 몇 가지 안 되는 데이터를 조합해서 여러분들이 기사에서 보는 그리고 많은 프로토콜에서 발표하는 데이터들을 살펴볼 수가 있습니다. 그리고 이제 보통 데이터 분석하면 사람들이 어려워하는 게 내가 데이터 분석을 해서 뭘 봐야 될까라는 것에 대해서 많이 의문을 가지게 되는데, 사실 데이터 분석은 크게 4가지 유형밖에 없어요. 첫 번째로는 이게 어떻게 구성되어 있는가, 해당 데이터가 어떻게 구성되어 있는가. 두 번째는 어떤 식으로 분포되어 있는가. 그리고 세 번째가 이 구성된 데이터와 비교하는 이런 분포된 데이터를 어떻게 비교할 건가. 네 번째가 이 데이터 간의 릴레이션을 어떻게 볼 건가. 이렇게 크게 4가지가 있습니다. 물론 이제 이런 구성에도 조금 더 디테일하게 들어간다면 세그멘테이션이 들어갈 수도 있고요. 이제 디스트리뷰션 같은 경우는 조금 더 본다면 얼마나 바이어스돼 있느냐, 얼마나 이제 치우쳐져 있느냐, 또는 어떤 아웃라이어들이 존재하느냐, 이런 식으로 구분을 할 수 있겠죠. 그럼 이제 이런 것들을 할 수 있다는데, 과연 그럼 이제 코딩은 어떻게 하냐라고 했을 때 SQL 같은 경우는 기본적으로 솔리디티나 뭐 파이썬 같은 언어만큼 어렵진 않아요. 물론 이제 어려워지려면 충분히 어려워질 수 있겠지만 이 쿼리 자체에서 사용하는 키워드가 20개 정도밖에 되지 않거든요. 그래서 간단하게 소개를 하면은 얘네도 결국 영어입니다. 그래서 SQL은 쿼리 순서와 알면 좋은 함수들로 이루어져 있는데, 이제 대표적으로 유명한 차트는 이런 게 있어요. 어떻게 하면 데이터 분석을 할 수 있는가라 했을 때 처음에는 여러 가지 데이터베이스가 있습니다. 이런 데이터베이스를 from으로 불러와요. 그럼 from을 하면 데이터를 이렇게 불러올 수 있고, 이 데이터 중에서 조건부 필터링 할 거예요. where이라는 걸로. 이따 코드를 통해서 보겠습니다. where이라는 걸로 필터링을 하게 되고, 이거를 특정 묶음에 따라서, 예를 들면은 타임스탬프에 따라서 아니면 어카운트에 따라서 그룹 바이를 하고, 그 필터링 된 것 중에서 일부를 제거한 다음에 내가 원하는 데이터를 선택하고 정렬한 다음에 몇 개만 보여줄 수 있어요. 이제 코드로 보면 조금 간단한데, 이제 이 데이터를, 이 SQL 코드를 보면은 되게 순차적으로 하면 영어와 거의 똑같습니다. 그래서 이 코드가 실행되는 순서를 넘버링을 해놨는데, 보게 되면 첫 번째 EVM의 트랜잭션 데이터에서 불러올 건데, 어떤 데이터를 불러올 거냐라고 했을 때 where, 지금 이 트랜잭션의 시간이 지금보다 1일보다 많으면, 그러니까 하루치 데이터를 보겠다는 거고요. 근데 이거를 묶을 거예요. 이 EVM 트랜잭션 데이터를 묶을 건데 뭘로 묶을 거냐면 이 블록체인이라는 주제로 묶을 겁니다. 그래서 이 블록체인이라는 주제로 묶었을 때 이 디스팅트가 서로 다른이란 뜻이거든요. 그래서 서로 다른 from, 그러니까 서로 다른 트랜잭션 서명자들을 이 10,000명이 안 되는 걸로 묶을 거예요. 10,000명 이상인 걸로 묶을 거예요. 그럼 이제 여기서 어떤 의미가 되느냐? 블록체인별로 묶을 건데 서로 다른 사용자가 몇 명인지 계산을 할 거고, 그리고 전체 얼만큼 많은 트랜잭션이 카운트 되었는지 계산을 할 거예요. 그러면 이제 얘는 블록체인별로 이제 데일리 액티브 유저를 구할 수 있고 하루에 얼만큼 많은 트랜잭션이 있었는지 구할 수 있죠. 그리고 그거를 이제 DAU로 정렬을 할 거고 상위 10개만 보겠다라는 뜻입니다. 이제 조금 더 쉬운 약간 조금 더 복잡하게 들어간다면 뭐 이런 식으로 할 수 있는데 이제 이 데이터가 GK 싱크 데이터거든요. 이게 GK 싱크 컨트랙트인데 이더리움 트랜잭션에서 GK 싱크로 가는 전체 트랜잭션을 다 볼 건데 얼만큼 가는지만 모아 보는 거예요. value. 그리고 이 GK 싱크 컨트랙트에서 빠져나가는 트랜잭션도 전체로 모아 볼 거예요. 얘는 근데 이제 빠져나가는 거니까 마이너스가 되겠죠. 그리고 얘네들을 다 묶어서 보게 된다면 이더리움은 이제 10의 18승 단위로 끊어지기 때문에 이 전체 이 GK 싱크 컨트랙트에 있는 이더리움 양의 총량을 구할 수가 있겠죠. 왜냐하면 이더리움 이 GK 싱크 컨트랙트에 간 이더리움 양과 빠진 이더리움 양을 그냥 빼면 되니까. 그래서 이런 식으로 구할 수 있습니다. 그래서 이렇게 이제 값을 구하고 나서는 시각화를 해야 되는데 이런 시각화랑 스토리텔링에는 그냥 공통적인 어떤 원칙이 있어요. 그래서 이제 공통적인 큰 세 원칙이 저는 항상 세 원칙을 바탕으로 시각화를 구성을 하는데 첫 번째로 가장 중요한 거는 이제 타겟에 대한 고려입니다. 타겟에 대한 고려 같은 경우는 결국 여러분들이 대시보드를 만들어서 공유를 하거나 아니면 내부에 대시보드를 만들어서 공유를 한다는 거는 명확한 독자가 있다는 뜻이에요. 그래서 그런 독자에 따라서 원하는 상황이 되게 다르게 되는데 예를 들면 에어드랍 헌터 같은 경우에는 본인이 랭킹이 몇 위이고 지금 되게 인터랙티브하게 검색하거나 아니면 컨트랙트별로 볼 수 있어야 하기 때문에 인터랙티브하게 볼 수 있어야 되고 리서처 같은 경우에는 가장 중요한 지표만 보면 되기 때문에 굳이 인터랙티브함이 필요 없을 때가 있습니다. 그래서 이렇게 타겟에 따라서 데이터에 대한 어떤 구성을 좀 바꿀 수도 있고요. 이제 두 번째는 아마 시각화 하시는 분들에게는 좀 유명한 어떤 이론 같은 건데 슈나이더만스 만트라라는 게 있습니다. 이게 이제 슈나이더만이라는 데이터 시각화 리서처가 있는데 이 리서처가 주장한 이 대시보드를 만드는 기본 원칙이에요. 항상 오버뷰, 전체적인 뷰를 먼저 보여주고 줌앤 필터를 통해서 그 내부 디테일을 볼 수 있게 만들어야 된다. 그래서 데이터 시각화를 만들 때 보통 처음 만들면 하는 실수는 가장 디테일한 시각화를 만들어서 공유를 한 다음에 이게 중요하다고 주장을 하는 경우가 많아요. 근데 이렇게 되면은 독자 입장에서는 이 데이터가 뭔지 이해조차 못한 채로 데이터를 보게 되는 경우가 많거든요. 그래서 항상 예를 들면 이더리움 데이터라고 했을 때 이더리움 트랜잭션이 얼마고 이더리움 뭐 지금 DAU가 얼마고 이런 큰 데이터를 먼저 보여준 다음에 이제 디테일한 정보를 보여주는 게 되게 중요합니다. 세 번째로는 이제 completeness인데 이건 이제 논문에서 많이 얘기하게 되는 건데 결국에 이제 시각화를 보는 사람들이 대부분 이제 고려를 하는 거는 아 여기 있는 사람들은 다 블록체인 에코시스템에 되게 관심이 많은 사람들이니까 설명이 없어도 내 데이터를 이해할 거야라고 생각을 하지만 결국 이제 여기서 빌딩 하시는 분들은 알겠지만 모든 컨트랙트와 모든 프로젝트를 알 수는 없거든요. 그렇기 때문에 그런 거에 대한 부가 설명을 추가를 해서 이 차트만 보더라도 이 대시보드만 보더라도 이 내용이 무엇인지 이해할 수 있어야 됩니다. 그래서 이 차트와 대시보드 자체만으로도 처음 보는 독자가 이해할 수 있게 대시보드를 만드는 게 가장 중요해요. 이게 제가 보통 대시보드를 만드는 가장 상위 3원칙이고 조금 더 디테일하게 구현 레벨에서 간다면 뭐 이런 팁을 사용할 수 있는데 좀 인지과학적인 요소를 사용하면 되게 좋습니다. 결국 이제 대부분의 사람들은 어떤 것들을 스캔할 때 좌측 상단에서 우측 하단으로 시야가 가게 되거든요. 그렇기 때문에 좌측 상단이 본인이 중요하게 생각하는 지표를 놔두고 우측 하단으로 갈수록 덜 중요한 지표를 놔뒀을 때 훨씬 더 효과가 좋은 시각화를 할 수가 있고요. 두 번째로는 꼭 이런 약간 뭐랄까 뷰에 대한 어떤 패스가 아니더라도 단일 값과 큰 차트가 중앙에 있으면 사람들은 눈이 먼저 가게 됩니다. 그리고 세 번째로는 비주얼 프리 어텐티브 비주얼 어트리뷰트라는 걸 사용하는 건데 이거는 뒤에 장표에서 추가적으로 설명을 드릴게요. 이제 두 번째로 중요한 거는 색깔인데 색상 같은 경우는 첫 번째로는 프로젝트의 색상을 사용하는 게 제일 좋아요. 예를 들면 유니스왑이라면은 그 유니스왑의 특유의 핑크색이라든지 아니면 메이커다오라면 그 초록색이라든지 그런 것들을 사용하는 게 제일 좋고 알록달록하게 시각화를 구성하면은 결국 보이는 게 없기 때문에 7개 이상의 색상을 사용하면 절대 안 됩니다. 그리고 가능하면 항상 단일 색상과 그거를 보조할 수 있는 서브 컬러로 구성을 하는 게 시각에서 제일 좋고 그 다음에 이제 뭐 게슈탈트 프린시펄이라고 해서 뭐 여러 가지 이제 시각적인 인지에 관한 내용인데 크게 두 가지가 있어요. 제일 중요한 거 묶어놓으면 사람들이 그게 유사하다고 인지를 하게 되고요. 그리고 유사한 어떤 패턴끼리는 비슷한 집단이라고 느끼게 됩니다. 그래서 이건 어떻게 사용하냐면 본인이 생각했을 때 비슷한 지표는 한 군데 묶어두고 항상 어떤 파티션을 쳐야 돼요. 파티션. 그리고 본인이 비슷하다고 생각하는 데이터는 항상 똑같은 색상과 똑같은 패턴으로 구성을 해야 되는데 이제 이 부분도 한번 살펴보도록 하겠습니다. 그래서 인지과학을 사용하라는 거는 보통 이런 겁니다. 이거 차트를 딱 봤을 때 저희는 you will read this first와 그리고 and then you will read this and then this one and you will read this last 약간 이런 식으로 자연스럽게 눈이 들어가는 어떤 인지과학적인 부분이 있어요. 그래서 이런 것들을 사용했을 때 본인이 어떤 식으로 대비를 하고 글씨에 컨트라스트를 넣느냐에 따라서 집중할 수 있는 게 다르다는 것을 보여주는 거고요. 그리고 또 중요한 거는 우리는 뭔가 모양에 대해서 구분을 잘하고 구분을 잘하는 존재라고 생각을 하지만 왼쪽에서 숫자 9를 세는 것과 오른쪽에서 숫자 9를 세는 거는 전혀 다르다는 걸 여러분들이 알 수 있습니다. 그래서 시각화를 할 때도 본인이 강조하고 싶은 포인트가 있다면 다른 것들에 대해서 뭔가 옅게 해놓고 본인이 생각하는 거에 강조하는 부분이 되게 중요하다는 걸 볼 수 있고 마찬가지로 이제 요런 이제 랭스나 위트 이런 어떤 시각적 요소를 통해서 강조를 하는 게 가장 중요하다는 걸 알 수가 있습니다. 그래서 조금 제가 이제 빨리 이제 진행을 한 게 시간이 있으면 어떻게 듄에서 쿼리를 빨리 칠 수 있는지에 대해서 보여드리고 싶어서 준비를 했는데 이제 이 화면이거든요. 그럼 이제 예시로 그냥 코드를 한번 몇 개 쳐드리면 일단 뭐 이더리움에서 데이터 분석을 할 때 어떻게 빨리 대시보드를 만들 수 있을까라고 한다면 첫 번째로 그냥 이더리움의 메이저한 매트릭을 몇 개 뽑아볼 수 있겠죠. 예를 들면 DAU라든지 트랜잭션 뭐 이런 것들을 먼저 뽑아본다고 칩시다. 그러면 일단 프롬을 통해서 이더리움 이런 식으로 일단 이더리움 트랜잭션 데이터를 불러왔어요. 이 이더리움 트랜잭션에서 그러면 어떤 걸 뽑아볼 거냐라고 했을 때 하루치 데이터를 뽑아볼 수 있어요. 보이나요? 네. 이더리움 데이터에서 그러면 나는 하루치 데이터가 아니라 그럼 2023년도 1월 1일까지의 데이터를 한번 뽑아보도록 하겠습니다. 그래서 일단 데이터를 한번 보도록 할게요. 이렇게 실행을 하면 2023년도 1월 1일부터 이더리움 트랜잭션 데이터를 쭉 볼 수 있는데 지금 인터넷이 안 돼서 일단은 핫스팟으로 연결했고요. 한번 다시 쳐보도록 할게요. 이런 식으로 쿼리를 처리하게 되면은 이더리움 트랜잭션 데이터들이 아마 쭉 나오게 될 겁니다. 근데 이제 여기서 DAU와 트랜잭션 이제 뭐 TX를 미리 쳐본다면 일단 뭐 이런 식으로 이제 칠 수가 있는데 이게 보면 데이터 트랭크라에서 이 블록 타임을 시간 단위로 끊는 거예요. 근데 이제 날짜 단위로 이제 데이 단위로 끄는 거고요. 여기서 각 개수별로 센다면 데일리 트랜잭션이 되겠죠. 그리고 하루 단위로 묶어야 하기 때문에 그룹 바이 원으로 했습니다. 이게 이제 이더리움 데이터였었고 조금 더 빨리 처리를 하면 최근에 듄이 이제 이런 AI 기능을 업데이트해서 가끔 오타가 있으면 오타를 잡아주긴 하는데 이런 식으로 구했을 때 나올 수 있는데 결국 이제 라이브 코딩을 이제 하면 안 된다는 이제 또 교훈을 얻게 되는데 사실 그래서 SQL 같은 경우는 이런 식으로 그냥 영어와 거의 같다고 저는 생각을 해요. 그래서 이더리움 트랜잭션 데이터에서 2023년부터 데이터를 볼 건데 하루 단위로 끊어서 볼 거고 그걸 묶어서 봤을 때 이제 데일리 트랜잭션을 구할 수 있다. 뭐 이런 식으로 볼 수 있게 되고요. 네. 네. 듄의 이제 평균 커리 속도 같은 경우는 최근에 이제 SQL 데이터베이스를 토큰화 시켰어요. 그래서 이제 요금제에 따라서 비싼 DB 같은 경우는 빨리 진행이 되고 하게 되는데 보통 이제 이런 것들은 몇 초 안에 나오는데 지금 약간 서버 문제인 것 같습니다. 이거는 뭐 제가 또 나중에 따로 자료를 올리도록 하고요. 그래서 결론적으로 말하고 싶었던 거는 온체인 데이터가 사실상 그렇게 많은 내용들을 함축하고 있지는 않고 쉽게 접근할 수 있는 부분이 많다는 거였어요. 그래서 사실 SQL도 한 20-30가지의 키워드만 알면 되고 이더리움 데이터도 한 10가지 정도 내외로 알면 되고 그래서 사실 듄의 데이터 스탯도 그렇게 많지 않다. 그래서 쉽게 데이터 분석을 할 수 있다는 것을 말씀드리고 싶었고요. 이제 해시드 같은 경우는 이제 듄에서 데이터 대시보드를 많이 만들어서 공유를 하고 있고 이제 이걸 통해서 에코시스템에 많이 기여하는 게 목표고요. 뭔가 이제 관심 있는 분들은 뭐 저한테 개인적으로 질문해 주시면 좋을 것 같습니다. 예, 더운 날에도 발표 들어주셔서 감사합니다.
Next speech is from the Francesco. Is Francesco here? Yeah, Francesco will make a presentation about the linear in the layer 2 landscape. Actually, recently there's so many layer 2, so a lot of the builders, they are confused, like which kind of the layer 2 they need to build on. So I think this is pretty perfect speech and presentation for a lot of the builders. So looking forward to your speech.
What's up, what's up, what's up? What's up, everybody? Oh, so many people, so many chairs. No, it's hot, the weather. Cool. So let me start with that, right? So this is not like a linear shield, right? I tell you why. Like every workshop that we're doing is, oh, this is the new feature, this is what's happening. But a lot of people don't get the context, right? So what are ZK EVM and how we kind of like started from scratch. and what's the difference between like how we come up with like rollups, how we're speaking with like ZK that are focused on privacy, and looks like I will do the presentation without the slide. But so I'm Francesco. For people that doesn't know me, I'm mostly dedicated on snaps, so everything MetaMask. And yeah, today we're doing something different. We will speak about Linea. How many of you guys heard about Linea at least? Cool. Some people, some faces that we don't know, unknown. But oh, it's colored. So let me start to break down this statement, right? So Linea will be a type 2 ZK EVM rollup, right? And the approach in this presentation is a bit like giving a context. So also, like if you're a beginner, like this is something that I wish to have, I don't know, maybe 6, 8 months ago when I was diving into like ZKVM and like the landscape and why, what are the levels, and basic concept. I think this is a good also like introduction, even if you want to deploy to other like rollups in the future, right? So let's start with the blockchain trilemma, right? And don't mind all this kind of like yeah gifs around, but for everybody that doesn't know, right? So we have the three right: scalability, security, and decentralization. And obviously, like we focus on the first layer with Ethereum on security and decentralization, and scalability need to be solved like on other ways, right? How many of you guys saw this already or read the paper, Vitalik paper on what was the name? The unrealistic rollup like clarification or something. That was quite cool. So scalability, so how we solve this, right? So boom, layer 2 solution, right? And for all the people here that are working on rollups, feel free also to jump in. I think we're so many today that we can, we can speak, have more an interactive session. So layer 1, obviously, as you can see here on the graph on your right, so settlement and consensus data availability. How many of you guys know what data availability is? Like, feel free to jump in and yeah, say what you think is. But the long story short here is that Ethereum is carrying around settlement and consensus, and then we have an execution layer done purely on a second layer. In this case, Linea, but basically all the rollups are satisfying the execution side. Cool. Layer 2 is basically what I just described right now. So we rely on data availability. So obviously, like you have different, like from optimistic, no optimistic, but as way to implement, rollups are one of the solution. I just want to state, like a lot of people, for example, like example on the Polygon POS side. So this is not a rollup; it's a sidechain. Like if we're speaking about, for example, Polygon and ZKVM is a rollup, right? And there is a lot of like small like misconception tricks that I want to also like speak about, so that people get a little bit clarity around what general rollups are, right? Okay, cool. We said rollups, that's where we are right now as a landscape. So how is this rollup kind of structured, right? And we put like 3 categories here, right? So you have your on-chain contract that is actually storing all the block values, is monitoring, and also tracks user deposit from both layer 1 to layer 2 and layer 2 and back to layer 1. You have the off-chain VM. And then you have basically the third category that we put on operators, validator, aggregator, sequencer. But basically, this is where all the fun facts are in terms of aggregation and publishing back to the Ethereum layer. Is this clear? A little bit. You find this useful? Okay, cool. So I know a little bit like how fast should I go? I don't know how long. I think I have 30 minutes. Cool. So in terms of fastest process, this is also a cool concept, but basically you have deposit and withdraw. So for everybody that already did some like deposit, it's quite straightforward. But from layer 1, layer 2, you're locking up your ETH on a rollup contract, and the equivalent is done when you're withdrawing that this Ethereum is being burned and is released to the main account. So these obviously take time, right? And you have this 7 months period depending on what rollups type are. And I wanted to also break down this, right? So you have obviously optimistic rollups, so like Optimism, Arbitrum base, they're all optimistic. And the big difference that you also want to see is that we are assuming the validity on the transaction side, and you have this challenge period that is basically 7 days. And look, it's not a problem. It's just taking a longer time, and there you also like custodial kind of like bridges, insurance that are basically like giving back the withdraw, because obviously when you are on a optimistic roll up and you're withdrawing, you get your money like almost instantly. I mean, not on 7 days period. And that's optimistic. And then you have all the other side on the roll-ups, that you have all the ZK roll-ups. So this is requiring validity proof, and they are verified through math, right? They don't have a direct challenge period, and you know some example, right? Linea is one of those, right? ZK Sync, Polygon. I think Alex or someone from ZK Sync will do a cool presentation later. I'm excited. And you know, Scroll, Starknet. I don't know how many of you used Cairo 2.0, but it's now like fully also like EVM compatible. That's also quite cool. And yeah, so now we define a little bit like where we are. We define what an optimistic and a ZK rollup are. And let's a little bit like deep dive on ZK EVM, right? So what is a ZK EVM? It's basically like directly smart contract transaction on a EVM machine, meaning also you don't need to go away. There are different types, and we will deep dive in right now. But depending on the type you are, like the goal is to have like a full EVM compatibility, meaning so also like if you're testing your smart contract and deploying on I don't know, on Foundry, Truffle, Hardhat, is fully compatible, so you don't need to change your stack or learn new infrastructure tooling, right? And obviously, the ZK proofs are also quite interesting concept, because you can build like specific things like arithmetization. You can build proof on top of proofs, and they're all secure with math assumptions. Cool. Speaking about types, and this is also like this is taken also from this paper from Vitalik, right? What was the name? An incomplete guide to rollups. And I think I read it 7 times, and I still don't understand everything. And yeah, it's but I try to like explain it here. So you have these 4 types, and obviously like your goal is to go to a fully Ethereum equivalent. And today, where we are right now on Lina is on a type 4.3, and the goal, as almost every like ZK EVM rollup, is going to a fully EVM compatibility, right? Yeah, so feel free to jump in if you have any questions. I think, as I mentioned, like there is also like a lot of like people from the rollup space here. They are probably even better than me on explaining those concepts. And yeah, it's quite exciting. This was also part of the paper, and basically like you always have a trade-off between compatibility and performance, and you see where we are with specific like types. Cool. So. This is like going a little bit like on the details, but is partially explaining how linear proofs are working. And the big difference between other ZK EVM is basically the arcade and the vortex part. And yeah, and those are kind of the main types on the prover. One quick like things that a lot of like ZK EVM are trying to solve, right? Like where we see also like a cool future is that when you have multi-provers, basically a prover deciding like where to deploy your transactions. And this is also something cool that I think like I hope really in the future like people will work on, where you have like a multi-prover world that's instead actually deploying on one ZK EVM. It will basically redirect it to different one depending on the transaction. And yeah, so that's kind of like the intro around like, you know, what we kind of break down the statement. We spoke about, you know, what are the different type of rollups and where kind of we play the role. So Lina will be a type 2 ZK rollups, right? So is the concept now a little bit like brain down? You find it like useful, at least speaking about those concepts? Cool. Now, speaking about like Lina itself, so we had our private testnet in January. So it's like a new like project, not truly new, because you know R&D in consensus has been like around 4 years into testing. But since private testnet, around like 55 million transactions. That was the latest that I did last week, a presentation on that. 5.6 million and 2.5 contract deployed. The cool thing is that during ECC, I don't know if you guys were in Paris, we officially launched mainnet, and since that time, we got around 4.5 million transactions and 800,000 wallet addresses. I think there is a typo here, it's 43 million TVL, but the quite cool thing is that we got a lot of like partners trying to deploy on Linea, because obviously different reasons. But if you look at like the TVL grow is one of the fastest TVL grow since mainnet. Cool. Why to build on Linea? Yeah, finality is something that probably everybody's talking about, and they have the same functionality. Obviously, liquidity. One thing I'm excited about that is also here. I mean, EVM equivalence. That's also like something all ZK EVM can speak about. But the long story short, for developers, is need to be quite straightforward. Need to be Solidity also compatible, and your tools need to be similar. So if you're used to do like Hardhead, Foundry, or Truffle, you don't want to like go and build and test on other infrastructures. User one, I don't know if you check out, but being Linea, being one of also like a product in a consensus like family, is directly also integrated with MetaMask network. So if you're going directly on MetaMask, now you see both test nets and on mainnet now. And yeah, on a time of security, ZK Proof and roadmap is fully centralization. The quite cool thing is also like ecosystem partner-wise. If you guys building, or you need like bridge, or you need like next like more funding, or you just need like cool exposure to like developer community calls, or like being part of those like tours. A good way is also like to be part of this ecosystem partner portal. And I guess, you know, everybody is kind of like being part of those portals to any other project in the rollup space today. Cool. So yeah, so those are kind of the three things also like that I want to mention. So obviously everybody know MetaMask, but in terms of like UX is also quite straightforward. You see Linea in your both and test and mainnet. We are also supporting Besu. For anybody that doesn't know, Besu is one of the largest open source clients. So hopefully more client diversity is coming. And yeah, this is also an internal team. I think mostly of the Ethereum clients is supported in the R&D team in Consensus. So it's also a great way to have those top researcher. And then like when you deploy a smart contract in Linea, you can also like go through Infura. So and obviously like Infura is supporting also Linea for deployments. Cool. So how to build on Linea? I think I put some screenshot here, but yeah, we were debugging. I didn't prep that much this presentation because we were the past 4 hours debugging for snaps and Linea. But the long story short, if you need some girly ETH, you can go on the faucet. Also, like I think Paradigm is supported. Also, you can bridge to Linea. Yeah, that's the faucet link. I can send you the links in Telegram, and also like you can just ask me, and I will send you some testnet tokens. I'm not a whale, sadly, but I can get you some for testing purposes. In tier, like for swapping your RPC is also quite straightforward. You can use one of those. I think I saw teams using both Ardet and Truffle before, and yeah, you just need to swap your RPC and use your Infura API key. I think, yeah, if you have any questions. So basically deployments. So we are encouraging you guys to deploying to any network, to any rollups that are here. And so that also like you can see different like experiences and target more bounties. and yeah, so it's I think that's, I put some screenshots also like for specific like deployments, but in Ardet you need to also like run those scripts, both for girly and Linea, and make sure always like when you are swapping, you just go on the Linea URL and the accounts, and you put your private key here. and type it well, because a lot of times we find just some small error that could not deploy because people miss like some syntax error. So for Ardent it's like this. For Foundry is also quite straightforward. You can directly create your RPC URL, and you just swap the Infura API key with your API key directly in your account. And yeah, so that's a little bit it, right? And you can reach me out. You can check out what Lina Build is updating. We're constantly updating our documentation for onboarding more devs. And let me know if you need some testnet token for deployments. And yeah, if you have any question, feel free to reach out. We're planning to be here all night. I think my colleague is also here around. That we are debugging some Linea deployments. Cool. Any question, guys? I think it was a little bit fast. I think, yeah. I mean, and if you have any question on both SDK or snaps, feel free to also reach out. And are you guys? How many hackers are here? Because I see a lot of familiar faces that are mentoring too. How many of you guys plan to do the Linea, to deploy on Linea, or just target using maybe SDK or building a snap? Some people, yeah. Cool, sounds good. Yeah, if you have any question, reach out, and yeah, I hope you have a great. I think submission is tomorrow at what? What time? 4, 5, 1, 1. Okay, sounds good. Awesome. Thanks, everybody.
Thank you, Francisco. Thank you for sharing your insight. Actually, the ZK Sync team, they supposed to share their speech and their presentation, but they couldn't come today. So we are gonna take a break for the 30 minutes, and we are gonna get another speech at 5 p.m. Thank you. Hey guys, we are going to start our presentation at 5, so please come and please join.
감사합니다. 언니 저녁은 6시부터라서 제가 하고 이거 끝나고 바로 갈게요. 왜요? 저녁식이라뇨 지금? 아니 배고프신 분들이 있어가지고. 아 진짜요? 괜찮아요? 근데 일단은 미안해. 괜찮아요.
Okay, we are about to start in 1 minute, so please sit and please come to join. Okay, let's start it. This is Sam. Personally, I'm craving for the DeFi, and a lot of the layer they have a big problem about the liquidity, so they really want to get some new solution for the liquidity. So Sam will gonna make a new liquidity paradigm for the DeFi. So I'm so looking forward to your speech, and yeah, please join.
Hello, hello. All right, let's get started. So my name is Sam McPherson. I'm co-founder, CEO of Phoenix Labs. We are a smart contract dev shop that is actively contributing to Spark protocol. So this talk is called the Maker Allocation System, a new liquidity paradigm for DeFi. So for better or worse, DeFi has chosen the US dollar as the accounting unit of choice. This is basically the lifeblood of DeFi. Protocols need this to come alive. So a lot of protocols have this problem where they need to attract users, but they require stable coins to provide capacity. Especially now, there's super high opportunity cost for this in this high interest rate environment. It's common to use yield farming to bootstrap protocol liquidity and get things rolling, but this comes with a cost. And that is the cost of capital. So idle liquidity costs about 5% plus per year. This is due to the high interest rate environment we're in. So LPs, they're discerning. They'll stick their money in where it's the highest yielding. So protocols to compete with the yields in TradFi, they need to offer particularly good yields. So protocols need to pay this one way or the other, and it can be prohibitively. What just happened? It's back. It can be prohibitively expensive for new protocols, especially in this high interest rate environment. What you have is a chicken and egg problem, where you need. Keeps cutting out. Okay. So enter Maker, the infinite LP. It's a little bit tongue-in-cheek, but the size of DAI, now having over 5 billion in outstanding DAI, provides this gargantuan capacity for protocols to connect into. The interesting thing about Maker that applies to the fiat stablecoins like USDC, USDT, is that Maker has the ability to mint DAI. So it does not have opportunity cost for maintaining non-circulating DAI in protocols. This is also known as pre-minted DAI or algorithmic DAI. These are other names for it. So because of the huge capacity in Maker, Maker can be the LP into your protocol. And then protocols can focus on like building user demand for their product and less about worrying about where they're going to get the stablecoin LPing from. All they have to do is provide demand at a price point above the US dollar risk-free rate. Introducing the Maker allocation system. This is a new system that's going live early next year. It's a brand new paradigm. It opens up access to Maker's liquidity to all protocols, and it's an open playing field for everybody. This is elastic, scalable supply to match user demand. It has support for DAI, USDC, and USDT. Fiat stablecoins, of course, have opportunity cost for maintaining them, but DAI, again, has this interesting relationship with Maker where you can LP into the protocol without incurring opportunity costs. So protocols, again, can focus on user acquisition and less about yield farming to bootstrap this, this LPing. So in this new paradigm, there are 4 allocator DAOs. These are, you can think of them like there's sub-DAOs of MakerDAO to provide redundancy for healthy competition for stablecoin allocation. Allocator DAOs have access to Maker credit facility with unlimited capacity at the base rate, and I will get more into what all these words mean in a moment. So here's kind of a concise summary of what the Maker allocation system looks like in a nutshell. So the 4 allocator DAOs, this is an image of one of the allocator DAOs, and you can think of there's 4 copies of this entire setup for each allocator DAO. So what each allocator DAO has access to in the top left is a Maker credit facility. This allows them to borrow any amount of DAI at the base rate. And again, I'll get into the base rate in a bit, but for now, it's just assume it's some rate that Maker charges. So as a allocator DAO, I can then borrow DAI from Maker directly. I then have those assets on my balance sheet. This is the top middle. I can then invest that DAI into whatever. So common examples of this on the bottom left are, say, DeFi investments. So this would be, for example, Spark, a lending protocol. This is probably what most people are more familiar with Maker. This is like user vaults where people can then further borrow that DAI by over-collateralizing their positions with ETH and staked ETH and all that kind of stuff. But really, there's no limit to what this could be. It could be fixed rate protocols, multi-chain transport, like really anything. The other piece that allocator DAOs have to deal with is market making the DAI peg. So this involves sticking the newly minted DAI into DEXs like Uniswap, Balancer, Curve, etc. And as a result of that, just by the nature of the DAI peg, you will start getting an inventory of USDC and USDT. These are Circle and Tether's fiat-backed stablecoins as inventory as assets that the allocator DAO can then further deploy to the bottom right, which is real-world asset investments. This is things like US Treasury bills, corporate debt, private debt, but again, like it could be whatever the allocator DAO wants to invest in. And the result of all of this is they earn yield on this. So this then turns into yield, which is in the top right, turns into equity for the allocator DAO. So let's get into what the base rate is now. So this is the cost of capital for allocator DAOs to borrow from Maker Core. It is a market-driven rate. Previously, Maker has had, well, even now, currently Maker has a peg stability module enforced hard peg to a 1-to-1 to the US dollar. These are going to be deprecated and replaced with this market-driven base rate. So this is, for those maybe who have been around for a while, this is kind of going back to the target rate feedback mechanism that Maker was originally planning to use. It's not quite the same, but it's similar in that it uses the market price of DAI to determine whether the base rate should go up or down. So if DAI price is less than $1, this target rate feedback mechanism will increase the base rate. And what this does is it encourages allocator DAOs to liquidate active investments, bring the USDC, USDT back on chain, and then bring the peg back up by bringing these back on chain and putting them back into the DEXs. And then the vice versa, there's when the DAI price is above $1, the base rate will start going down. This encourages more investment because the allocator DAOs get a better yield. So allocator DAOs, they need to maintain some inventory of highly liquid, low yield tokens on chain. This is like USDC, USDT. These are both the best available to maintain a $1 peg, but the trade-off is that they don't yield anything, or they yield like very low amounts compared to the TradFi yields, like the US Treasuries, for example. So basically, allocator DAOs have to balance between yield and peg, or really duration, and this is their task. There's also another technical detail that idle DAI is charged a small fee for tail risk, but not so important. So here's a more concrete example of what this will likely look like in practice. At the top, you have the US federal funds rate. This is now over 5%. It's whatever the government is paying for T-bills and stuff like that, short duration T-bills. Because, again, we are using a US dollar stablecoin, this is the risk-free rate. So naturally, allocator DAOs will be incentivized to put as much capital into this to maximize their return, and this will drive certain things. So maybe let's go over this chart a little bit. So we have the base rate in the middle. This is the teal line, and then slightly below that at a fixed discount is the DAI savings rate. These two lines will just move in tandem. And basically, the allocator DAOs are able to, anything that they earn on top of this base rate, they will be able to keep 100% of that yield into their own treasury. So they're incentivized. So if at the very left here, you can see the base rate is much lower than the US federal funds rate. So they're incentivized to mint as much DAI as possible, really, and competitively allocate it into treasuries as rapidly as possible. Now, as they do that, the DAI will start to depeg down as you keep increasing the supply. And this will naturally make the base rate increase, as you can see, moving towards the right. Now, it's possible even the base rate goes higher than the federal funds rate, in which case each of the allocator DAOs is now taking a loss. So they are now incentivized to liquidate the positions, bring the USDC back on chain, bring the peg back up to $1 such that the base rate does not continue to tick up. And this dynamic basically ensures that the base rate will settle out at probably about slightly less than the US federal funds rate. But the allocator DAOs are also incentivized to make sure the peg is tight, so they aren't running a loss here. Yeah. So allocator DAOs have rules. Allocators can mint they have the ability to mint unlimited DAI, but they're rate limited. So they can only mint, say, X DAI every Y hours, and they can only allocate to pre-approved investments. Like, obviously, you can't just mint DAI and then give it to your buddy in a wallet or something like that. There has to be preset investment opportunities, such as, say, Spark or T-bills. There's many tokens that do this now. And the allocator DAOs are free to choose where they slot it into to earn the best yield. Allocator DAOs also can perform due diligence on investment opportunities they provide. So allocators are not only doing the allocation side, they're also vetting the investment opportunities. So yeah, I'll get more into the due diligence side in a bit. Riskier investments, so T-bills are pretty safe, but naturally allocator DAOs may want to branch out to riskier investments. So on the TradFi side, this might be something slightly more risky, like corporate debt, AAA corporate debt, or on the DeFi side, something more like going multi-chain, going to some experimental new chain that you find very interesting and exciting. So the larger allocator DAO surplus buffer, this is the due to the revenue that the allocator DAO has been generating from the yield opportunities. As that gets bigger, it gives them more freedom to experiment. As they have more skin in the game, they can they are incentivized to make sure that even if they are taking on risk, it's a measured risk and it's not out of control. Additionally, so conduits, this is the investment opportunities. They need a mechanism for allowing allocator DAOs to signal when they want to reclaim capital. So this will be like if the peg is starting to break down and all the on-chain stable coins have are gone, then the allocator DAOs need to be able to signal to, say, some treasury bill investment, you need to liquidate the position, get me some USDC back, and then bring the peg back in line. So this is a little bit more of the technical side. So this is the rough structure of the conduit. Really, there's three main actions that conduits, it's fairly general, but here's the main three actions. So deposit, I think you can guess this, is you're able to deposit assets. This is usually stable coins, either DAI, USDT, or USDC, into this conduit. And you can think of it like a black box that earns yield. And it could be DeFi, it could be TradFi, it could be whatever. And then on the other side, there's withdraw. This is the ability for the allocator DAO to withdraw immediately accessible liquidity. And the immediately accessible piece is important here for this third piece, where this is signaling request funds, where the allocator DAO can signal to the conduit, and whatever that looks like, to bring liquidity back on chain, sell the investments, and then bring USDC back on chain to then withdraw and market make the peg. So for something like Spark, which is a lending market, what this looks like is raising interest rates to encourage borrowers to repay and third-party depositors to deposit DAI. For real-world assets, this means instructions to a trust or something like that to sell T-bills or whatever the mechanism is. So looking at the big picture, this is what the structure looks like. Maker is going to drastically simplify such that instead of having all these user vaults and stuff like that, there's just the 4 allocators, and these are the vaults that Maker cares about. They all get charged the same base rate, and then it is delegated to the allocator DAOs to then further invest that in the best opportunities possible competitively, and that's another piece that's important, is that it's competitive. So if you see at the top, Maker will give credit to, say, allocator DAO 1, and in return, that allocator DAO 1 immediately starts paying the base rate, and then they further give credit out to, keeps cut out again. Then they further give credit out to, say, Sparkland for user vaults to borrow against their decentralized collateral such as ETH. Then Sparkland would, say, pay back the base rate plus some spread that the allocator DAO can earn into their own treasury. And you're free to invest part of that into Sparkland, into US T-bills or corporate bonds, or your protocol here. It's really open to everybody. So this is very similar to a central commercial bank relation, where the allocator DAOs are the innovation, they're the more user-facing side of things, and the Maker Core is just the more simplified, high-level piece, and it's a nice relation. There's also another interesting thing is that as the system increases in complexity, it needs to scale about how to determine if things are operating correctly. So there is also a bounty program if funds are being misused. There is a reporting system where anybody can identify this and report it, and you get a bounty. So why do we care? Why is this better? You know. So I think a good comparison is like Silicon Valley Bank, which was a recent colossal failure of a bank. And really, these things are like, the problem is that these things are so opaque, like you have no idea what's going on until there's a liquidity event. And then it exposes all the things that were going wrong, but there's no way to really proactively determine what's going wrong here. And this is where I think blockchain and this new allocation system come in. So in the blockchain world, things are transparent. Everything is on chain. Obviously, we're not there yet, but this is the goal we're working towards. We want everything to be tokenized, everything to be very, like the loan supply chain to be all on chain, fully auditable, like in real time. And this is the dream, and I think we'll get there. So yeah, this is why it's better than the status quo. So let's go through a few case studies to maybe make this more concrete. So first case study, this is the lending market, Spark. So we've launched just 4 months ago, and we've already been able to amass 450 million in TVL due to this privileged access to Maker through this allocation system. The DAI market, the interesting thing here is the DAI market is set to an allocator DAO controlled fixed spread above the base rate. So the users will pay the base rate plus some spread, and it tracks to that instead of the normal utilization-based curves that you're used to in lending markets. Allocator DAOs can then add and remove liquidity as needed to match user demand. So because allocator DAOs can just mint DAI and stick it in, they can do this and basically just track the user demand, keep some, like say, a 30 million buffer of idle liquidity, and as users, you know, you put 30 million in, somebody borrows 5, and then you just put 5 million in more, and you can just do this pretty much indefinitely compared to the size of DAI demand. Yeah, and again, the interest rates will increase if the allocator DAOs need to reclaim capital and everything is borrowed. Another use case, market making. So good example of this is, say, Arrakis, who does advanced strategies on top of Uniswap v3. So because the allocator DAOs need to maintain the peg, a certain amount of their inventory needs to remain in DAI and USDC and USDT, and that's earning nothing by default. So presumably you want to still get as much return as possible. So making advanced strategies on Uniswap v3, this is something that the allocator DAOs will want because it gives them a better yield beyond a naive solution. Another use case, cross-chain transport. So I'm a firm believer that stablecoins will be the most volume between jumping between chains. So in this example, we have, say, we want to go from Optimism to Arbitrum. The standard strategy is to burn some DAI on Optimism and then have some system that will indicate that the DAI should be minted on Arbitrum. This is something that would be perfect for the allocation system, where Maker can just LP into all these chains at once, and then maintaining that inventory of idle DAI actually doesn't cost Maker anything because it's not in circulation, and every time somebody wants to jump chains, they're burning the same amount of DAI as they're minting. So there is no cost to maintaining that. So this can plug into existing protocols like Hop, Connext, and yeah, we're really excited with this kind of stuff. Please talk to us. Another case study, fixed rates. So allocator DAOs, they can be the primary LP into fixed rate instruments like PTs or whatever else. Again, there's some interesting dynamics with reduced costs here as the DAI does not exactly enter circulation. So that still is kind of an active area of research that we're looking at. So there's tons of examples of protocols like this, you know, Delve, formerly Element, Sense, IPOR, yeah. And case study 5, your protocol. So again, you don't need to worry about how to attract stablecoin liquidity. Like, we want protocols to just concentrate on finding user demand for your product. Don't worry about yield farming. Don't worry about any of this stuff. Just have Maker as your LP, and you don't have to worry about it. So please contact the Spark Allocator DAO or one of the others to perform due diligence. We can get your protocols onboarded. So for DeFi native stuff, we're looking at innovative products, you know, a lot of audits, Lindy, all this kind of stuff to get connected. And for real world assets, this would be things like legal due diligence, tokenization, on-chain liquidity, fees, and counterparty risk, and all that kind of stuff. Thank you. Oh yeah, and we're looking for a front-end dev. We're hiring.
Thank you. Thank you for your insightful presentation. Actually, the ZK Sync team arrived, and ZK Sync can provide the presentation now. Is there Marco here? Okay, nice, nice. Yeah, Marco, thank you. Thank you for supporting and sharing the insights. And yeah, before we started, Marco, can you give me your introduction a little bit, and please start.
Yeah, of course. So hello everyone. I'm Marco. I'm the person responsible for the business team in Meta Labs. Unfortunately, today you don't get to see Alex because he's sick and he got stuck in Europe. But for those of you who go to token 2049, you'll probably see there if he get better and is able to fly. So within Meta Labs, what I do is I deal with everything around the business team, so business development, investments, et cetera, I was one of the very early participants in the team, so very happy to answer any question about what zkSync is all about and Meta Labs is doing. So what I'm going to talk about today is the ZK stack and what we think are the superpower of the system, or at least what we tried to build into the system to give it to you as developers that are going to use it. First of all, what is ZK stack? ZK stack is a modular framework to deploy sovereign ZK rollup. So it's just a set of tools that will allow anybody with a reasonable amount of technical knowledge to be able to deploy their own chains. What are some of the characteristics that are already available today? First of all, and I think most importantly, it's free and open source, truly open source. It's available, it's under MIT Apache license, you can take it, you can fork it, you can copy it, can do whatever you want, and it's free. We don't want anything in exchange, we just want you to use it and increase the network effect around the technology. The second is EVM compatible. You don't need to figure out new languages, new paradigms, you don't need to bootstrap, best practices around security, all that. All the things that you are used to on Ethereum will work on ZK stack. Three, I will argue in a second, I'll speak about it in a little bit more detail, but is today probably the most battle-tested of the layer 2 in terms of number of transactions and a few other metrics. Third and fourth together is modular and customizable. So you can use it pretty much however you want. There's very little amount of primitive. It's pretty much the only thing that you are kind of forced to use is the prover technology. Everything else, with a certain degree of technical effort, is going to be customizable. You can change the token that powers your system. You can remove a token that powers your system and use Ether in exchange. You can launch your ZK rollup as a layer 2. You can launch it at layer 3. You can launch 5 of them, some of them layer 2, some of them layer 3, feeding on top of your layer 2s. You can launch them in ZK rollup mode. You can launch them in Validium mode or in something we call ZK Porter. I'll speak about both of them in a second. And so it's highly customizable, and you can do with it pretty much whatever you want. And finally, we are trying to build it to be credibly neutral. We are fully committed to decentralization. Like all layer 2s, we are highly centralized to a degree that we are very uncomfortable with. And we are trying to do everything we can to change this. And it's a commitment that Alex made already a few times. I'm making it again today. We try to be the first to be fully decentralized. And if we're not the first, we'll be very happy because someone else is beating up to that. But this is a very important thing that everybody should be working on. Before going into the details, this is why we are doing it. Everything we do, so Meta Labs is not really a company, it's mostly a mission-driven group of people, and the mission is advancing personal freedom for all. Everything we do, we try to do it with this North Star in mind. Before, again, speaking in more detail about ZK Stack, a couple of points. So this is the first hyperchain that has been launched. It's been launched by us, and it's called Era. We launched it 5 months ago, and we are humbled, very, very thankful to the community because we have the largest number of daily active addresses. The sources is this great website called Grow the Pie that measures a bunch of metrics across all layer 2s. We are also #1 in terms of transaction, in terms of throughput. If you look at it on a daily basis, on a weekly basis, on a monthly basis, very often on a daily basis, we do more transaction than all the optimistic rollup combined. On a 30-day basis, we do almost as many transactions as Ethereum. So this is very good. Why am I saying this? Is not really to pat myself on the back. I think these are actually terrible results. So these numbers are all very, very small. If we want to get 1 billion people on chain, 10 TPS, 100 TPS, 200, 500, 1,000. These are all numbers that are very, very small. What we need is something that has multiple scale of magnitude more performance than what all of us can achieve today simultaneously. So why am I saying this is instead to prove another point, and is that ZK Stack today is the most battle-tested system that you can use if you want to build your own sovereign space. First of all, it has proofs. Proof that are working. Second, it has validity proof, which is widely accepted to be the future of scaling. But third, as I was trying to show you these graphs, it has had a huge amount of activity. It has a small life, but is in this just 5 months achieved a very, very high amount of activity that tested it very, very thoroughly. So what are some of the characteristics of the system and why we think it's interesting? And this is, you know, what did we build into ZK Stack that you think is going to be useful for you? There's a lot of things, but we will focus on 3. The first is what we want to give you, the developers, is the ability to offer magical UX to your users. At the moment, in crypto, we are well too enamored with the technology. We think what we do is an end in and of itself. It's great, it's beautiful. We kind of, you know, a lot of us like to figure out how to deal with private keys, what's involved in the risks. Majority of people in the world don't know and don't care, and they don't want to know. And so the solution is not trying to educate them. The solution is abstracting the blockchain-specific requirement and technology away. And this is what we mean with magical UX. The second thing is we need to have a system that is credible in trying to address limitless scale. Many solutions that are available today are an expansion of the scale of the system that we have been using until now. So blockchain technology, we have been used until now to something that is a supply constrained system. Ethereum is a good example. When there is something with product market fit, the price goes so high that eventually the product market fit is destroyed. And this is really not great. So blockchain until now are scaling like an island, where once you finish the space, prices go up. A lot of the scaling solutions that have been developed are like building skyscraper on the island or doing reclaiming land on near the island. These are extremely expensive things to do that have their own constraint that very quickly kick in. So for those of you that are going to Singapore, you will see you carpet bomb the island with skyscraper, and at some point the price skyrocket. I lived there 10 years. I can assure you it's very difficult to afford an apartment there. So the solution is not building skyscraper. The solution is shifting the paradigm away from what we are building is stuff on an island to we are renting servers from Google. So we need to move blockchain to scale like real estate on a physical place to scaling like a normal server. So you need something that scales with the amount of resources you have to throw at your constraining variable, which in our case is GPUs. The third thing that I would also encourage is to people, for people to think not about building your own system, full stop, but to build your own system as a part of a gigantic network of systems. So one thing we saw with the alternative layer 1 is a massive fragmentation of liquidity, of user, and fragmentation of utility in a network is terrible. No? Network utility for the user grows super linearly with the number of users. So a system with 100 users is worth much more than 10 systems with 10 users each. And so what we want is something that creates so few friction that if you have your own roll-up, your users think they're part of a gigantic network. A little bit more on this. So the first is Magic UX. Where is ZK Sync different? What is some of the things you may want to consider when you're choosing a system? So first of all, we are quite happy that the Ethereum community also joined on the bandwagon of account abstraction with 4337. It's great. We have been talking about it for 2 years, and I personally think is one of the necessary, not sufficient, but necessary condition to get 1 billion users on chain. Without this, we probably remain in the tens of millions of users maximum, because most people don't want to deal with private keys. The problem with 4337 is that it doesn't work with normal addresses. And so it requires a huge, gigantic migration from the tens of millions or hundreds of millions, as they say, MetaMask addresses onto these new addresses that need to be deployed and your user will need to migrate to in order for the feature that you implement with account abstraction to be easily usable by them. On ZK Sync, on ZK Stack, instead, native account abstraction is native, is embedded in the core functionality of the protocol. All the user can use it. If you activate gasless transaction immediately and without them having to do anything, all your user will be able to have gasless transaction. We think this is very, very important. No migration is required. When new feature in the future will be available, they will be available to everyone immediately. What are some of the features? I mean, people here will probably are already very familiar, but what we want to achieve with Magic US is total abstraction of private keys with social key recovery, spending rule, flexible validation, allow the creation of interesting use cases and simplify a lot the user experience of user. Multi-call, the ability to send one transaction and do 10 things rather than 10 transaction plus 10 approval is really important. Sessions, you can't build a game without session. Nobody will want to stop what they're doing, sign something, and then go back to what they're doing. And then we need to get rid of the gas. So dealing with the gas is unacceptable. When you switch on your air conditioning, you don't want to think about how much is the price of oil in US versus Dubai. That's not the point. And we need to make sure that everything supports gasless transaction, meta transaction, et cetera, et cetera. All of this is available as a base technology on ZK Sync. You can build it, integrate it however you want. Your user will immediately be able to use any of these things as soon as you switch them on. The second important thing is limitless scale. So this is a tweet, but there is a lot of tweets going on at the moment. One big problem of all the scaling solution is that as long as they are roll up, they have to post the data availability to Ethereum. And at the end of the day, this is constrained. It's the problem I was saying before of the skyscraper. Yes, you have more space, but it's not a lot more space. What does it mean? It means that we can boost the demand by 5x, 10x, 20x. It's just not gonna be enough. What's the solution to this problem is that you need to have recursive zero-knowledge proof that allow you to aggregate proof from multiple layers into a single proof. This makes, theoretically, the system scaling infinitely. You can have 1,000 hyperchain. Each of them produce a proof of their state. They send it to some intermediate layer, which we call layer aggregator. They will take all of this proof, create a new proof that is tiny, and then send this to Ethereum. You can aggregate 1, you can aggregate 1,000, you can aggregate 1,000,000 such chain. If each of these chain just make 100 TPS, which is what Era can already do today, then you have 100 million TPS, and it's technically feasible already today. What's the problem there, which is the other big thing, is that all of these hundreds of millions of transactions, all of the data availability, and all of this tries to go on Ethereum, and Ethereum can cope with, say, 200 of these transactions, if they're complex. If they're simple Ethereum transfers, yes, 4844, boost the block space a little bit more, but practically, if they're interesting transaction, like an Uniswap trade, you really can cram maybe between 100 and 200 of these in a single block, which is not fantastic per second, which is not fantastic. So what's the solution there? Being able to choose data availability policy that are not layer 1. ZK Stack is fully customizable. You can delegate your data availability to our own ZK Porter. You can use one of the many data availability service providers that are popping up every now and then, and they're all super interesting, and they have their own trade-offs. You can keep the data availability private, don't publish anywhere, but just publish the proof or publish it delayed, which also have interesting trade-off and could be interesting for some design. And you can, of course, build your own data availability service and just choose that and give it whatever properties your system need to have. This is very, very important, and both of these things can work on any ZK rollup that have a sufficiently advanced prover, but they work better if you have state difference. We think this is extremely important, and is not something that we have been communicated very widely and probably good enough to the general public. Most of the rollup out there have the full cold data landing on Ethereum, which is a choice and has also a trade-off with some benefits, but mostly we think is not the optimal choice. Only us and Starkware decided to instead post on-chain the state difference. What does it mean is that if there is 100 state changes in a block, we just take the final state, posted that to Ethereum, plus the proof that all the other intermediate states were valid. And so you don't really need to know what they are because they don't really matter to establish the validity of the entire system. What does this imply? It implies some form of compression of the cold data. If there is 1,000 users sending token to each other, this compression can be not very much, unless they send a lot of token to the same people all the time. But, for example, for an Oracle update, this compression is extremely, extremely important. If you update an Oracle once within a block, now you can update it how many times as you want, because the others are almost free. There is a cost for the proof that is infinitesimal as compared to data availability, but all the other updates are almost free. Some example why this is relevant. If you are a market maker and you're trading on anything, your risk model will tell you that you have a risk profile that is very high if your source of information is unpredictable in time and is very slow between each update. So if you have Oracle updates that are 5 to 20 minutes away, and this 5 to 20 minutes is not fixed, it can be 5, it can be 10, it can be 12, your risk model will tell you make very wide bid offer. on ZK Sync, you can make Oracle update every second. You can make it statistically stable. And what this means is that now the risk model of the market maker will tell them, you can now make very tight bid offer. Tight bid offer means lower slippage. Lower slippage means me and you, normal user that are trading in the system, will get a better user experience without having to do anything. Another good example where this is interesting is for anything that is pertaining lending. So if you're Aave, for example, you have an over-collateralization of X, 60%, and the risk that this over-collateralization is covering is the risk that the collateral jumps below the value of your loan before someone can liquidate it. And someone can liquidate it only after an Oracle update. So if the Oracle updates are 5 minutes away, and they move to be 1 second away, because this risk grows with volatility, because volatility grows with the square root of time, you have roughly square root of 300 times less risk, which is 17, which means that your over-collateralization can move from 60 to 4 safely without actually increasing the risk for the user, which in turn means that if you are a normal user like me that have his ETH stuck in Aave, I will get more yield. And I will do nothing at all in order to achieve this. And the other big important information is that it's going to be impossible for you to achieve the same level of yield for your user without increasing the risk or without having a big liquidity mining program to compensate for the delta between Aave deployed on a state-different system like ZK Sync or Starkware versus a non-state different different system. Another way to say the same thing, which is point number 2 here, is that what we have on chain is the output of the operation and not the input. Why this is important is because if you deal with zero-knowledge proof, the output is always very small. The important thing that we use is not really ZK, is the S of snarks, is the succinct property, the fact that the proofs are always very tiny. What this means in practice for you is that anything that has to do with zero-knowledge proof on a system that has a state difference will be fundamentally cheaper than everywhere else. So if you are working with a traditional finance enterprise, this is necessary. If you're working with a payment network, this is necessary. If you're working with a digital identity project, this is going to be very, very relevant. But also if you're working on a game, if you want to do Fog of War, if you want to do a poker game, all of this, any situation in which you don't want for the entire state of the system to be available when the players are doing something on chain, you will need privacy. In order to do privacy, you will need to be able to verify zero-knowledge proof, and this verification will be fundamentally and always cheaper in a place with state difference versus a place without state difference. And the final thing is ZK Porter. What this enabled, it enables an efficient method to have volition. Volition is a system in which within your layer, you have both ZK rollup user, the post data availability on chain, and ZK Porter user, the post data availability somewhere else. And this allows for the creation of something that is a black hole for liquidity. You don't have to fragment it. You can just create a differential system living in the same space, atomically composable with each other. And the final thing I wanted to kind of talk very quickly about is that while we give all of you the ability to create their own chain, every time you create your chain, you're separating yourself from the place that has network effect yesterday. And there is a potential competitive game there where you just assume that people will move from where they are to where you are, and you get the entire pie. But there is probably a better game that is that you can share, you can just become part of a bigger pie, and because of the super linear growth in utility of networks, this pie can be much, much bigger if you join it. The example here is, where do you want to live? You want to live 100 kilometers from New York, you want to live you want to set up your shop in Brooklyn or in Newark, or you want to set it up in central Manhattan, right? And there's going to be good reason to do either. This is an example, in the real world. This on the left, there is the city of Seoul. In every city we go, we change. But so a big city, it's like a general purpose ZK rollup. I live in Seoul. You can do anything you want here. But practically, there's a lot of congestion. If you try to take the subway on Friday, they have to push you in. If you try to go to a nice place where other people want to go, you have to book a month in advance. There are alternatives. There are app-specific rollup, like Disneyland, or in Seoul, it would be Legoland in Chungcheong, right? So you can go there because they are designed to offer a perfect experience, say, for your children. The problem is that you go there if they are an hour away, 2 hours away from where you live, and you likely are not going to live in your Disney. You're likely going to live in a general purpose place most of the time. But you're not going to go there if they're in the middle of the desert. And you're not going to go there for just a restaurant. So you're not going to travel 3 hours to go to a restaurant. It's very, very unlikely. So what you need is a system that is designed with this in mind and is designed to be able to provide very, very fast, very, very cheap communication channel across all the layers so that when you create your own layer, you can make it custom made like Euro Disney, but it's as if it was in central Manhattan. Now you have the maximum amount of demand from the user base that is living in the general purpose chain, but can use your system immediately as soon as they want high performance, high compute, special access to big chunk of liquidity, et cetera, et cetera. How does it work? It relies on a bunch of technologies. One of them is that all our systems share the prover. So share the same circuit, which means that any proof that is generated anywhere in the topology is as if it was generated in your layer, so you can immediately trust it. The second is the bottom here is share a bridge, if you want, with the rest of the ecosystem, which means that when you transfer assets from one hyperchain to another, it's going to be very, very cheap. The third is you can also share something we call layer aggregator that allow you to aggregate your proof with others and make them all also very, very cheap. But the output is that you now have this many-to-many communication channel that allow you to do something like the following. You can live in your chain. Through multi-call and account abstraction, you can sign a single transaction that say, move my money onto a lending specialized chain, borrow something, then send it into another, swap a specialized chain, swap it with something else that I need in order to stake in a third chain, and give me back the result. You will be waiting a very small amount of time, in minutes. So basically every step will require one confirmation. We are shrinking the time for this confirmation very, very fast. And it will be very cheap. It will require essentially one transaction, and the UX will be great because it requires only one transaction that will encapsulate all of the other. The analogy here is a little bit like the email. What you want is to send an email to marco@metalabs.dev, and you don't really want to know exactly in which server our email exists or what's going on in the background. You just need to do that, and I need to receive the email and maybe send you back something. All of this is about to be released, but all the hyperchain that are developed today already share the bridge, and so they will be fully compatible with the entire system once it's ready, which we expect to be before the end of the year. So to leave you, when you choose a stack to deploy your sovereign chain, my suggestion is to choose a stack that is ready for you. We think ZK Stack is ready, well, first and foremost, because it's available, and it's the only one that is fully available at the moment, one of the very few one. Most of the other has some form of limitation in the license or some requirement in terms of payment. We are the only one that are free and fully open source. And the second, a system that is ready. We have been doing more transactions than anybody else, which is really the test that you want to see, that the system that you're choosing is capable of doing and performing. Point number two, you want to get close to a system that has already achieved some form of network effect. And depending on the metric you choose, we have the largest number of addresses, the largest amount of transaction. We are the third in terms of TVL. And this is achieved over just 5 months. And there are other systems that have been around for much longer that didn't get to the same point. So it's a good place to get close. And the third is you have to choose the trade-off. Every time you choose a system, you will probably get a set of benefits, and all the other players in the area are all super smart, are advancing the industry very much, and they all will have their own superpowers. We think these are the superpowers you may want to consider. You want a system that allows you to offer magical UX. You want a system that is credible when it says that it can achieve any amount of scale. It's going to be expensive to achieve that amount of scale, but you're going to be able to afford it through the fees that the demand of your user will give you. And three, you want a system that is designed to allow interconnectivity with other chains that are building using the same technology. And I'll stop here, and if there are any questions, happy to answer or to pass the microphone to the next speaker. So yeah, so there is a lot of this stuff is already ready. So Paymaster, for example, is fully implemented, and we didn't implement our own on purpose because we wanted, because otherwise, you get lock-in effect. If we build our own, then people use ours and they don't innovate. But the general purpose Paymaster broad framework is available. There is one that is either live or about to be live from 1inch that allow just you to pay in whatever, and they will convert it into Ether, which is what we as validator receive today. But there will be a very interesting one where it's a little bit like the credit card experience in some country where I go and rather than pay immediately, I pay in credit, for example, and I mint DAI if I have, say, some collateral somewhere, I mint it live on the fly, DAI are used to pay, are converted into Ether, blah, 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 and I end up with a loan in Ethereum, for example. We have been discussing with some large payment network to integrate something with, say, Visa, where you swipe your credit card, you prepay $100, and then you pay whatever for a month or two until you finish this credit. So all of these things are, the technology is already ready, and there is a bunch of people that are building this thing up. There is a new wallet called Clave that we have been working with very closely. Argent, before, now focusing much more on Starknet, they built the full stack for Argent wallet, which is available already. So you have social key recovery, you have a bunch of things. So some example are already there, and of course, people are adopting it with a reasonable speed.
Can you just go maybe into a bit more detail about the app-specific rollups and the messaging between those and how that all works?
So saying in advance that I'm on the business side, and so some of the tech may be not very clear. So one thing I will say is, and maybe, I don't know if there's a way for us to communicate after this, but there is a great talk from a smarter colleague called Kalman at ETCC, where he's explaining exactly how messages work and are cryptographically secure. But the idea is you can emit a state into any of these chains, and because the state comes with validity proof, you can then rely manually to any of the other chain, and the other chain know that this eventually will percolate down to the common root, and so they can start to take action on this instruction immediately. So what we are building is this relayer network that takes messages plus proof from anywhere and send it everywhere else. And once you have this in place, then you can now rely on a very fast general messaging system. That comes with validity proof and so is immediately useful. No? So as compared to a typical messaging system, or some of the messaging systems that have been developed before that instead rely on an optimistic approach where if no one challenges the invalidity of the message for 30 minutes, etc. So this means it's very, very fast. The other important thing is that all of this happens and the verification are done on ZK Stack. And because they are done using the output, they're very, very cheap. So all of the verification of these messages can be done for pennies. When we verify our own proof on Ethereum, it costs $500,000 to $1 million gas. No? So that's still, if you have 1 million transactions inside, it doesn't matter, possibly, but you need to get there. Now you have this attrition at the beginning that can stop adoption. The good thing is that instead, all of this communication is verified within the ZK stack, and so it's already verified in a system that looks at output, and they're already tiny. So verification of this proof will be very, very cheap. The other bits and pieces that are interesting, you can share a bridge between hyperchains. So depending on what this message is doing, this may or may not be relevant, but say if the message is used as a bridge, a good bridge is, so today bridges are very scary, And essentially what happens is I send you stuff here, you verify that it's true, and you send me stuff there. And okay, it's so-so, right? A better way would be I have an immutable smart contract here, I send stuff to that, it burns it, gives me a receipt, I move the receipt somewhere else, I send it to another smart contract to mint the asset there. And this is liquidity-less, it's infinitely liquidity efficient, and potentially is very, very fast if it comes with validity proof. But there is a problem, is if you live in a layer 3 on top of ERA, now this is also very cheap because the assets really don't move. We are still using this word bridge, but for layer 2, for ZK Rollup at least, the bridge is a misnomer. No, really the assets are living on layer 1. They are living on Ethereum. They are never moving. It's not really a bridge. They don't go anywhere else. It's just like a container more than a bridge. The problem with, if you deploy ZK Stack as a layer 2, is that it's like if you invest in wine. If you invest in wine and you have it in your warehouse, if you sell it to me, if I'm happy with your warehouse, it's cheap, but if you have to send it to my warehouse, you have to load it on a truck and send it, and that's not great. By sharing the bridge is like sharing the warehouse. And the third layer, these are all optional. You can decide to use it when you deploy the system, or you can decide to not use it. The third is this layer aggregator that takes the proof coming from everywhere, through recursive zero knowledge, creates a new proof that is then a summary of the other proof. And this is just a nice tool that scales nicely. Now, if there are 3 people that opt in, the final cost of verification is 1/3. If there is 100, is 100. Why this is kind of important is that ZK rollup are great in many ways, but they have a bunch of problems. One of them is that they're a little bit like a Formula 1 car. No? If you go at 50 kilometers per hour in a Formula 1 car, it doesn't grip very well. Actually grips less than like a Panda. No? It's really bad. Once you go to whatever, 200 kilometers per hour, the lift on the back will make it a great car. We have a kind of the same problem, that there is this fixed cost of verification for the witness on layer 1, and so if you have a few transactions, it's expensive. By using the layer aggregator, instead you don't. So when you join the system later, you don't have to bootstrap this minimum amount of demand to go fast enough. You will just jump on it. There's already another 100 hyperchain there. So now your proof is infinitesimal. No, instead of 500,000 gas, is 500 gas. And so who cares? Even the very first 10 user will already have a reasonably good experience once you are, at 0.5 TPS. Essentially, this is 0 from the point of view of the final user. So these are the bits and pieces that compose this very fast, very cheap, and cryptographically secure messaging system across the chain. Okay, thank you.
Thank you for sharing the insight. And now we finish all of the presentation today. So there's a dinner on the second floor. You can enjoy and you can feel free to bring your food. Okay, thank you.
담당하시는 분이 있어서 그분한테 여쭤보고 바로 한다고 하는데